California.
Welcome, everyone. How are you enjoying Cisco Live so far? Everybody having a good time? Good morning.
Good morning.
First session of the day. We're all here ready to get started. Excited to see you all for the era of accelerated reskilling. Here's our agenda. Just quickly, what we're going to do is talk about how we got started, some of the critical components that are included in the work that we've done, community center. Remember that word community. We're going to talk about that a lot. It was critical to everything that we were doing. Our internal expertise, our subject matter experts, novel by nature, how this came together organically as we were working on it and things were progressing. And then how can you start? How can you do what we are doing now and start strong? We'll give you those component pieces. And lastly, of course, we'll end with questions. I actually have some questions for you, and I hope you'll have some questions for us as well. I'm Susan Mintz, Dr. Susan Mintz. I have a PhD in educational psychology, and I'm the leader at Cisco. I've been there for 17 years. I'm the leader at Cisco for technical skills training globally, internal facing. And I have with me the incomparable futurist, visionary, global AI architect, Annie Hardy.
Thank you, Susan. We are excited to be here. I'm a qualitative futurist, and a big part of my job is chasing signals and finding patterns evolving over time. So AI is changing your job, your company, the world. Everyone knows it. This is something that's happening. A lot of people are bored by AI already. They're like, oh my gosh, we don't have that much AI. Everybody at Cisco Live is talking about AI. I can't even do AI. The fact is that it is still coming because we are in the second half of the fourth industrial revolution. So when we look at this is a DIKW pyramid. It specifies kind of the role of computation and technology related to data and what is happening with data when it comes to what computers do. So in the first half of the fourth industrial revolution, computers took over data and information tasks. It processed the data and it gathered information based on the data and presented us with information. So then what happened was we then became the knowledge workers. So if you've heard of the term knowledge workers, that's who we are, and that comes from the DIKW pyramid, knowledge workers. However, artificial intelligence is taking over, partly taking over the layer of knowledge work. It's taking over knowledge tasks. This is where we are right now. We have some of the knowledge tasks historically we've done that AI is taking some of those tasks from us. We actually studied what that looks like, what the impact looks like by conducting research, doing a report called the Transformational Opportunity of AI on ICT jobs. We looked at like 70 jobs in information and communications technology. And if you're curious about what the report says, you can read the report. There's an executive summary or there's a massive one, or you can go to Notebook LM, upload the 300-page report, and listen to this.
Okay, so you know how sometimes you find yourself down these rabbit holes late at night, like suddenly you just have to know everything about how AI is changing the job market? Well, think of this deep dive as like your shortcut. We are diving deep into how AI is shaking things up for those of us in the world of ICT. And trust me, it's way more exciting than just robots taking our jobs. We actually got our hands on this brand new report, like it just came out in July.
So just FYI, it's completely AI generated. I went to Notebook LM on Google. I uploaded the 300-page report. I clicked create a podcast. And what it did is it has two separate voices that have reviewed and synthesized all of the information, created a 40-minute podcast out of it, and I can pop that on my phone and go jogging instead of sitting down and reading this 300-page report. If your company is still talking about and believing that ChatGPT is the future of AI, that is not the future of AI. The future of AI is synthesis. It is simplification.
Okay,
AI
so
does a lot of things. And it's going to have a moderate to high impact on almost every job in your company. You'll see right here, the only one of the ICT jobs that's not going to have at least a moderate transformation of 100% is infrastructure and operations. So we still have hands on hardware, rock and roll. But even hands-on hardware, are going to have to shift and adopt. When you look at the report, you'll see more about the details, and I'll give you a QR code that you can use to access the report and the findings within it. We also conducted research and pulled together the Cisco AI Readiness Index. Now, in the index, what we did was we asked customers like you, okay, so where are you? Where are you in AI? Are you in skills training? How do you think it's going to impact you? And what we found was that 93%, this is not a surprise, 93% of respondents predicted the workload of their organization's infrastructure will increase with the deployment of AI-powered technologies. Not a surprise. Everybody's talking GPUs, not a shock, right? 59% said they have a maximum of 1 year to implement their AI strategy or they're going to lose competitive advantage. That's a lot, but guess what else? Less than half say they're even just moderately well-resourced from a talent perspective to pull that off. 93% say it's going to change. 58% say they're going to lose if they don't do it in a year, and yet, how many people don't have the talent? A lot of them. So how do we address this era of reskilling? And how did I address this era of reskilling? Because I am a global architect, I am a futurist. How did I do it? The first thing I did was I actually pulled people together. We have a lot of WebEx rooms and a lot of WebEx spaces. And I saw people talking about artificial intelligence. And I wanted to cultivate and foster that community. There's a lot of shadow AI. Are you seeing shadow AI in your organizations already? People who are spinning up ChatGPT on company infrastructure, people who are like, I'm going to API this, I'm going to pull this data into that, pull this GPT, I'm going to summarize these documents, marketers who are using diffusion models to create images without really knowing the ethical sources, people who don't know how to prompt, Samsung losing company secrets. Any of this sound familiar? This is happening, it's rampant. And so what I wanted to do is I said, I'm really concerned about the risk here. I see the risk. I'm going to pull everybody together. I'm going to put a room together so we can start to raise visibility of seeing what's actually going on. We're going to open a forum so people can talk about what they're doing. And it's not only our technologists in that forum, it's our legal people in the forum. It's our infrastructure people in the forum. It's our people, our human resources people in the forum. Everybody now has insight, and our responsible AI team, our AI impact team. Everybody now has visibility into what's happening in the company. And everybody has visibility into the people who are doing awesome stuff. And that's what leads me to what happened next. It began with this community. It began with just a WebEx space. Now we have 4,400 people in that WebEx space. It's really massive. That's a lot of people. But it changed from that. It began as this community-led, just like fandom of AI. And then Susan came into the picture. I'm the movement builder. She is the senior learning expert.
Isn't she a dynamic speaker? I'm so interested in what she has to say. I almost forgot what I was going to say. So I'm a learning expert. Nothing's happening. Okay. When I was a child, I can just remember every day getting into the big blue corduroy chair in the living room and reading and learning and reading and learning. You could hand me anything. Honestly, my favorite book was my algebra book, and it was the only book that I was disappointed when it ended. You could hand me anything and I would enjoy it. As a young adult, I started thinking, why am I so bored? I would do something, I would get good at it, I'd get bored, I'd move on, get bored, move on, get bored, move on. As a middle-aged adult, I thought, well, everybody else has a passion. I have a brother that's a lawyer, 2 brothers that are teachers, a mother who's a social worker, but I can't get fixated on anything. And I was so bored, I started thinking, what if? What if I did something this way instead of that way? I don't want to do it the way everybody else is doing it. What if I look at it through a different lens and turn it upside down, turn it sideways, and come out with something different? And then as an older adult, I finally realized who I was. I'm an inventor, I'm a disruptor, I'm a creator, and this was the perfect age for me of AI where I could start looking at things in a different way and implement new learning strategies. And that's the approach that we took as we move forward. So how can you equip your workers today? We're going to show you how. But first we're going to talk about how did we do it when we started out in 2023. Meeting the moment. How many of you all here are curious, excited, passionate, maybe a little bit fearful about AI? Raise your hand. A little bit of trepidation there. Well, we can relate to that. We were the same way, and we still are. But we use that to drive our momentum. Our curiosity drove our listening. So as Annie mentioned, we had this WebEx space that she set up. And right now we have about 4,500 people in it. We've got so many people in it that Annie's had to set up separate topical spaces so that we continue to have the conversation. And we listened to what everybody was saying. People were pouring in with their thoughts, their ideas, articles. There's an article by this one, there's an article by that one. That started driving excitement and forcing us to connect. So we set up these connection spaces and we were talking to each other, and I met Annie. Annie was doing a talk, and I reached out to her and I said, hey, I can give you a big microphone. I have a series that I'm running at Cisco, a Tech Talk series. Let me give you a big microphone. And Annie's session still to date has had the largest amount of attendees. It was 1,000 people at one time listening to Annie, and we've had thousands since listening to the recording. We've also refreshed it. So she's done a 2025 version. We connected, then as Annie said earlier, she built community. She connected me to Daryl. Daryl connected me to Gaurav. Gaurav connected me to Victor. Victor connected me to Lisa in legal, and we started moving forward and planning. Because of our passion, we also built partnerships. We started working very closely together across different functions. We weren't even on the same team, but it didn't matter. We built our own team and started moving forward on the AI journey. Our fear represented to me an opportunity to educate. Again, I'm an educator. When I'm fearful about anything in my life, the one thing that I've always been able to lean on is going out and getting information and teaching myself so that I have the tools to deal with it. And it helps take that edge off, but that fearfulness is a good thing because it drives you forward. Let's go through our trajectory quickly. Annie did her first Gen AI presentation in February of 2023, shortly after OpenAI dropped GPT-4. Annie launched the Gen AI Explorers space. We did the Tech Talk. Our teams started coming together, all those connections, all those partnerships. We formed a core team and started working together and planning how are we going to educate 86,000 people globally, all our full-time employees, and keep in mind that AI is the first technology in my mind that truly crosses over. Think about your non-technical folks. How are they going to survive in this era if they're not learning something about AI, even if it's prompting? There are techniques around prompting. There are things that they can learn to do. They need to take on these new skills. We then launched the Green Belt. This was our first badge. It's a learning pathway, and what this was aimed at was for the non-technical and the technical audience. We were looking for literacy so that everyone could get the fundamental knowledge that they needed in order to function in an AI era, this fourth industrial revolution. We had a Cisco Illuminate event. Illuminate event is our 365-day educational event. And we had an AI track that launched. It was G2 Patel speaking with Andrew Ng. Does everybody know who Andrew Ng is? Does anybody know who Andrew Ng is? Andrew Ng is the co-founder of Coursera. He's also the founder of deeplearning.ai. Also, two places, by the way, that you can get really good content. I've taken some of it myself. I'll talk about that in just a moment. We launched an AI Fundamentals badge. This is also meant for literacy for non-technical and technical. Talks about machine learning, deep learning, algorithms, just so people are literate and know how to move forward in the Gen AI space. You still have to have some of that predictive modeling training in your background. And by the way, AI didn't just come out in training at 2024. We've been doing AI all along. AI's been around for years, right? It isn't new, but it kind of was behind the scenes. It wasn't in the forefront the way it is today. It was just kind of humming along in the background. Then we created the Gen AI Blue Belt. The Blue Belt was fundamental as well, but for practitioners. So this is where we start talking about our tools. We start talking about LLMs. We start talking about fine-tuning, any number of things in there to set practitioners up for success. This is where we reached over 4,000 members. As I said, we've got over 4,500 now. And then we came up with the Gen AI Black Belt. This is a different black belt than the one that Annie's going to talk about. Annie's going to talk about the one that's for partners. This is the internal one. It's a very high bar. It's for advanced practitioners. There's instructor-led, there's digital learning, and then you have to enroll for the exam. And we kind of modeled this after CCIE. So we have our distinguished engineers, our principal engineers, and our technical leaders who are involved in this. And people come in and take the exam, and then we expect a lot more from them than to go out and be technically skilled, which they need to be. They need to build a model, deploy a model, have users, have metrics, but we expect them to really be the leaders in this space. So they have to show up in leadership, mentoring. They have mentees. They're developing content. They're delivering content. They're going outside of Cisco and doing technical presentations. They are publishing technical papers. So we have very high expectations of these folks. Setting a strong foundation. So there are some things that we always kept in the back of our minds as we were moving forward. One of them is developing trust and growth. We knew that we weren't going to get very far with our audience if they didn't trust us, if they didn't believe in what we were doing or understand what we were doing. So when we think about trust, the things that I started thinking about were relevancy, credibility, inclusivity. So what I mean by that is that our content had to be good. It had to be fresh. Gen AI is changing so rapidly. It's not the kind of training content that you can put out there and go, okay, I'm done. I did it. It's out here. Every quarter, we go back and look at the content and we refresh it. We re-record. We get rid of old content. We add new content. It's changing at the speed of light. We can't sit on our laurels. Again, our non-technical audience. These folks are thinking, where's my space in the future in this company? How am I going to continue to work here? Is it going to be taken over? So we need to and needed to give them that space. We created a prompting for everyone pathway, and we started doing presentations on techniques, prompting techniques, and reminded them, at least now, today, while we're still in the era of ANI, though we're quickly moving towards AGI if agentic is to be believed. In this era of ANI, there's human in the loop, human first, human last. I don't know if you all are familiar with that, but that's key. AI right now, today, is a tool, and the human needs to be invested in it. Cisco hired people for their expertise, for their knowledge, for their brains, for their know-how. If you take what you get out of a ChatGPT tool and go, okay, I'm done, you may as well have just signed your job away at this point. So we reassured our non-technical folks that they are a very big part of the AI movement. Building resiliency. So one of the things that I always keep in the back of my mind, frankly, is psychological safety. So one of the things that you need to do is in these spaces have the room and the space to make mistakes, to say silly things, to come up with ideas that may fail. But when you think of that failed idea, it may generate or trigger another idea for someone else that will propel us forward. And in that space, you can be safe. You move faster together when you are comfortable with being able to say whatever's on your mind. And we've seen lots of that. Business and social impact. Chuck said a couple of years ago, Cisco's going to be a positive force in the world with AI. That's our principle. We're going to, the Hippocratic Oath, do no harm. It doesn't just apply in the medical field. There are a lot of things that can go wrong with AI, and that's why we have our AI governance team, who also monitors the work that we're doing to make sure that we're being transparent, that we're doing no harm, that we're working with integrity. I'm going to show you some of the classes that we've put together in our pathways. The first one starting with Annie's generative AI talk that she did for us. These classes we put together in a very different way than we had done in the past. Often you go to third-party vendors. Because of our guardrails, it was very important to us that we had the Cisco context and that we had people speaking with us that could relate to the projects that were going on, the products that we have at Cisco. And we got our SMEs involved. Annie talked about our SMEs earlier. I'm mentioning our subject matter experts that we were partnering with. And these folks took the time, the energy, and the effort because of their own passion in the topic to do recordings, to do instructor-led classes. We did 20-minute sessions. We did 40-minute sessions. Unless it was on a hands-on lab, then it may have been 3 hours, 6 hours, because you need to be able to come out of that with something that you can actually do. Not just understand what it is, but actually move forward and do it. We put together podcasts. Annie mentioned Notebook LM. That's such a fun tool. I did a podcast myself. It's a great way to learn. But we also did fireside chats. We did panels. We decided people can learn in a number of different ways. It doesn't have to be the same old formula. AI is different. We wanted our learning to be different as well. And we continue to invest in what's the new way to stay up to date and current with our learners who are evolving just like our technology is. So where can you start? Let's talk about the building blocks. If you haven't already, create an open culture similar to the one that we've been talking about. We had someone in our session on Monday that said to us, we have engineers in our company, they don't believe in AI. How do we get them invested? How do we get them started? Another one came forward in a chat yesterday and said they just think it's the next big thing. Why should we bother moving away from the project that we're working on now when something else is going to come along in a couple of months? So this is what I will say. Start out by developing an AI learning strategy. Have an AI strategy, first of all. Talk to your leadership and get a strategy put in place. Then you can formulate a learning strategy. But I will also say, how many of you think that AI is just a flash? Anybody? Does anybody here think that it's just the next big thing? I'm so happy to see that. So when you ping me later, I'm going to remind you of this conversation. But in any case, you know, what's happening now may be hot, and I agree with that. And there may be another hot thing. Technology is that way. There's always going to be an emerging technology that's coming forward, but AI is not going anywhere. It's going to be here. It's going to be embedded, as I mentioned earlier. Are we on the cusp of AGI with agentic? Entirely possible. Partner with legal. Again, we work with our AI governance team, and they guide us. I'm going to talk about tool usage in a minute, but I'll bring it up here. And that is, they will look at the tools that we can use. We have a very small list, by the way. They look at the tools that we can use. They tell us the tools we can use. They tell us the tools we don't need to worry about. And they tell us the tools we absolutely cannot. But what I will say here is when you are working with your tools, be mindful of your data. Make sure you're putting in your data in something that you can trust and that isn't going to go out to the world. DeepSeek. Anyway, just be careful what you're doing. Again, find your internal SMEs. You probably have them and don't even realize it. So there's always subject matter experts, and I'll tell you why. Because people are so fascinated by this space, they become experts. I'll give you a good story. We have a non-technical person that was in product marketing, newer to the industry, newer to engineering. He went through the green belt. He went through the blue belt. He got so taken with it. He's now producing his own YouTubes on highly complex AI topics. I'm fascinated by these stories, and we have several of them as we move forward, and we're going to have more, and I couldn't be prouder of our folks. Work with a learning professional. Again, our learners are evolving. Our learners are changing, and we need to, as learning professionals, change with them. Somehow trigger that intrinsic motivation, that personal agency that keeps them engaged and involved in moving forward. Because if you can't do that, you've already lost them. Build trust. Again, work with them, be relevant, be credible, have high quality content that they can rely on, and that they know that they can come to you and get what they need. Annie.
Okay. So a lot of people say, where can we start? But others say, what resources do we have? So Cisco does have resources. The first one, this is the ICT report I mentioned. It's a PDF, and if you go to this QR code, you just look for it, find it. There's actually a button that says Access Training Recommendations with free courses. So you can click free Access Training Recommendations, and this is not only for your engineers, this also is like people in marketing, people in project management, people in sales and business roles. So I highly recommend you can get that, share it with your team as a free resource. Next is we actually have a specialization now for partners. So if you are part of our partner community, we have a specialization for artificial intelligence. We have 2 different tracks, one for sales, one for pre-sales engineers, and we're going to be adding more. More will be announced. We want to equip our partners with understanding it. I'm also in it, so you'll see my little short hair. I'm pretty excited to be actually in that training. That's an Easter egg that you can look for. But what is not here, and I have a QR code here, is yesterday they announced that there is a 33 hours and 34 CUs, like continuing education credits, for free right now for the next 6 weeks on Cisco U, focused on AI-ready infrastructure. So if you have people who need continuing education credits for their CCNP, CCNA, CCIE, or CCDE that are focused on AI, I have a QR code because that is brand new, announced yesterday, and you can send it to your team. You could also search on Cisco U for AI infrastructure, and you will see the training. And I'm sure there's lots of people around here that are happy to talk with you about it. But we do want to make sure that you're equipped. We've worked AI into every single certification we have. We now have AI employed in every single certification. We're super excited. We're excited. We want to equip you and enable you. We've been doing it for a really long time. And on that note, we want you to keep the conversation going. We're actually going to be in the mobile app. You can use the mobile app to speak to us. I'm not sure, is there?
Not yet, but we'll look into it and make sure.
All right, we're going to be up here. How about that?
Yeah.
I'll put my badge back on. You can see my email address. We also have surveys. Really important. If you like this session, you want to hear more, like this session, we need you to tell them that. If you didn't like this session and you want us to improve, also, really want to know that. We cannot get better if you do not let us know. But we do want to know what you like, and you could win a cute little bicycle t-shirt. I have been run over by almost 20 bicycles. And then also, visit the Cisco Showcase. Susan and I are available for Meet the Engineer meetings today and tomorrow, so please check that out, book one. And I think that's it. Grab a snapshot if you want to have any other questions, and we'll be up here.
Yeah, please grab our emails, by the way. If you want to reach out, we're happy to have a chat anytime.
That's awesome. Are there any questions that you all have that we can answer right now? Or any thoughts? Anything that you all are dealing with that other people might be able to benefit from?
Thank you for coming.
Hold on. Martin,
we loved having you. Oh, sorry. Question?
Did you have one? Oh, okay, got it.
Loved having you. Please do reach out to us and enjoy Cisco Live.
Thank you.
Thanks, everybody.
Well, welcome everyone to the session today. I'm so excited that you are all here. My name is Shannon Wu, and I lead the employee tech development organization that's part of Learn and Growth. Although Dr. LT couldn't make it today, her message, leadership, and executive board experience will resonate throughout the session. So how many of you are feeling the energy, the excitement across the hall, the technology, the innovation, the connection you're making here as well? I believe you're in the right place. Your insight and talent are helping shaping, making the decision and produce an impact for your organization. Today, we're going to talk about leading, but as well as how to nurture your leadership skills. In the AI age, as well as holistically, how we embrace the rapidly evolving workforce today. Now, if I may, start with a simple question. What is the biggest leadership challenge you are facing today? Is it the AI impact and ethical consideration? Or the workforce transformation? Or the data and privacy and security? What else? By no means, this is not an exclusive list. If you start voting, you can say share, but I'm interested to hear all those, select others as well. Workforce transformation is popping up across. Good? So maybe you're all still getting dialed in. Getting a sense of where you are, the current state. These are all critical elements to go through. Now let me start with sharing a couple stats today, based on the Future of Jobs report provided by World Economic Forum. 42% of our business tasks will be automated by 2027. That's less than 2 years away. I'm talking about business tasks, not jobs. 42%. Imagine the time you and your team will have more on innovation, creating solution for your customers. That's 12,000 seconds per day. I know some of you are probably thinking, hey, I can probably put in an extra walk as well. Yes? And lots of things, right? Sometimes you could attend a 90-minute meeting. Well, perhaps you can do it in 5 minutes. I'm not saying the connection is not important. The connection is so important, but we can be more intentional how you spend your time. Hey, WebEx Assist already help you summarize it. The ones that you can get the insights from, right? Now Cisco, along with 8 tech companies, specifically in the ICT tech job perspective, we conducted an AI-enabled ICT workforce consortium. It's showing that 92% of job will be augmented. The good news is, if you haven't checked it out already, do check it out. There's great resources that help you understand how the different jobs will be impacted, and what are the skills required to help you to be successful. Now, on the other end of the spectrum, based on the Work Trend Index report provided by Microsoft and LinkedIn, showing that only 25% of companies are providing GAI training. Can you raise your hand if your company currently providing training, development? I see a few. Great, you're ahead. Those haven't started, this is the time. Now let me start with sharing a little bit about journey of Cisco and AI transformation, especially as it relates to workforce transformation. At the onset of ChatGPT, there's a group of individuals that are super excited. They can't wait to create a new app, check it out, even try to jailbreak. I know some of you are in this room. They're the early adopters. They start with bringing folks along. bring the skeptics too. Create a dynamic, the conversation on what is the best practice? What is the possibility? Let them see the possibility. And yes, there's a lot of excitement. Now, at the same time, so I just want to mention that creates the multiplier effect as we continue to bring in and have that community. At the same time, Cisco also created a GAI governance office. Ensure that we use the data safely and securely. We also have the principles, responsible AI principles, that ensure that we consider all aspects of work, whether it's privacy, fairness, responsibility, whatnot. And with this whole ecosystem of support, what we find is employee leaned in. 33% of employees already active, taking development in GAI space. Hey, guess what? 20% even obtain a certificate, certification, and badges, embedding that in their workflow. This year alone, 75% growth. It's accelerating. And that is exciting. Now, where we're going is that critical mass impact. You think about it, 20% creates a movement. This is beyond that. And then what we're thinking now is how we meet the learner where they're at, bring it to them. We can think about different personas of individual. How can we have the experiential experience, as well as ensuring that they embed in their workflow and how they do things, how they learn, and how we are leading. Leader play a significant role in this. Look at that ignite. You spark the excitement, the innovation for your team. Having the conversation, allow individuals to reflect on what it means and activate. That's when the motion starts. And know that this is a triangle shape because technologies is accelerating so fast, we need to continue to iterate. It doesn't stop now. So how do you build a culture? We need to have a strong purpose. Especially in the AI age, we need to think about how we leverage the system and tools to ensure that we create innovation as well as enhancing the engagement with our employees and the entire workforce. Maya Angelou said, people may not remember what you said, but how you make them feel. When we think about AI, we need to remember human in the loop, whether it is how we personally as a leader leverage the AI, or how we drive adoption of AI of our workforce, or how the team is leveraging, collaborating together. If we always remember human in the loop, you will bring people along. A great leader, a leader, need to build trust. If you have trust, the people's trust, they will follow your direction. They will even go above and beyond. Yes. If you can ignite and inspire someone to dream more, to do more, to learn more, and become more, you are the leader, said John Adams. It is about raising the bar and reaching, unlocking that potential. Now, great leaders, all great leaders cannot lead alone. How do you bring the organization together? How can you inspire everyone to have that single purpose, much like an orchestra? Every musician, every chair need to be expert at what they do, but at the same time, they collaborate, they listen to each other, and they follow that single purpose. And that's when the magic happens. You all sing a symphony. When you see that music, that everyone sing the same song. Now at Cisco, we believe leadership is everyone's responsibility. You start with leading yourself, much like putting on the oxygen mask. You have that curiosity. Then you lead your team and your organization. Remember, in the age of AI, everything you do, when we're leveraging a system and tools, you always think about what that means. How can I support the greater good? What is my purpose? When you lead teams, at Cisco, we have Teaming with AI initiative that helps support individuals to get more hands-on experience with it. It's a place to try, but to find actual results and generate that insight and share that with others. The team I'm leading, AI DreamWorks, comes from cross-functional organization, from finance to onboarding, learning, certification team, all come together, having fun and driving innovation. Within a short period of time, we created a chatbot that improved the experience. And we even look at creating a robust library, a prompt library, that can be leveraged and improved and shared with others. And it's through that drive that we can show results and bring the organization together. One additional example, the finance team already leveraging additional chat and the library of a rich, complex automation approach to improve the result. And there's so much opportunity there. Now you may ask, so how do we drive this huge transformation in the accelerated speed? It all starts from the foundation. Develop how you equip your workforce with the skill sets they need. A Accenture report shared that by people leading focused approach, there's an opportunity of 10 trillion economic value there. 10 trillion, that's with a T, not with a B. So imagine that opportunity out there for you to unlock. Always leading. When you lead, not just lead, you also need to listen. Listen to their team. Where are they at? How can you help them? And this is a two-way engagement that you help. How are you feeling right now? There are research showing that if you miss that engagement with your enterprise, that also going to cost you $8.9 trillion due to global GBT loss due to low engagement. And that's a bit scary. But on the contrary, if you have the high engagement, it can create result, 25% of profit increase. Yes. Now when it comes to, you all say, hey, changes take time. But if you make the change, if you start the development now, you will see the result immediately. It's about fostering a growth culture that continue that development. I'll share with you one example at Cisco, the Catalyst engineering team. Thousands of engineers across the globe come together. How do they develop the strong culture? It is through a series of journey, from learning day, development day, learning about cross-functional technology that allow you to innovate more. Then follow 4 months later, they have a Hack AI-thon. And that leading is from top to all the way to the exec, all the way to the interns. And what is the result of the Hack AI-thon? 15% of the result was able to be delivered to the customer, improving the result. Now, what do you see in this series of pictures? Can you share? Any one of you? Energy? What else? What is a hub in that holds it all? You're thinking? Well, picking these pictures because, hey, we're in Amsterdam. It resonates with you, don't you? A little bit? Now, great. What is the AI effect? It's turbocharging this super win right now. If you have the right leadership leading, and harnessing across the different pillars, you will be able to harness this power and drive beyond the horizon. Here's the opportunity. Set your vision. What is the goal? How are you going to help the customer? How are you going to create the result? What problem are you solving? Leveraging the technology to push the boundary. Communicate. I talked about that. Communicate. Continue to share that insight that you are seeing. And of course, performance matter. If you just have a vision without result, that's not it. So you need to provide the result. Continue that growth. And all this is anchored around the ethical AI. Now, 76% of employers already witness positive impact based on the report, because 75% of the employees are already actively engaging in generative AI. Now's the time. Those that haven't raised the hand, think about it. The Cisco U has lots of resources and tons of other resources that you can help bring your organization in to start that development. Those that leverage Gen AI actually find the work, save time, make them be able to focus on more, and be more efficient, more creative, and help them enjoy work. Now, what is the skills that you need in an AI? Generative AI, overnight, quadruple all our capabilities. At the same time, we're also facing what? Information overload, lots of information, there's risk of identity theft and fake data. So this is a time where it's very important that we need to focus on driving, harnessing that power, but at the same time, minimizing the risk. Now, what this shows you is, much like the ballerina in the center, always leading with human first. With that, you drive the visionary leadership through a better way to decipher information, so you have the right data to help you make the right decision. Relevant information. Be the culture architect. This is what we talked about. Develop yourself, develop your team, and develop your organization. Harness and balance that 5 pillars I just shared. And back to that triangle again. That's where the leaders can continue to drive. Now you said, all this is great. Where do I start? You start with ABC. Being authentic to who you are, your leadership, and create awe-inspiring vision and purpose for your team. Obviously, trust is super important. Be compassionate and have courage. Once we plant that seed, we know it will grow. When you show result, that's why you bring others in as well. Remember that 12,000 seconds that we will gain? AI is a fast train. It is time for us to continue to embrace, elevate, and lead. By what? What are the toolkits I can take away? Cultivating your leadership skill with ABC. Continue to embed, develop, engage, and foster. This is a time. It's the first time ever that we are closest to almost getting a time machine. Leverage that time to invest and innovate. Now I'll leave you with one quote from Dr. LT. AI continues to revolutionize how we synthesize information and data, reshaping our capability. Hey, 10 years of research can be done in split seconds at your fingertips. Wow, that's powerful. The time to embrace and harness this potential is now. And I would just add, tomorrow starts today. Thank you. Danke, gracias, merci beaucoup. Hey, AI Assist, can you say all the thank you in all the different languages? Any questions? You can reach us. And then don't forget to fill out the survey as well. A bit quiet. Don't feel free. I'm going to stick around. Any questions? Excited? You're ready to rock and roll? Thank you, everyone.
Good morning, everyone. How you guys doing today? Welcome to the Cisco U Theater. I am Kareem Iskander. I lead technical advocacy for Cisco Learning and Certifications. And I've been around with Cisco for a long time. Right out of college, 16 years. Did DevNet for a while, and now I'm doing certification. And I wanted to put this session together to get you started with Splunk. I know a lot of us are familiar with the Cisco ecosystem. We just acquired Splunk. You might have played with Splunk in the past, but I wanted to show you a way how to stand up Splunk and how to get started with pumping data into Splunk. And so I'm going to give you a brief introduction and kind of have you visualize where Splunk is. We're going to talk about Splunk observability. And then I'm going to dig into the different types of Splunk deployment and how easy it is to get that going. We're going to look at getting and pumping data into Splunk. And then I'm going to dig into Meraki and Catalyst Center and how we can start getting some of our data from our infrastructure, from our controllers into Splunk and doing something with it. Okay? I know it's a 30-minute session. You don't have to take pictures. Everything that I'm going to talk to you about today is covered in a Cisco U tutorial. So I have a QR code at the end, or if you go access u.cisco.com, search for my name or Splunk, you'll find that tutorial, and you'll find every single step-by-step that we have here, okay? So I want you to think about this. I want you to think about date night. Valentine's Day is coming. We're all preparing on taking our significant other out, and you have to go and look for research a place to take, whether they have availability. Maybe you have dietary restrictions and you want to make sure that that restaurant has that. Or maybe you want to check the menu to see what's on it, if it's something romantic or not, and you want to order. All of these, as a human, are data points that we go through to make a decision, right? And we hit these data points, and that gets us and leads us to our decision. For our infrastructure, we need something very similar. We want to be able to collect data from everything that we have and all the deployments that we have into a single pane of glass, so we can correlate these data points, see what happens to our infrastructure, look at our application and our application performance. And this is where Splunk comes in play. Splunk has multiple things. It has observability and it has security, and they kind of are tied hand in hand, because if you can observe something and you can detect an issue, then you can go and say if this is secure or not and do some type of remediation to it. And so Splunk observability is essentially allows you to make data-driven decisions based on what you get from your infrastructure. Just like how we consider date night as a task to get to the point where we're going to go out and drive to that location, we can get all of our data out and look at what's happening, search it, and build dashboards and detect any of the discrepancies that are happening with our network. As our network and infrastructure grows and it becomes in multiple locations, it's really hard to be able to pinpoint where our issues are. And this is where being able to get your data out of Splunk into one indexer, and I'm going to talk about what that means later, allows us to make better decisions. And so with Splunk, you have the capabilities to go in and inject an agent into your code that would allow you to see from an APM perspective what's going on with your application itself. And then you can traverse down all the way down to the infrastructure where you can inject some code or you can inject an agent into your virtualization layer to see if there's any slowdowns with your Kubernetes cluster or maybe slowdowns with your ESXi. And then you can go down to your infrastructure. Maybe you have a deployment of on-prem with Catalyst Center, or maybe you're managing all your infrastructure with Meraki network, Meraki cloud-based dashboard. You can actually go and collect all the logs, correlate that, slice it and dice it, and be able to make a decision on what's going on. So it gives you that top to bottom or bottom to up observability for your entire infrastructure. Now, for this sake of this conversation, I want to talk to you about a couple of things. I want to talk to you about, one, the Splunk deployments that we have, the different types. Two, I want to talk to you about the different types of data collections. How do we get data out and into Splunk? And then I want to put in Cisco into the mix. So I'm going to show you how you can easily bring out data from Meraki dashboard and from Catalyst Center. Also, it's not limited to that, right? It could be anything. You could have a WebEx cloud that is talking to Splunk and sending that telemetry data. Or maybe you can have some type of network automation Ansible playbook that you can inject some code into it to pump data out into Splunk and see what's going on with your automation scripts. But the important part is to be able to stand up Splunk and be able to configure some data collection to Splunk to get our data in it. And so let's look at Splunk deployment and our options here. Splunk has two options. You can do a Splunk enterprise deployment, which is on-prem, or you can basically go subscribe and sign up for a Splunk cloud deployment, which is the easiest one. For the sake of our conversation, I'm going to show you how easy it is to stand up a single instance of Splunk Enterprise. For Splunk Enterprise, there are two different types of deployment. And that the deployment depends on your use case from an enterprise perspective. So a single instance, which means it's just basically a single VM that you stand up. It contains a forwarder. That forwarder is the data input mechanism into Splunk. It contains indexers, which is, think of it as a giant database that once you have the data, an indexer contains my data as a database that makes it searchable. And then our search head, which is the mechanism to say, show me the data for this time slice of this network and, right? So that's our search head. And in a single instance, all of that is one service. Now, if we look at a distributed model, and you can think about this use case is you're testing, or maybe you're a small shop and you just need a single instance where all your network in one place. But if you're distributed and you have different admins sitting in different locations around the world, maybe your infrastructure itself is distributed and you need to start pumping data into these forwarders, into the different indexers. You don't want them to all be sitting on the other side of the world. So you can deploy a Splunk Enterprise in a distributed manner, which means you can stand up multiple indexers in different locations. You can stand up multiple forwarders in different locations and multiple search head in different locations and be able to basically manage that based on how close it is to your infrastructure so you can reduce latency and noise when it gets sent out to Splunk. The other positive and good thing about having a distributed model is you can control, think of it as a microservice, you can control the amount of indexers or forwarders that are up and running from a service perspective. So let's say your data is not 24/7 being pumped from the United States and you need to take down some indexers to save some CPU and power, you can actually have the ability to manage and control that. Now, if you don't want to deal with any of this, Splunk has a cloud deployment. You get all the exact same features. You get forwarders, you get indexers, you can search. They also provide you a free trial for 14 days if you want to test out cloud. So it's a great way to get started. But also, they allow you to have the choice of cloud providers. So if you're an AWS shop or GCP shop, you can actually choose which cloud provider to have your Splunk cloud instance at. Okay, so we're going to talk about the enterprise deployment here. It's as easy as that. And this is as simple as getting a sandbox up and running. You go figure out which OS you want to deploy it on. You download the installer. In this case, I use the Linux installer. You go in RPM-interactive with the RPM name that installs Splunk. There are different variations to this installation depending on the documentation. This is the easiest I've found. And then I want you to be mindful of one thing that you should know when you're setting this up. You actually have to go to the user c.config file, set up that YAML file, say, give it a username and a password. And before you start the Splunk service, and then simply run Splunk start, that will stand up the service with the configured username, and then you have a dashboard that you can start logging into. So this is how simple it is to get started with Splunk Enterprise. The next part I want you to understand and learn is the data collection component of Splunk. So the data collection component of Splunk is the ability to be able to get data into Splunk. So you have to do something in Splunk dashboard itself that says, where am I going to pump data into you, right? And so there are two different types of Splunk forwarders. And there is your universal forwarder and your heavy forwarder. And I'm going to explain the two differences. For the sake of our session, we're going to cover universal forwarder because it plays really nicely with some of the Cisco APIs and Cisco webhooks that we have. But I want you to understand the difference here. So universal forwarders are, think of them as a lightweight minimum resource forwarder. It allows you to basically pump syslog from all your devices into Splunk, okay? On the same account with that, because it's super simple, there's no parsing on it, which means you go in configure your syslog to be, whether it's device telemetry, in your dashboard, anything and any changes that happen in your infrastructure gets pumped. And the way that Splunk charges you is based on how big your indexer is. Your indexer, we said, was your database itself, right? And so, yeah, it's super simple to get started with. You simply go into Splunk, and you create basically a pinhole in your firewall saying that on the Splunk, on this IP address, on this port, I want to be able to receive data. And then you go into your infrastructure, your devices, whatever it is that you want, and you supply this IP and port, and basically, if you log into the Meraki dashboard, for instance, an event will get fired off with a syslog saying Kiss Candy has logged in at this timestamp. Or maybe you've moved a device from one site to another in DNAC, another one that's going to get, another event is going to get fired off, or a syslog. So the entire syslog gets pumped into Splunk, and you handle it on the Splunk side saying, I have this massive database, I got to search for it. It's really useful if you don't want to handle anything, if you want to just have data in there and maybe relate to it later, or search it, make it searchable later, or maybe archive it for later, right? But it's not really intuitive. What I recommend is heavy forwarders. Heavy forwarders are basically allows you to have full control of your data before it hits indexers. And so heavy forwarders are a feature of Splunk Enterprise and Splunk Cloud. And there are a couple of different types of heavy forwarders, but they allow you to basically perform data parsing before you save it into your indexer. So you can have a heavy forwarder for TCP, UDP. You can even go as far as having a script that lives in your Splunk instance, a Python script that says, once you receive this JSON payload from X, do something with it, and then decide whether you should save it or maybe route it somewhere else. For the sake of our conversation, because it's super simple, we're going to talk about something called HTTP Event Collector, a type of heavy forwarder. And HEC is essentially, who's here familiar with webhooks? Okay, so HEC is essentially a webhook receiver. A webhook is a way, so when we're talking about APIs, right? APIs is you go and say, hey, I want data or update data. Webhooks is the reverse, which is the system itself sends you out some event, some JSON payload based on some type of threshold or configuration that you've set up. So it's the reverse of APIs. And so with Splunk HEC, what you are allowed or what you tend to do at this point is to say, I have a receiver in Splunk. It has a URL. It has a token to authorize. And I'm going to take that and configure it in the different controllers that I have on my network based on specific alerts that I care about. And I'm going to send that out to Splunk whenever these alerts take place. And so now you're pinpointing on the certain things that you care about as opposed to everything, right? So that's kind of the differences between universal forwarders and heavy forwarders, as well as the different types of heavy forwarders that we have. So when we hone in on HEC specifically, what does it allow you to do? It allows you to send data to Splunk instance over HTTP and HTTPS in the sake of Meraki and Catalyst Center, because the webhooks are secured, which means that there's a need for a token as well as a certificate on it. It would not allow you to send webhooks over HTTP. It has to be HTTPS. The webhook receiver essentially collects the data and then attaches that data to the indexer of your choice and then makes it available in the search head so you can start searching and looking at different data points at different time frames. So that's HEC in a nutshell. Now, how do we configure that? Excuse me. You go into Splunk, you create a new action, you create a new token. You say that token is of type HEC, HTTP Event Collector. You take that HEC, Splunk is going to give you two things. He's going to give you the token that you generated, and it's going to give you an endpoint. The endpoint looks very similar to this. It's always your Splunk server followed by port 8088. The HEC is listening on port 8088. And then services/collector. So that would be your HEC connection. At this point, there are two things, /event or /event raw. And you got to drill into the documentation a little bit on the differences between the endpoints that gets fired that are available in the HEC for you to be able to register with your service. That's specified in the service side. So Catalyst Center will tell you, if you want me to send out my raw JSON data as part of these events as a webhook, you have to use /raw. So just read the documentation. In the case of Meraki and Catalyst Center, those are that holds true. So now that we have HEC configured in Splunk and we have a way to receive data, we want to go into our controllers and configure that HEC receiver to be able to start pumping data. And so let's look at how we do that in Meraki. I'm going to do all of that. I'm going to switch from slides to show you how we could do all of this live as a demo after we just walk through it. So if we look at Meraki itself, there are two ways to get data out of Meraki and into Splunk. The HTTP Event Collector method will use webhooks, and I'll talk about that in a minute here. But I also want you to know that there is a way in Meraki where you can basically use the lightweight universal forwarders that we talked about, where you can simply say, I have an IP address, I have a port, all your system logs that are happening in Meraki, go pump it. So that's the easiest way. That's the universal forwarder method that we talked about earlier. But if we want to utilize HEC and we want to be able to set up the different alerts, you basically go into Meraki and configure a webhook. And this is part of the organization configuration portion, and I'll show you that live. And then within that, when you configure a webhook, you're going to be able to essentially create a template. Meraki has standardized liquid templating that you can leverage. And a template, basically, think of it if you've used automation, it's like Jinja 2 templating, but it's different. It's called liquid templating. It's a type of templating. And it essentially requires you, do you have a question? Yeah, what's your question real quick? There is NetFlow and SNMP. So the question is it only webhooks or syslogs, but or SNMP and NetFlow. It does support SNMP and NetFlow. So once you go in and configure your webhook, you're required to use a template. In this case, we have to create a Splunk-specific template that is 90% based on the standard Meraki template, but we have to add 3 fields. These 3 fields identify the source, identify the type of the event, and identifies who you are. And these are required part of Splunk in order for basically the indexer to register that webhook event itself. And I'll show you this. When we talk about webhooks in Meraki, they're ideally used for when it comes to Splunk with HTTP event collectors. Now, obviously, you can use webhooks to send events out to your own script. You can also avoid heck if you really want to get fancy. You can send these webhooks to the script to a scripted heavy forwarder in Splunk to apply some logic to it before it gets saved. Okay? So we have to go out and build our Meraki template to configure that. We have to configure the receiver that we extrapolated from Splunk itself as part of the webhook receiver in Splunk. And then once that's configured, we have to go configure our alerts in Splunk itself to say, hey, I want you to send out an alert when my device goes down. Or if a port has been down for more than 5 minutes, I care about that. I want to see what's going on. Send an event out to Splunk. Or maybe somebody changed an admin and added an admin to my dashboard. For security reasons, I want you to send out an alert to my Splunk that makes it available to me. And from there, you can do a lot more. So once we have that alert into Splunk, you can actually start taking actions based on that. For instance, think of it as a complete loop, right? So somebody added an admin on the dashboard when you're not supposed to have a new admin on your Meraki dashboard. You look at that, your operator is watching that and notices that action in Splunk. You can automate the other way with the Meraki APIs to say, this admin shouldn't have been added. Automatically, when you see a new admin, go down to Meraki APIs and remove the admin that was added, right? So you can have that entire cycle built and automated end to end. And that's a minute example that I'm using. So I'm not going to drill in so much into this because I want to show you the live demo. We have about 10 minutes here. I want to show you the components. But in Catalyst Center, it's exactly the same method. Once I have that receiver, and it could be the same exact HEC receiver that we use in Meraki and Catalyst Center. So once I have that in place, in Catalyst Center, we call them destinations. So I go in and configure that webhook receiver as a destination in Meraki. And then, I apologize, in Catalyst Center. And from there, I also have to go into the Catalyst Center alerts and pick the different types of alerts that I care about and I want to see in my Splunk dashboard. So all of this makes sense to you. Any questions before I show you how all of this is connected and it's done? Okay, real quick. Yeah. Yeah, so the question is, in case I'm not using some type of controller, Catalyst Center, that I'm managing my switches, could I still apply a template? You don't need a template. If you're managing your devices standalone, you probably have some type of script. You can use OpenTelemetry to pump that telemetry data out, send it to the endpoint that we configured, and it's going to be sent out as a different format, as log data, essentially. But yes, you can. It doesn't have to be a controller. Okay, so here's my instance of Splunk. First thing we talked about is we need to, sorry, I'm not mirroring. Okay, can you guys see this okay? All right, so if I look at, this is my Splunk instance and Splunk Enterprise that I deployed. If I go into settings here, I can start configuring data inputs. So in my data inputs, I have everything that we talked about. I have my heavy forwarders, our HTTP event collector. I have TCP, UDP scripted, and so forth. What we care about is to go in and create a webhook receiver, our HTTP event collector here. And it's very simple. You go in, you configure a new token, you give it a name, a source override. Whenever you configure, in our case, we're defining the source in our template in Meraki. But if you want to give it a different name, so in my case, I'm calling it the Meraki source. If I want to give it a different name when it hits the heck, it gets overrid, then you can just use that override feature. I don't need to do it. Give it a description. And if you're looking to basically have a handshake, every single time a webhook gets fired, Splunk goes back and says, I've received it. Here's a string that you can validate. You can enable index acknowledgement. In our case, we don't need any of this because it's a simple webhook that gets sent out. I can go next. This point, there are two pieces that I need to tell the heck to configure. I need to configure the source type. We know that in our controller, the majority of the things that are going to come out are, from a webhook perspective, is a JSON payload. So I can go in and configure my source and can say this is, you can have Splunk automatically detect the source, and it's pretty good about it, but I've noticed that I have better luck with actually, since I know what's coming from my devices as a JSON, I can go and say this is a JSON payload. And then at this point, here is the index, which is your database itself, right? Where the file that's going to contain all that, the JSON. So I have a Meraki index that I've created. You can create a new one if you want. And the way that you do index, again, is dependent on the types of deployment, depending on if you want to have a distributed index or not, right? But I have all in one. So I'm going to use my Meraki index. That's it. So at this point, I've created a new data input of type HTTP event collector that we did together. Here's one. If I show this token is what I need for Meraki or Catalyst Center to talk to me. And then I can simply take that information from here, go out to my Meraki, go to organization. In the Meraki dashboard here, for instance, I can go API and webhooks. Before I get started, I have to go and create a new template. In this case, it has to be specific to Splunk. In your instance of Meraki, you will have all these included templates. I build my Splunk one based on the Meraki template, but I've added the specific headers that are required for Splunk to authenticate properly, as well as the mandatory fields that I needed as part of my template. So if I look at the Splunk template here, you can see this liquid template that has these 4 fields right here. From event down is the exact same template, the standard Meraki template that Meraki uses. I needed to supply the time, the host, the source, That's where we do an override on the source when we created our heck. And the source type, mine is just min. It could be anything that you want. And that's it. Now, you have the template. The other portion that you need to know is when you're authenticating against a heck, it requires a header, just like any API call. So the authorization is the key. Splunk space the shared token, which is the token that Splunk gave us that I showed you. So you have to actually have that part of your template itself. And that's it. At this point, I can go in and basically create my receiver, add a new receiver, give it a name. The URL in this case is our instance of Splunk 8088 service. In this case, I'm using /raw as opposed to /events. And that configures the webhook for me whenever at this point, and I'm using the, now I have access to the Splunk template that we created, so make sure you select that. And that's it, I've configured my webhook. At this point, I can go back into my network-wide alerts, and I can say, based on whatever alerts I care about from network-wide, wireless, WAN applications, switches, I want to send it to that specific webhook into Splunk. And that's going to automatically handle all of these events in the Splunk. If I go back to my Splunk, I've triggered some of these events. So now, because they're connected into a Meraki index that we created, they're available in my search head. And I can basically go and start searching and creating dashboards based on the data that we have. I think I have a search here. And you can see that the JSON, this was from earlier today. Or this was earlier today. You can see the JSON here came out of our instance, and it tells you exactly what happened, on which device, who triggered what triggered that event. In this case, a user changed configuration via API, and it tells you what was prior to the change and what was the field that was changed and what was it after. So you have this in Splunk, and then you can actually start applying rules to that to say if a device was renamed, that goes against our rules, our audit rules. You can go back and change the device name to what it's supposed to be from your golden image. So you can see how simple it is to integrate your Splunk into your workflows and into your automation with Meraki. If I go back to my slide, and I don't have access to my Catalyst Center. I don't have time to show you this, but in Catalyst Center is very similar. You can go into settings. You can go into destination. You create a new destination, which is our Splunk heck. Exactly the same way. And then you're going to go out to your alerts. And basically select the alerts that you care about that gets sent out onto that destination, attach it to the same indexer, and now you have correlation between your on-prem managed by Catalyst Center and your cloud-managed devices all in one place, and you can see what's going on with your entire infrastructure. So you can see how useful it is, how easy it is to get started with all of this. I encourage you to go do the tutorial that I have on Cisco U. It covers everything and step by step, and it helps you. If you have any feedback for me on that tutorial, please reach out to me directly. But I hope you enjoyed this session, and thank you for your time today. Enjoy Cisco Live. Thank you all.
My friends, ladies and gentlemen, good morning, good late morning. Welcome to the Bidir-PIM Made Easy session. it just warms my networker's heart to see that there are still people interested in hardcore networking. I, for one, am definitely the guy who does all these things. And, well, my friends tell me that I have a sort of weird penchant for all the weird protocols, such as EIGRP, or ISIS, or frame relay, or even Bidir-PIM, which somehow in the world of multicast has this ugly duckling position. This is why I decided to make this session, because Bidir-PIM, once, I believe, properly explained, is simple. Simple to understand and simple to deploy. And so I decided to talk about this one and make it, and also draw parallels to something else that you already probably know, to understand it. My name is Paluch, or Peter, simply Peter. I'm currently in Cisco in the Cisco Bootcamp delivery team. Before that, I was responsible for one of the CCI exams. And when I joined Cisco originally, I was in a tech team, supporting our customers for about 3 years. And I still keep touch with my tech friends, looking into source code, looking into tech cases. So even though I am now on the teaching side of things, I still believe I have a contact with reality. And that's what I want to share with you here. Now, this topology will be following us throughout the session. I apologize for it being a little vulgar in terms of lines and colors, but I want it to be visible. And I won't be talking just about Bidir-PIM. In fact, I will do an overview of the multicast routing technologies we've seen so far, because if you understand what they do and what their drawbacks are, understanding PIM Bidir is truly simple. So please bear with me if I touch something that you know already. It's to make sure that we are on the same level. So how does IP multicasting work in general? First of all, sources just stream. They don't know if there is anybody interested, and they don't want to know, they don't care. So if the, let's say the green antenna starts transmitting, it just does it without knowing who is listening. And if the red antenna starts sending, the same thing. It just sends it. Maybe there's 100 receivers, 1,000, maybe nobody. It doesn't care, it just transmits. On the other side, the hosts at the bottom, they just subscribe. They say, to whomever it may concern, I want to get the green stream. And let's say it's the host A saying this. Right? Or maybe it's the host B saying that. They don't know who the sender is most of the time. Sometimes they do, but most of the time they don't. And they don't know if they're sending, and they don't know where they are. They just say, I want the green stream. And C says nothing. Maybe it's shut down, or it's playing a drama queen. It doesn't want to do anything. And it's the network in the middle that we expect to do some magic, to not spill the transmission to those who are not interested, but replicate it to those who are interested. And if the host C changes their mind later, okay, we update the situation and connect the receiver with the source, or at least the transmitter in the group that it's interested in. I suppose so far so good. But let's go further. It wasn't maybe as visible on the previous slide, but let me focus on what's truly happening over there. What we're creating here in multicast routing is what we called multicast distribution trees. And from that green one, let me for a while remove the uninterested parties. And so this is what we're left with when we want to send the transmission, let's say from the green sender to the receivers A and B. Now, what do we expect from these trees and when we construct them? We want them first to start at a defined spot, to grow from some specific place. Most of the time, it's the sender itself. Sometimes it's a neutral point in the network we call the rendezvous point router. But most of the time, it's the source. That's one thing. So that's what happens there. Second, we want those flows to traverse by possibly the shortest paths from the source to the networks where the receivers are. In this case, it would be through these routers. And finally, we expect the traffic to be replicated when necessary, because it's being sent only once. But some routers will have the onerous duty to split the traffic and send multiple copies to those branches where there are interested receivers. A few comments. Yeah, this is the router that does the replication. A few comments to keep in mind, and this is going to be the only slide with just the text. A very important concept in all the multicast routing we do is what we call reverse path forwarding. Sometimes it's said that multicast routing is really about the sources, not about the receivers. And that's right, because if you think about it, yes, we look at the destination, but that's a multicast group. It doesn't tell us where the receivers are. They may be spread all across your topology. But because you want to transmit the packets along the shortest paths from the sender, you better look if that packet truly comes through that interface that goes back to that sender. And we call this interface the RPF interface, reverse path forwarding interface. And by the way, multicast routing protocols do not compute the shortest path to the sources. It's your normal routing protocol, OSPF, ISA, ZIGRP, BGP, whoever, even statics, that decides how to go back to the sources. That's why our multicast routing protocols are called protocol independent, because they just hope that the unicast routing table towards sources is already there, that it's already built. So what the multicast routing protocols do more is the signaling between routers. I want the stream. No, I don't want the stream. That's what they do most of the time. And what's also terribly important to understand that in all these variants, aside from Bidir-PIM, the signaling, I want the stream or I don't want the stream, most of the time goes toward the source, but the traffic flows only in the opposite direction. So the trees we construct with all the PIM variants, aside from Bidir-PIM, are unidirectional. Signaling goes one way, flows goes the opposite way. This is very important to keep in mind. Finally, if a router replicates the packets, or if it even decides to forward it, it's not just blindly anywhere. It has to be either to a PIM neighbor, and I know that I have PIM neighbors because we send those hello packets and other packets, or out to an end network where I know about end receivers. And my question to you, how do I know that I have end receivers? Through which protocol? Not PIM. IGMP, precisely, and in IPv6, MLD, multicast listener discovery. Perfect. One of the simplest implementations of this mechanism was what we called PIM dense mode. Now, PIM dense mode is rarely used nowadays. It's good for small networks, but it has scalability issues. You will soon see why. The idea here is that we will flood the traffic everywhere and then correct ourselves if we find out that they didn't want it. That's the basic thing about the whole PIM-DM. So what happens here? Let's assume that host A expresses the interest. To whomever it may concern, I want the green stream. That's what the A says. And routers 5 and 6, they hear it, and they do precisely nothing. Because they don't know who the source might be. There's no action to be taken. Sure, they remember that they have a receiver, but that's all. They stay. Only when the green sender truly starts sending packets, okay, it might be 2. Suddenly, the routers start first what we call the flooding phase. They think that it's wise to propagate this multicast everywhere if it was received on this RPF interface. So R1 gets it there, so it floods it to its neighbors. It knows that there are PIM neighbors because we have those PIM hello packets, so I know that I can. For R2, R3, and R4, if this traffic came on the RPF interface from their own point of view, they will forward it further, the rest of the interfaces. So we flood it more, and we flood it even more. And by this time, Host B is happy because they have the stream. Host A is probably double as happy because he gets the stream even twice. That's normal. Transient duplication of packets in multicast has to be expected. There will be some signaling between 5 and 6 so that ultimately there is only one of them streaming into the shared segment. However, now a pruning phase starts. For some of these routers, the traffic arrives on a non-RPF interface. So that traffic has to be dropped. So why do you even bother? Don't send it to me. And for some other routers, there are no receivers interested, no neighbors, no end hosts. So I say, I don't need it, stop it. That's the case for R8, for example. Between R3 and R4, that's the non-RP interface between them. So we say, I don't want it. And R5, well, it lost to R6, so it also says, I don't want it. So their upstream routers stop, and the process may repeat even a couple of times more because now R2 doesn't need it, R3 doesn't need it. And so we end up with that original tree we had at the beginning. And this process repeats, if I'm not mistaken, every 3 minutes or so. It's very simple, not difficult to implement. However, those trees are not built until there is traffic. So that's why we say this is data-driven. And also, even though it seems simple, the problem is that I had to remember that I seen that sender in that group, even if I didn't want it, because the next moment, C, I don't have it here, but C may decide that they want the green traffic. Well, if I forgot that there was the green sender in that group, I cannot join him. So even though I rejected the stream, I have to keep in mind that it was there. And that's what it's the scalability problem here. Another model, a different one, is what we call PIM source-specific multicast. This guy gets a bad reputation, but it's one of the simplest ever, really. Here, we don't flood. Here, we act on interest. And we assume that the host knows not only what group it's interested in, but also who is the sender into it. That's also the gotcha. How the hosts know the IP addresses of the senders? This protocol doesn't solve this problem. The receivers have to learn in some other way. Maybe they're hard-coded, maybe they find it in DNS, and so on. But let's assume they know it, and they will tell, to whomever it may concern, I want the green traffic from the top sender up there. I'm using IGMP version 3 to signal this. And now, because this join said, I want the traffic from that specific source, I know how to get to it. I have my normal routing table. So all PIM does is to send PIM joins up the tree to the source. And so if the source starts sending, it can flow down in the opposite direction to the joins, down to the receiver. And if later, let's say host B decides to join the same group from the same sender, we repeat the process, possibly merging with already existing tree. And so we now have, again, the tree as before. The nice thing about this is that it's also simple. Only the routers interested and involved in the best paths here know anything about it. The others don't care, they don't need to. The issue is that even if it's the same group, just a different sender, you would need to create an independent tree toward that sender, even in the same group, if you also wanted that sender to get their traffic to you. So it may go up in the complexity of the memory that you need to do. Also, as I mentioned, the problem there was that you had to know who the source is. Many times you don't know. Now, this source-specific multicast is a subset of a more sophisticated mechanism, which we call PIM sparse mode. PIM sparse mode assumes that, first of all, the receivers probably do not know who the senders are. They know the groups, but they don't know the senders. If you don't know the sender, you can hardly build a multicast tree to a specific source because you have none. You have no idea who that might be. So instead of that, you make a compromise. You build that tree to a neutral meeting point, which we call a rendezvous point router. That tree will be called the shared tree, because once somehow, by some miracle, the traffic makes it all the way to the rendezvous point, no matter who sent it, no matter the sender, it will flow down the same tree to the receivers. That's why we call it shared. Now, how it's all done, that magic there. Okay, let's assume that the rendezvous point here is router 3. And by the way, every router here knows it. Every needs to learn about it somehow, statically or dynamically. Now let's assume that host A joins a multicast group. No source. So we don't know how to build the tree to the source, but we at least know who the rendezvous point is, and so we go ahead and try to build the tree toward the rendezvous point. Here we go. If at this stage the rendezvous point somehow got to receive that multicast stream, it could forward it down these branches. And of course, if B joins later, even B can be made happy. The gotcha here is, how does a traffic from a sender get to the rendezvous point? This process is called registering the source. Registering the source. Let's assume that we truly have this shared tree built. It's there for all the senders in a specific group. And now the green guy starts transmitting. Remember, senders don't speak PIM, senders just send. It must be the routers that do all the magic. Router 1 is the first router connected to the sender, and it knows who the RP is. It does a funny thing. It simply takes the multicast packets and it tunnels them in unicast packets targeted to the rendezvous point. So essentially, it turns the multicast into unicast. Why not multicast immediately? Because R1 has no branches of any multicast tree built. It cannot just forward it natively. All it can do is put it into a tunnel and send it to rendezvous point. Well, now rendezvous point can unpack the tunnel, see the multicast packet, and send it down the shared tree. And by this time, A and B are already happy. Rendezvous point isn't, because it has to do this untunneling thing. And R1 also isn't happy because it has to do the tunneling thing. So it would be good if we could get rid of the tunnel. Well, why we didn't build a source tree in the first place? Because we didn't know who the source was. But the moment I got the first packet on R3 in the tunnel, I know who sent it. I've just taken it out from the tunnel. Knowing who the source is, rendezvous point now joins the source tree toward the source, now that we know who it is. And once the traffic starts flowing natively, it stops the tunnel. And it may stay in the situation like this essentially forever. Now, there also is a process that would allow the last hop routers, such as 6 as 7, do the same trick. After the very first packet, they know who the sender is, so they can switch over to the source tree as well. It's not here. That's not important. For me, what's important here is the shared part here, but also the source part, the source tree between R1 and R3. Notice, this is a sort of a Frankenstein's monster. There is still a source-based part, the green one, even though very little, between R1 and R3, stitched together at the rendezvous point with the shared part from R3 in the blue side down there. So we have a shared tree, but not completely shared. It's still better. But we don't have a fully shared tree now. And now, my question to you is, All this worked nicely if there were few senders, many receivers, but few, if any, combined roles. But what will happen if now A, B, and C, they might be part of the same group, but what if they are also senders in that same group? Well, if we were building a source tree, then for A, it would instantiate one instance of it. For B, even though go through the same paths, it would be another entry in your routing, multicast routing tables for the replication. And if C starts also transmitting, then you have a third instance of the same tree. And why we have to do these instances even though they share the same links? Because they are not bidirectional. They always go from the source to the receivers. And if somebody thinks about, wouldn't PIM sparse mode solve this with the shared tree? Oh, no, it wouldn't, because even in the shared tree, the traffic flows only from the rendezvous point down, not up the tree. But this would be up the tree, although I don't have it. So most of the time, it would be bypassed. It would be a source tree built for those entries as well. So what can we do here? And my question here is, do we know any other protocol in our networks that actually also builds trees, which, however, do not have a direction? And I give you a hint. That burns, right? Switches, fui. And spanning tree protocol. But people, the ideas in Bidir-PIM are precisely the same as in spanning tree. 1 minute refresher here. Spanning tree, as you know, prevents switching loops, and it works formally in 3 steps. First, you elect a root bridge. It would be the rendezvous point for us. Let's say it's the guy where R1 used to be. Then, on all non-root switches, you select one root port. Let's say it would be this for those switches. And opposite, those would be designated ports. And again, one stratum further, you would select again some root ports. And on the other side of the link, that would be a designated port. And again, down, you would select designated ports to the hosts. And what was left here, well, those ports are neither root ports connecting you upstream, neither designated ports going downstream. So they are superfluous, and you can block them. So those would be the red ones. And the shared tree here would look something like this. And so that it really feels like a tree, let me remove those blocked links for a while. Now here, there's really no loops. You cannot loop a packet here. And what are the forwarding rules if these were still switches here? If you get a packet or a frame on a root port, it goes out all the designated ports, if flooded. If you get a frame on a designated port, it goes up the root port and the rest of the designated ports. This is precisely what Bidir-PIM does. The Bidir-PIM builds, again, a shared tree, a purely shared tree, against a rendezvous point address. Every router has to decide what is its RPF interface toward the rendezvous point. That's like the root port in STP. And for every other interface, the router decides if it is the designated forwarder, like the designated port in STP. So if I simply took the same roles as before from that switched network, this would be it, and this would be one possible way of Bidir-PIM constructing the shared tree, copying the ideas. Just we don't call the blocked ports as blocked, we call them losers, which is not a nice word, but anyway, that's how we truly call them. And there's one more change. We changed the flooding rules. But again, the way STP works. If you, as a router, get a multicast on an RPF interface, that's coming from the root of the tree. If you get it on an RPF interface, you can send it out your designated forwarder interfaces to your neighbors, end-to-end hosts, of course. That's the downstream traffic. If you get a multicast packet on an interface where you are a designated forwarder, you send it out your RPF interface upstream and from other designated forwarder interfaces if you still have any. The flooding is just like we would do in STP here. And essentially, that's what Bidir-PIM does. A few very interesting facts to note. First of all, you may have noted that I said we build the shared tree toward an rendezvous point address, not to an RP. That's because in this process, RP doesn't do anything. There is no tunneling, no registration, no source tree path building to the sender. Essentially, the rendezvous point in Bidir-PIM is just a location toward which you compute your RPF interfaces, but that location has no other function. It doesn't need to exist, really. It may be an IP address on a link, which is not owned by any physical device, which is interesting. That also means that as opposed to PIM sparse mode, where if you have multiple rendezvous points in active-active fashion, you have to synchronize them about the sources with MSDP, for example. There is no such thing here. There is nothing to synchronize. RP does nothing. It's just a reference point, that's all. And as I mentioned, it doesn't need to be any real device. So where would this be used, really? First of all, like the typical application is whenever you have many-to-many sources and receivers, such as video conferencing, such as financial trading applications where they interact with each other. It may be, now very popular application is, for example, BGP EVPN. You extend your VLANs across a routed underlay, so you may have possibly multiple tunnel endpoints that host the members of the same VLAN. Any of them can become the source of a local multicast or broadcast there, and you have to efficiently replicate it to all the other endpoints in your underlay, behind which there might be another receiver. But this is still usable even for the initial application where you have just a few sources and lots of receivers. If you don't care that the tree is maybe not optimal, but you completely conserve the resources very aggressively. So it's not like this has to only be for many-to-many applications. You can just have it for few-to-many or one-to-many just as well. It conserves the resources pretty nicely. And with this, thank you very much. I'll be around for any questions. Thank you.
All right. Can everybody hear me okay? Awesome. I'm Rob Gresham. I'm going to do a little presentation on enhancing security solutions. By show of hands, how many of you are in a SOC or part of a SOC that is greater than 30 people? How many are in a SOC that is greater than 20 people? 10. 5. No SOCs? No SOC people at all? Oh, come on. There's somebody that does security in your business, right? Okay, so the idea here is that my name is Rob Gresham. If you want to know my bio, by all means, go find me on LinkedIn. I'm there. You can go read all the cool things that I've done in my lifetime. Really quickly, I've built SOCs for a living. That's what I do. So I've been part of automation. I've done the actual detection engineering. I've pulled all the pieces together, but predominantly, I want to help you get better faster in security operations. I was a former Splunker for about 6.5 years, led professional services for 4 of those years, and then the product for the last 2. What we're going to kind of talk about is a journey, because doing and building a SOC isn't easy. How many people mountain climb? Come on. Nobody walks a mountain anywhere in here? All right, there we go. Now we're starting to get some participation. But if you learn how to mountain climb, well, there's other skills. You need to learn how to use ropes. You need to learn how to rappel. You need to learn how to ice climb. But the same thing for security. There are certain skills and abilities, and we're going to talk about that. Now, we may not always get up to the summit and be able to do everything for everybody everywhere. But the key here is, why do you need this? Well, most of you are here, maybe probably because how many are here are Cisco network people and love networks? There we go. Now I get to see some hands. Awesome. So what came first, the endpoint or the network? The endpoint technically was first, right? But it was Commodore 64s, didn't really do anything but helped you, right? But in the grand scheme of it. But it didn't really start to matter until we created the networks, till we started communicating and bringing those things together so we could share the capabilities that we have. All these tools, every breach has every capability of these tools. Our problem with these tools is that you need the data from those tools to the endpoint in order to effectively manage your breach. When we start looking at the SOC of the future, it's about bringing things together. It's about leveraging the power of Splunk with the power of Cisco. Because an endpoint event is getting evaded all the time. Endpoint, EDRs, how many people have EDRs in the room? Right? Pretty much everybody should have an EDR because it's your basis and foundational intelligence. But with that, it's evolved, right? It used to be AV, then it was endpoint protection, then it went to EDR, or endpoint detection and response. Now they're XDR, and then there's the next generation SIM, right? Supposedly. But the idea here is that all of those are compounding journeys building up to a capability. You also need a SIM, because a SIM gives you compliance, it matches other use cases, vulnerability management, visibility, operational visibility, IT operations, and then SOAR. What does SOAR give you? SOAR gives you all that automation to bring all these things together. Well, what happens when you bring it all together in one shot? That's a unified threat detection, investigation, response platform. This is what you need to get to. Now, the problem with getting to that point is that you got to be able to make all these tools work together. If you are using a Microsoft XDR and you're using a Splunk SIM and you're using Palo Alto's XOR, you got a lot of work ahead of you to make that work. So how do we make this easier so that you can get that cohesive view of everything that you're going on and building? Well, when you think of Cisco as a tool and capability, you understand that there are a bunch of things in a SOC that need to get done. These are all the capabilities for a full SOC to accomplish. So where you think your maturity is will be relational to how you're running your business and where your capabilities are. But what Cisco wants to be able to do is meet you where you are. For example, we realize that every customer needs these basic capabilities across the board to be able to ingest natural link or native telemetry from their systems, be able to take in third-party threat intelligence, to be able to do case management, visualize the threat at full ends of scale, full asset management, because asset management is job number one, right? To understand the things on your network, because how many endpoint EDRs see all the things that are on my network? Come on, nobody? You don't put endpoint, oh, come on, you know. But the reality is the endpoint products can't be put on everything, right? There's IoT devices that won't even run them, right? So we need the network in order to see full visibility. But we also need to be tactical. We need to be fast. We need things to work together so that we can understand. But then we need to be able to take that and transition that to lessons learned, right? And what other policies and capabilities that we need to create in our governance. But as we grow and we knock those out, if I gave you a tool that did that today, Well, then I want to lean into different skills and abilities. I want to expand. Once you start expanding, the first thing that general customers move into is detection engineering and threat hunting, right? They focus right here and they start doing these pieces. Well, the problem with that is if you don't have a data platform and you don't have a SOC platform, you're just doing that ad hoc with a SOAR product or some other tool, running around and putting all these things together. And you built a bunch of cool workflows, some Python scripts, maybe some JavaScripts, maybe you built an app, whatever the case may be. But then you grow up and you realize, I really need a tool for this. And then you go buy a SIM, and then you realize, wait, I got a new data platform. Now I got to do data tiering. Now I got a SOC platform. I got to bring all these things together. The problem with that is that everything that you built previously doesn't go with the thing that you built already. And now you've got to replace all those processes. But great for you. You have a Confluence page of all your actions and things that you're supposed to do, right? And it's kept up to date all the time. So you can go back to your documentation, you can go back to your tools and rewrite all those capabilities. But ultimately, when we get to forensics and malware analysis, that's a lot more data. Some of it valuable, some of it not, some of it needs to just be temporary. We want to be able to do all the things. At the enterprise level, we're at the maximum maturity of what we can do. It's like, if anybody familiar with CMMI or capability maturity model, or Six Sigma, the idea is to get to 5, but most people only get about 3.5. Some rarely see 4, maybe 1 or 2 processes. But when you pull all those together, we want to be able to start to scale. And well, the first thing we need is we need to start with a common platform. Once we have a common platform approach, then we can pivot and start focusing on our detection engineering. Our detection engineering has to be much like we do for software. It has to be inline, it has to be versionable, it has to be scalable. For it could be in one region or another region. Maybe you're an MSP and you need to spread that detection engineering out, but you also need to be able to go on and have full-scale automation. Automation that you built 3 years ago should be on the same platform you're building 5 years from now. How do you do that? If you're changing platforms all the time and you don't have a platform that focuses on integration. Oh, but then you did automation and now you're adopting generative AI and it can do magic things for you, right? Solve all your problems, go do automation for you, but can it show its work? Can it show you the proof of how it did what it needed to do? It's going to get there, but you're going to want to be able to tell it how to do what task, when to do what task, in what order, because your business is unique. And it's not like your business or your business or your business. So to take it one step further, we need to not move all that data to the same place. While I appreciate you all coming here, right here, sitting right now, I wish I could reach everybody in every stage. But being able to federate is a problem because we have to be able to access those portals at different ports in time. And what better company that actually created networks to bring data together into different pieces and to share it than to be the same company that integrates your security products together without locking you into a specific product. The key here is that our session journey starts with automation. You got to have the tools in order to start to go faster, to make those easy things go away. And through our journey, we're going to be on that trail to SOAR. The typical SOAR customer, on the average, on a standalone product, only gets 7 workflows done. That's it. That's all they usually get. Some get up in the 120s and get a lot of things done. Maybe they're smaller, they're capable, they focus on that primarily. It really depends on where the focus is, but the average is about 7 use cases. But as we move, we have different skills and abilities to tie these things together. We start with different capabilities like an XDR. But if we don't learn how to put the endpoint and network data together, and I don't just mean NetFlow data or Zeek data or DNS data, I mean the whole kit and caboodle. Because I don't need you to answer this, but think in your mind, if you're in a SOC, how do you take that network event, whether it's a URL, domain, IP address, and tell me, the investigator, what process executed that event? It's a very difficult task. As we take it a little bit further, you sprinkled a little MFA on your capabilities so that you could keep bad guys from using your username and passwords. But what we've realized now is that we need to actually go into identity detection and response capabilities, right? We need to be able to manage all the things that are going in that environment, and it's not just for prevention. We need to be able to reset sessions and capabilities. But also, we need to start doing compliance. That's why there's that little dip there, because everybody loves compliance, right? But you have to do it. You have to start measuring yourself. Once you start measuring your capabilities, you realize where your gaps are, and then you start moving to vulnerability management, and you need a SIM. From the SIM, you start doing threat detection, right? Detection engineering. Are you threat hunting? You're threat hunting all the time. An investigation is, in essence, a threat hunt. The difference is you have a starting point with a normal threat hunt. But in detection engineering, you start with this idea, and you move it to an actual detection. And once you have that detection, you either realize, uh-oh, I have an incident, and now I need to do incident handling, or two, I have a detection that I want to keep an eye on and catch threats as they come and happen along. An XDR lifts you up, drops you in place, but not all XDRs are equal. We'll talk about that in just a sec. Then, if you buy a SIM and a SIM takes you up, that's great. You went and bought a SIM, but you notice the SIM didn't take you all the way up to TDIR. Why? Because there's more work that you need to do there. They can't make it easy for all the way easy for you because your business is unique to you. What things do you have a compliance requirement? How are you managing vulnerability? Where do you see your assets? What app integrations you have? The key here is that the SIM will get you parts of the way there, but you still have to learn the journey of integrating all of these capabilities together to make the SIM powerful. This is why most customers don't have fun with a SIM, because they haven't learned their journey to put these things together yet by the time they take that journey to the SIM. And then two, the SIM replaces all the previous activities they had in the past. So if they were using an XDR, like let's give you an example, Microsoft's Defender XDR. They're using that XDR. They got identity, they got all the endpoint data, they got email, cool. Well, the next problem that they have is that when they go to SIM, they put in Sentinel. Well, now, do you work in the XDR or you work in the SIM? What we want to be able to articulate is that each part of this system, the network, the endpoint, the email, all have good, better, best scenarios. For us, you can see that we can start with good, be able to take our NetFlow data over here, move it through our telemetry broker into XDR, and then later into Splunk. But we can also do that with SNA, which is our best way, pull all those, create new alarms in telemetry, and send that to Splunk. Being able to combine the power of Splunk Enterprise with the power of XDR allows you to start keeping things in the same space and working your game, because now you're not losing the capability. If you lose a network piece and you say, you know, I like Darktrace, but you know what? I like SNA, but I want to go to Darktrace. I'm going to be sad that you're leaving, but my XDR still supports Darktrace, ExtraHop. If those are the vendors that you're using, that's fine. Bring Vectra AI, I'm good with that too. Integrate it with our product and get the value out of your tools. But don't trade out your XDR just because. But if you went to Microsoft or Palo Alto or anybody else, they don't have an open XDR. If you rip out their XDR, you're ripping out the endpoint and all their other integrations along with it. Obviously, EDR-based XDRs are aplenty. There are tons of them. The key is how do they work with other products more than themselves. A true XDR works with other sources, other data pieces. Okay? As you can see here, our primary use cases to date are CrowdStrike, Secure Endpoint, Microsoft Defender, and Sentinel-1. These are our primary use case endpoints. We also have Trend Micro, Cybereason, and Palo Alto Cortex as an integration capability. The key here is that how do you join the endpoint to the network? Well, you need a tool that tells you, well, this thing happened on the network off that endpoint, and this was the process that executed that thing. Oh, by the way, here's the parent process. here's the logged on users, here are the hashes for all those objects, and here is the user process or users for those processes. With that full picture, I can stitch an endpoint event back to a specific network event, which tells me breadth of what the attack is, tells me where the C2 channels are possibly coming from, seeing where lateral movement from SMB, that east-west traffic, which is notoriously hard to find. Also, I need to be able to understand my email. I need to be able to ingest email into our environment, whether it's coming in through the traditional gateway or feeding into ETD. ETD feeds XDR so that we can see the email, the attachment, and the URL and process it with XDR and align it to the endpoint and the network event that happened in your environment. But not only that, we integrate it with Meraki. So if you're a smaller IT environment and you're running with 5 or 6 people, you can integrate XDR with Meraki right out of the gate. One configuration, one setup, and you push all your NetFlow data to XDR automatically with Meraki's integration. The other piece that you want to be able to consider and think about is, yes, Rob, it's great. Cisco has all the things. It's a great company. But I don't want all of Cisco's stuff. Buy the breach suite. Get the capabilities of the breach suite here and be able to have not only the advantage capabilities, but also to have managed detection and response capability and CTIR, Cisco Talos Incident Response Team, to help you support you when a breach does happen, to actually be able to do that deep dive forensics. Now we talk about an XDR. What is a true XDR? The industry version of an XDR to date is an endpoint product that receives additional signals from other products. IDC defined endpoint or XDR as a collection of telemetry sources. We added to create detections of maliciousness, not just from endpoint, right? Every other EDR right now, to date, only creates detections from endpoint enrichment capabilities, not just from network capabilities or network events. In addition to that, we needed to provide you a response and automation capability so that you could remediate or at least contain and block those pieces. And with XDR, you can see the integrations coming into play into the tooling and mapping them all together. But what we see is that we also have AWS integrations, we have APIs, we can bring all those flows in, we have campus flows, we have remote workers that can be able, and we have the Talos intelligence already embedded into the product. In addition to this, there are 4 things that make our XDR different. First, we start with asset insights and context. We already gather all your asset information from your integrations that you're telling us. We take that and tie that to automation and response. We create in XDR, there are 585 workflows managed by XDR that you can use across the various products. We do threat hunting and investigation automatically. You do not have to build it. You don't have to build a playbook for it. It's integrated into the platform by default. And then lastly, our hardest part to do. We got to take everybody else's data, normalize it to open cybersecurity schema framework, and then turn around, ingest it, and recreate the detections from those other tools, much like a SIM does. The difference is we're a correlation engine, not a detection engine. We have some detections, but we correlate activities from other devices into ours. If you need detection engineering, you go to a SIM. As you can see here, we have identity intelligence already integrated into the product. You can use the XDR Automate workflow that will actually go and pull identity intelligence into the environment and then update a ticket and an incident in the case that something had happened. With these, we have the automated responses from identity intelligence to be able to block, remote reset an MFA inside that session so that you can have those capabilities in that platform in addition to workflows. If you notice, you can't see this, but contain assets doesn't ask you what product. It just does it. The workflow integrates and strips away the application integration so that we just focus on solving the task. And every time there's a new integration for a new product, we just integrate it into that workflow. So if you change from Microsoft Defender to Secure Endpoint, you don't lose capabilities in that product. As we've talked about getting to ITDR, we're going to really quickly cover compliance. This is where Splunk comes in and we bring that piece together. As we bring Splunk in, it gives us an extensive dashboarding capability to visualize and view your data, right? And ultimately, you want to be able to see and trust the data that's getting in. So we want to be able to trace that all the way back. Obviously, Splunk has, if you've never seen Splunk before, it's easy to ingest JSON data, super easy, don't have to do a thing. It already knows the field types. You can already get top 10 summarizations right out of the user experience without any searching. And then if you need to quickly filter on source type, as you see above here, we just pick on the source type, and then we reduce the date and timestamps, and now we can get the logs that we care about based on that source type. We can move that into a very complex SPL. There are really good friends of mine that have great SPL skills. This just happens to be some of the logic behind the risk-based alerting capabilities within Splunk. You're not going to write this. You're going to get help with it. You're going to have an AI assistant to help you write that. You're going to have professional services to help you write some of these complex capabilities. But you can do anything you need with Splunk as a data backend. Also, we created our own gold standard app to integrate all the data from Cisco products automatically into Splunk by just setting up the configuration, telling it what index you want that to be in, and then we'll go ahead and schedule and push it, and you can have one or many integrations as needed. Am I blocking your view? Okay. Also, we have already pre-built a whole bunch of dashboards for different tools so that you can check the operational and data integrity flows of your integrations. With that, we've also integrated SNA, or Secure Network Analytics, directly into Splunk. So if you don't want to buy XDR, but you need the network observability and visibility, you can tie that in directly right into XDR, and we made it simple and easy. Another key component on Splunk that you should be thinking about and looking at is not only do we have our asset inventory coming in XDR, but Splunk has an awesome tool called Asset Risk Intelligence that basically scans all the indexes and starts to correlate all the assets that you see in your environment so that you can get visibility. It integrates with your ServiceNow CMDB. It pulls DHCP logs so we can see the asset moving through its entirety. It's built to help you identify compliance requirements and make sure you have full visibility of the assets in your environment. This combined with XDR, and you get a complete 360-degree visibility of your network. In addition to that, you have compliance apps that give you where you are in your security operations or security program to measure those capabilities, whether, as you can see here, we got GDPR, Cyber Essentials, but also then take that one step further. You can see which detections you need for compliance contact and what framework and what group they belong to. And you can do dynamic search and reporting to make sure that you've got the right coverage you need. But that's not all that Splunk gives you in the capabilities. You can actually go in and grab the Splunk Security Essentials app and actually start building detections straight out of the gate and integrating the data sources that you have. In addition to the Enterprise Security Content app update starts you on detection engineering. But you have all kinds of other apps like IT Essentials and the InfoSec app to help you along in starting to gather and build your security operation. As we pull through, now we've talked about Splunk, and we've got Splunk into play, but the next step is we need to integrate with that SIM. Well, the power of the SIM is actually pulling all these pieces together. Now, I'm not going to give you a demo on Splunk Enterprise Security 8, but you definitely should go over and see them in the security piece and get a demo of that tool. That tool is awesome. It does a lot of great things. It's the Formula One of SIMs. So it helps you get the things you need. It provides the detection engineering you need in order to actually improve your program. There are lots of capabilities, but where XDR fits in this is to kind of level the load of what you need to ingest. We can totally ingest capabilities like endpoint network and email, but then transfer that data over to SIM to make it faster and easier to run Splunk and XDR together as a superpower. You can see ES here. You can see that it has a very similar UI to XDR in some places. You have capabilities of understanding your threat scores. You have a drill down search capability. you have adaptive responses, you have notes that you can use, and then you have owner operational for case management capabilities. But you also have the Talos integration in the product. Not only do you have it in ES, but you also have the Talos integration in SOAR. We've helped work with the teams on the Splunk side to integrate Talos into their capabilities. But that's not all. There's more. If you go to the research at Splunk, or research.splunk.com, you're able to not only get analytical stories about things that you care about, like Medusa Stealer, detections that support that, and playbooks that support those capabilities, so you get out of at least 110 playbooks, or maybe a little bit more, out of the box that start working in your environment from the ES to SOAR integration moving forward. Now, we come to the best part. I've talked about all the strategy and all the things that we put together. But the reality is that it doesn't really work if you can't see it in action. So the Splunk and Cisco teams work together to actually solve part of this problem by doing the Black Hat SOC here in EMEA in 2024. We actually integrated all the tools together and ran a SOC for Black Hat and for the Super Bowl this year just the other day. The key here is that what we wanted to be able to do is tie these products together in multiple layers so that you can achieve your goals, whether it's the user protection suite, the cloud suite, the breach suite, third-party data sources, your firewall data, or your enterprise security, SOAR attack analyzer, and Splunk platform are all integrated in a cohesive environment in the new Cisco Security Cloud so that you can interact with those products together at one point in time. This is going to be your new SOC platform, because it doesn't matter what third-party products you remove out of your environment. You want to switch? Switch. Splunk adjusts. We have 2,800 apps in Splunk, right? But we also have 435, I think it's 435 integrations in SOAR. There are over 90 integrations in XDR. We have lots of ways and capabilities to pull these pieces together. But we're going to talk primarily about the breach suite today. Being able to integrate these capabilities together gives you the superpower you need to run your SOC and give you a premier SOC platform. As you can see here, this is some of the hardware for Black Hat Europe. This was the integration setup for Black Hat. Notice Palo's in the middle. We got Arista, we got Strata, we got Talos, we got Splunk, we got Corelight, and we have Cisco XDR hubbing it all together with Palo Alto's Cortex. The Splunk sources that we were using, Thousand Eyes, Corelight, Palo Alto Networks, Arista logs. But what the customers wanted to see is how was the SOC operating? How are we pulling these executive dashboards together to pull all these pieces so that you could see what's happening? Whether it's pulling in the Thousand Eyes data or the umbrella data, we needed a comprehensive data visualization platform, which Splunk provided, to be able to create these dashboards and pull these pieces together. But also to be able to tie them into an easier understanding of how we manage incident response, into what incidents we were tracking, what Corelight events we were seeing, how was that working on blocks and panorama. But then turning around, we needed to create an integration off the fly. Over the course of 3 days, they created one workflow that they used and templated in order to create the integrations for certain detections that they needed from point products that were not immediately integrated into XDR. So this workflow that you see here produced individual vendor detections inside XDR relatively easy. And as you can see here on the right, SMA malicious detection, Palo Alto, Corelight, Thousand Eyes, incident enrichment, adding room and purpose, Palo Alto threats. All of these workflows are available for you to download inside the platform in the exchange, so that you can use these same workflows just as the Black Hat SOC did. But as you can see here, as XDR pulls the crypto mining example together, you can see how it brings and integrates those so you can see what's bad and malicious. It brings all the events together, and you can see what asset has that event and see active threat intelligence against it. But then you also pull in the examples of what incident based on what tooling we have from whether it was coming from malware analytics or other tools. But then the WebEx incident and incident reports gave you a quick summary so that the team could join together and collaborate on what was happening in the environment. Ivan, LaTricia, and Ryan helped me. Ryan's in the room here somewhere with his head down. There you are, Ryan. Ryan's over here. Ryan, they helped build this capability, and I'm just talking about it for them. This workflow template you can grab and use for yourself and build your own integrations and capabilities in the product. Just as you can see this HTTP traversal event, we can just pull that into XDR, and the automatic enrichment of other events automatically follow in. The threat intelligence, if it's there, is already populated into the incident. There's nothing else extra to do. In Splunk, you can see how we can easily query and pick up the incidents by using a simple parameter inside our alert signature to be able to pull any exploit alert we want out of a firewall and pull it into our environment. We did the same thing here so that we didn't have to strictly define a particular parameter or capability to match it. We used variables in order to pass it from XDR to Splunk into a common search. That common search fed the alerts. Then the alerts populated XDR. This is an example of the workflow, and this is how it populates in XDR. As you can see, we pulled out not only the assets themselves, the observables, but all the indicators from those different pieces. We scored it and summarized it and gave you an easy way to just quickly view and start removing and responding to those incidents as you needed. You can see that we had all the capable scores and pieces of the asset as it was updated when the new incidents populated in as we ran the workflow over and over, and a new event showed up. As you can see, in this journey, there's a lot of work to be done to reach TDIR. But Cisco is working together with our Splunk team members to create a combined system so that you can join these pieces together and be able to create a cohesive incident response and detection investigation platform for you. There are additional resources for Splunk and XDR and how we did these integrations. Please don't hesitate to reach them. Thank you for your time. I appreciate you. Hopefully you learned something. And if I went entirely too fast, they are recording. And there you can take it, go a little bit slower, and read through my slides. Thank you very much, everyone. Have a great day.
Well, why did you come if it wasn't a cute title? It was a cute title, right? So before we begin, I guess the little thing hasn't gone on yet. So my name is Fishburne. For those of you who I've never taught before. No, I'm kidding. So for those of you like in the United States, I actually have a web page, yada, yada, yada. So I'm a big kid. I'm a dual CCIE and a CCDE. I've been with Cisco since 1996. And many, many years ago, because I joined in TAC, someone at Cisco Live said you should really teach about techniques of a network detective. And so what I do. So because I am a big kid, I do have stickers. So if you could just feel free to have a little bit of fun, pass them around. I do have very strong views on a few things that will come through. And so I do have my little badge because I'm a big kid. And it's got my CCDE number up here and my CCIE number down here. And it says Network Detective. I was like so well chuffed getting this. Okay, so they don't have me quite starting yet, which is great. The concept here, just to let you know, and actually I was, they still haven't started it yet. I had this in my backpack, and my brother-in-law got sick, and I was in the waiting room one time a number of years ago, and I pulled this out and put it on the table. So this guy said, oh, are you, and and I was like, no, and I learned that he'd retired, so I asked him a bunch of questions. The concept is that a lot of people, when they're trying to troubleshoot something, use a lot of similar concepts. So whether or not you are voice, whose voice? Collaboration? Oh, you scare me. You've got to be wicked smart. I really have a hard time with that. So I'm serious, actually. I have a hard time with memorization. For me, it's better if I can see a flow. So what we're going to cover today, which apparently it's now started, is basically whether you are collaboration or routing or whatever you are, some techniques that I have used over the years, because really my favorite thing is actually troubleshooting. I don't know if you all, I mean, obviously I'm not in a production network, so there's a lot of different things that you all have. For me, in TAC helping somebody, or actually in the lab, because I work in the lab a lot, it's quite the, you know, we got it, yeah, you know, moment. And it's also really nice because usually in that situation, people are trying to work together. So what we're going to talk about today is techniques of a network detective, and hope that this actually goes. So this is your crime scene. So when something happens, this is your crime scene. And you're trying to figure out, like, you're trying to gather all of the facts and you're trying to gather the clues. Okay? Now, what are facts and what are clues? Right? A fact is that I'm wearing this blue shirt. And it says Cisco on it. Now, the differentiation, in my opinion, between a fact and a clue is you have knowledge that this has a meaning. It's either this is not normal or it is normal. So this means, because this is Wednesday, right? This means that I'm a speaker here, right? Because you've probably seen people wearing this shirt. So the difference between a fact and a clue for me is that you have knowledge. So you're going to hear me say again and again, knowledge is key. Knowing what's normal is key. Knowing what's not normal is key. Because that is what differentiates between a fact and a clue. Now, I know I was in TAC for many years, and it's the standard answer. No, nothing changed. The concept is that nothing that you think is relevant has changed. And that does get into, to be perfectly honest, fear and pride. And so fear and pride, you'll hear me talk later on. Fear, pride, silos are obstructions to network justice. In my view, each and every one of you, we all protect the packet for our customer, regardless of where you are in your network. We all protect the packet. That is our job. It goes from one end to the other, regardless of the silos. It's one network. So what we're going to talk about today is we're going to talk about trying to have the case of the missing packets, and then finding the answer. Who done it? Where is it? What is it? And then get to problem solved. There are, whoops, hello. Hello. Stop that. This is our agenda in picture format. We're going to talk about be prepared. In here, be prepared, knowledge is key. Find the suspects, question the suspects, and then the thing that everybody forgets to do, which is learn from your mistakes. Right? And we're going to talk about that because there are many times where people are like, oh, well, I think we put that static route in because I'll do something in lab and have a customer's configs. I don't take that static route in because I think we put it in for some reason, but we can't remember why now. Okay? BGP communities. Have you thought about looking at your, we use communities and we used to tag things, but I don't remember now. So we put things in and then we have this heavy lift later. Whereas, of course, if it was fresh in our mind, it would be a faster lift. So what I'm going to tell you is be prepared. Knowledge is key. And for those of you, I have to fix my website, but I have a website called Networking with Fish, and I'll probably try to do some things in there that are like troubleshooting ride-alongs, if you want to try to do some. But I have to kind of sort of clean some stuff up first, so don't go there till later. Don't go there till tomorrow. Some URLs are broken. So be prepared, knowledge is key. So this is what we're going to talk about. So this is the boring stuff. I find it boring, okay? For those of you who have a full conference pass, I'm teaching a class later on at 4 o'clock today about IPv6. What do you mean there's no broadcast? But please know that every single solitary breakout that has ever happened at Cisco Live is up on Cisco Live video on demand. And you can put the name John Smith in some bogus email address. And you can see every single solitary breakout that has happened at any Cisco Live. Absolutely free learning, okay? I think you can even download it, the MP4. So please take advantage of that if you're not a full conference pass. So be prepared, knowledge is key. So this is what we're going to talk about first. And so I'm going to say, know your crime scene. Apparently something is, so know your crime scene. Know your crime scene. Know your crime scene map. What is your crime scene map? It's your diagrams. We're going to talk about that. Okay? So this, again, is just a high-level 30-minute, know your crime scene, know what's normal. If your traffic goes from, I'm from the United States, from New Jersey to Chicago to California, know that it is normal that if Chicago has an outage, that you go from New Jersey to Florida to California. Because by knowing how the failure is supposed to happen, you can more quickly adapt to that. And a lot of these things, I've actually read a lot of stuff about police and detectives and stuff like that, and have seen so much overlapping, right? Know what's normal. Know who the people are that walk the street. Know if an infamous diamond person is, in the country, and there's big diamonds in the country. Know this stuff. So know what's normal, know who your witnesses are, and know your suspects. Every single box in the network that sees the packet or doesn't see the packet is a witness. For me, as a routing person, that means that I can do shows. But regardless of what you are, everyone that touches or doesn't touch the network that you expect to have it go through is a witness. Everybody is a witness. Either they saw the packet or they didn't see the packet. Whoops. Know your network monitoring tools, know the devices in your network and their modus operandi. So when they actually come in, like when the ASR 1000s first came out, and I was doing certain show commands, it was like, well, no, you can't see anymore because we're not doing fast path. So you actually have to see the Ceph. You have to go lower. So you actually have to see who's doing the work. Like I might do CPOCs, and I might just give the diagram to a college intern. And then if someone says, well, are you using these cables? I'm like, I don't know, don't ask me. I offloaded that to a distributed, obviously we're doing a lot of that, right? We're doing a lot of SDN stuff where the brain then tells somebody else. And you may not know, so you have to go back to the brain to see what I programmed you to do. So you need to know the modus operandi of the packet. Know how to question a suspect. So you need to be able to interpret the facts. So know a crime has occurred. Here's the other thing. Know a failure has occurred. Right? Know a failure has occurred. So just like real law enforcement, a cold case is much more difficult than an active case. So you want to try to get onto the crime scene as soon as you can, because that's where you'll find the most active clues, especially if it's still happening. So please know a failure has occurred, because as soon as you know a failure has occurred, you can actually go ahead and reduce the downtime. And you can also you can get to it fresh. And here's the other chance. Anyone got cascading failures? Yeah, so you think that traffic is supposed to go from New Jersey to Chicago and then over to California. And what you don't realize is that the box that you think you're supposed to go over to in Florida is supposed to actually do that. The router's been in Ramon for a week. Okay? So now you actually can have cascading failures, or cascading failures where I'm going through one device, but because your CPU, you're just so busy. Because not only are we doing more with less, but all of our equipment's doing more with less, right? Right? Yeah, is what it is nowadays. So your CPU can be so heavy, the bandwidth, that you could have already failed, and then you go over. So cascading failure. So if we knew that there was a failure on you, for your CPU is too high or whatever, and that gets into the monitoring tools. Don't wait till it's 99%. But at the same time, when the ASR 1000s first came out, I couldn't do a show CPU anymore. Because what I was doing with the show CPU was I was asking this brain as opposed to the brain on the line cards. So now the CPU, and that gets back to knowing the modus operandi of your box. How does it work? How do you talk to it? How do you investigate it? How do you ask it questions? That gets back to knowledge is key, and you want that knowledge just like law enforcement, and that's why they have specialties. So that you learn how to go ahead and ask people, oh, right, of course. Now we have those little pieces of tape that show the approximate height, because people learned and they improved. We could spend the next half hour on this one. Okay, have accurate and helpful crime scene maps. So I was in TAC, and you would go ahead and you would send me, I'm so sorry, I'm picking on you all the time. Okay, you. You would go ahead and you would send me a diagram. The problem is that diagrams are very difficult. I'm smart, but we all do diagrams so differently. And that's why when you go to hotels and stuff like that, they all have very set ways of telling you this is where the emergency exits are. But we don't do that with our diagrams. So you will actually spend time and energy trying to get me, the TAC engineer, to understand your diagram so that I can then help you. For me, the more that you actually have diagrams that don't have the big picture pop, you're hindering the investigation. So I'll give you a suggestion. Who doesn't work in a company or a group that has silos? Yeah, okay. So what you're going to do is you're going to go ahead and you're going to give your diagram to someone in a different group. And then you're going to do this. You're going to be tempted to be like, oh, just to let you know. Okay, that dotted links means, okay, and then have him tell you what he thinks quickly pops. So in 5 minutes, give him a diagram that you think he could quickly catch on to in 5 minutes and see whether or not he can. And then you do the same thing back. And then improve. This is the crime in the lounge. There was a crime. Your absolute #1 person that you are convinced did it is in the conservatory. However, there is absolutely no way that any of the doors were open in the conservatory. And no cameras caught this person in the hallways. Can you rule this person out? Who says yes, you can absolutely rule this person out? Who says no, you cannot rule this person out? Why can you not rule this person out? Pardon me, I'll be right back. Where'd he go? Oh. Why can't you rule him out? Oh, he jumped out the window. Okay, that doesn't help me. Who has heard the board game Clue? Oh, sure, you have, and you were like being all quiet there. Fine, be that way. So in the board game Clue, there are actually secret passages. So in the board game Clue, you have secret passages between the lounge and the conservatory and between the study and the kitchen. So this diagram that you have here would hinder your investigation. This one, with all of the knowledge, it's so funny because we talk about visibility and observability and how you need it more in your network, but we don't always have it in our diagrams. So how can we follow through? This diagram would hinder, that diagram would help. Please have diagrams that help and don't hinder. Otherwise, people think that you're giving them all the information because you're giving it to them, and then they assume that that's what's gonna happen. Okay? So, know your witnesses. We already talked about this. This is what I'm gonna tell you right here. When you give the diagram to somebody else, when you give it to me, I want the big pictures to pop. So for me, I actually use like a thicker line and then a thinner line for if it's a backup. I used dotted dashes if it's a trunk, if I expect to have multiple VLANs over that. So for me, I do things, and so try to figure out how you can actually, for your most critical things, have diagrams or crime scenes that quickly pop. Find the suspects. Find the suspects is gather the facts, collect the clues, follow the evidence, interview the witnesses, question the suspects. I actually found this years ago on the web for how law enforcement is taught. So they're actually gather the facts, collect the clues, follow the evidence, interview the witnesses, interrogate the suspects. I just changed that. So this is what it is. You're going to gather the facts. You're going to collect the clues. Knowledge is fact versus clue. It can't be a clue until you have knowledge to differentiate between a fact and a clue. It is a fact that the traffic is going from New Jersey to Florida to California. It is a clue that you have knowledge that that's supposed to be the backup path. Knowledge is what differentiates a fact and a clue. And then that's the boring reading stuff, sorry. Follow the evidence. Oh, I will say this one thing. Whoopsie-daisy. Wow, this thing is, Dimitra, I love your clicker, but wow, it's very responsive. Okay, this is going to be me on my soapbox for a second, because I can help you, and that's what I want to do. I want to help you truly help and understand how to be a better network detective. I want you to be like, yeah, shoulder back, I'm going to protect the network. I'm going to tell you some things that are not technical, that are obstructions of network justice. Assumptions and holding a theory too tight. The security people will say, it's always the firewall. Right? Networking will say, up, it's the firewall. Firewall people, up, it's the network. When you hold these theories too tight, you are no longer open. Imagine if I was actually in law enforcement. And that's the different thing that we have, and we have to actually figure out how to handle that, right? If you were my cousin, and I'm supposed to investigate you, I have to recuse myself from that investigation. And yet in our environment, it's our network, or it's our firewall. And so we end up having that come into play because of fear, pride, silos, whatever. And as long as you accept that you have fear, pride, or silos, that's fine, and understand that they are obstructions to network justice at times. Because it's your network that you're actually investigating. That's why it's so much easier to say, oh, it's got to be the firewall. It can't be us, you know. But then when you do that, you're wasting time, you're hindering. So inaccurate crime scene maps, inability to differentiate fact from clue, silos on the team and network. How do you work together when the packet is going from here to over here when we don't have transparency? When I can't really contact, okay, let's pretend I'm the silo, that you can't really contact me because I'm like, yeah, okay, you know, no, it's not the network. Why do I even bother talking to you? Now, some things we can do about that and some things we can't do about that. Maybe talk to that person when you're not having an emergency. Maybe thank that person or ask them, can I understand a little bit more, because you're truly trying to understand, not because you're trying to figure out how to blame them later. Don't do that. Be pure of it. We're not stupid. We catch on. Not being methodical. I actually have to do something in my environment. So in my environment, I do CPOCs, Customer Proof of Concept Labs. And we're under the gun, and there's been times I've slept on the floor or overnight because things weren't working so great. And what I have done, and I have learned not to do, is I will actually start troubleshooting. And we have what's called the 1 hour rule that I like to try to encourage people to do. After 1 hour, remember, I'm not a production environment. After 1 hour, I have to be able to go to someone else and pull them in. There have been a lot of times that I actually pull somebody in because I think it's a bug or something, right, or I need escalation. Well, did you try A and B? Yeah, I did. Did you try A before B or B before A? I don't remember. So what I will do is I'll start trying to troubleshoot something, and what I'll do is I'll do like the first pass, the second pass, and then after 15 minutes, sometimes it's 20, and I'll actually set a stopwatch, and the people in my room will actually be like, you want to time yourself? I'm like, sure. And after 20, I will start documenting. I will start actually writing down. Admittedly, I don't do it for the first 15, but if I haven't quickly figured it out in 15 minutes, I will start writing down what I did. Because the only reason not to do that is pride. So that's not being methodical, and of course, fear and pride. And these really are obstructions to network justice, and you can clearly see why. It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. Sherlock Holmes, or should I say Sir Arthur Conan Doyle. So this is very, very true. We hold a theory and we'll hold it too tight. And what will happen is I'll have a theory in that first 15 minutes. And while I teach these classes, I have to actually hold it very loosely. First opinions are crucial, but if the evidence changes, so must the theory. Basically, let the evidence guide you. Let the evidence guide you. It's very difficult, but let the evidence guide you. It is especially difficult because the law enforcement doesn't necessarily have two failures or cascading failures as often as we do, right? So we might actually have something like a router's been in Rahman for a month, and then you have a problem. So now we have two things. So now they're very, very different when we're troubleshooting them, and we're looking for one thing. If you let the evidence guide you and you follow the evidence, then you can be more open to it being two things as opposed to one thing that happens to fit both of those facts and clues. Okay, this is my troubleshooting methodology. So what is the problem? Gathering facts. Where is the problem? So this is basically, if I were to break down what I do when I'm troubleshooting, I do the first pack. I'm looking for quick confessions or the obvious clues. Well, I've already paused now. I would say smoking gun, but I don't want to bother people. So I'm looking for basically the quick confessions or obvious clues. I'm looking for something in Rahman. I'm looking for something with high CPU. I'm looking for something that I don't have the route on the other side. That's my first pass. My second pass is now I'm starting to document. Now I'm on a scavenger hunt for clues. My third pass is I'm preparing for deeper troubleshooting, and then we have the stakeout. So understanding the easiest one really is if it is happening right now and it is 100% failure, or it's happening right now and it's 50% failure. The very difficult ones are the intermittent ones. And obviously, so you've got to start asking things like, what are the patterns? What are the commonalities? Is it only happening to Windows devices? Is it only happening to Mac? And you might only have a small period of time to try to figure that out real quick. And then you have to pause and come up with what your plan of attack is for when it happens again. Your triage of what exactly you're going to do. So is it all Macs? Okay, well, let me just get into a Mac real quick. You know, so you have to plan when you're going to do the stakeout. You have to plan in advance where you're going to be and where you're going to position people for the stakeout. Just like if you were in law enforcement. I love this one. What has changed? I was in TAC. I will also be escalation for people, and I will walk into other people's rooms, and they'll be like, nothing changed. What you're really saying, if you don't mind my saying so, is nothing that you think is relevant has changed. Now, that's going to get back into, if you don't mind my saying so, fear and pride. Mostly pride. A little bit of fear. So there was one time where I actually had to write a bug, and I could recreate it. So I knew that I went in, I shut the interface, I put a description on, I put a config on, and then I no-shut the interface. And I knew that I could make it happen because I did that. When I created the bug, every fiber of my being wanted to not do what? Oh, I put a description on the interface, by the way. Oh, this person's an idiot. I don't know the code. I can't do that because then I'm doing exactly what I'm telling you not to do, which is give all of the facts. You give all of the facts to law enforcement. Give all of the facts. All of them. Don't hold back. If you're holding back, ask yourself why you're holding back. For me, putting the description, that was pride. This is my first pass. I go through and I do a quick green, yellow, and kind of figure it out. I only actually stop if it's red. Like if this is Rahman, that's red, I'll stop there. The orange, I'll just continue to go. because I'm looking to see if there's any other reds. Now, if this is ROM-mon, but this one's passing traffic, then I'll just pass on. I'll make a note of it to go back, but that's not the culprit. Second pass is going to be a scavenger hunt for clues, so I'm going to go into each one. I'm going to do show commands. I'm going to have commands that I already know in advance that I'm going to do. And I'll be doing the same thing. Preparing for deeper troubleshooting. Documenting becomes critical. You need to know that you did this and then you did that. I have actually had a number of problems in the past where it was actually a timer. And we were like, well, we pull the supervisor out and we do this and we do that. And then we realized that we were talking for a while, trying to figure out what it was. So we pulled the supervisor out again, and it didn't happen that time because we weren't taking into consideration that we were talking for longer. So it felt more intermittent to us. When you're doing the stakeout, have a plan. Please be methodical. Document the stakeout. Use your NMS tools. Question the suspects. I'm just going to tell you right now, question the suspects, forget about it. If the suspect is French, I have to speak French. So the suspect gets back into what is your subject matter expertise. You really have to be able to ask them the questions. So what I find is the be prepared, tons of space there. The find the suspects, tons of space there. The questioning the suspects, once you actually have them, gets into needing a subject matter expert once you actually have a red flag and you really think it's him. So that one is you really need to know the modus operandi. You need to know how to question them, and you need to know what normal is. Like with that ASR 1000, you don't do show CPU because that's way up here. I'm asking the wrong level in that box. So question the suspect is a lot harder, but you can get a lot of improvement in other areas. And then I'm going to say improve. I know, it absolutely stinks. Everyone's doing more with less, right? And then you've got the next fire to fight. And it's hard. Maybe just write something down, you know, to remember to take that static route out. So my view is that insanity is doing the same thing over and over again and expecting different results. Here is my honest view, and this is in my personal life as well. Every failure should improve the procedures. Every failure that you have at work, every crime scene that you have in work, has the potential to improve the procedures, as opposed to, oh, well, you know, I mean, we gave him admin access, and that was just a really dumb thing, and we'll never do that again. Poor guy. But so you'll find yourself wanting to rationalize that it won't happen again. Try to stop yourself on that. So what I want you to do is when things happen, I want you to go backwards. And there's one more thing I want to say. How could you have prevented it? How could you have better prepared? How could you repair faster? And I'm going to say document and question. So how can we prevent this in the future? Well, we could if we had HA, but okay, you don't have the money for HA. Fine. If we can't prevent it, how could we better be prepared? If we are as prepared as we can be, how could we get to repair faster next time? Please, I'm begging you. I'm really begging you. And I'm going to tell you, if you feel that it's another company's product that you could help to get repair faster, I don't care. Just protect the packet. One last thing is when people come into CPOC, they're usually coming in looking for single point of failures, convergence, and everything. And they're wanting to test to figure out whether or not, what are the weakest links in their networks. You know, you pen test, you do all these other things also, right? Now, I'm just going to go ahead and say, and how can our network be improved? I'm just going to go ahead and say right here. The packet rides on top of the network. The network is all us engineers. Okay? So, and that is on top of the network engineers and then management and policy. So if you are management and policy, what I'm going to say is please stop doing the dive and catch awards. Because this young man here, he's always like, he's sleepless. He doesn't sleep at night. And what he's doing is he's trying to think about how to save 1 second. He's being proactive. Don't forget about the people that are doing incremental little things as opposed to the diving catches. Because if you reinforce diving catch awards only, that's the environment that you're going to be creating. Try to go proactive. If you're a team leader or something like that, try to go proactive and try to not have the reactive. Single point of failures, okay? So, bandwidth of the IT staff, are they being utilized efficiency? Can you get enough bandwidth out of them for the job done? The CPU percentage, what is the most, what are they doing? Is that okay? So the same questions that people come to ask me, what is the CPU of this router doing? Is that okay? We never seem to do that with the humans. And yet the packet and everything rides on top of them. So what I would say is at least try to pause your quality of networking documents. How can you get to faster troubleshooting? What are the single points of failures on your team to support that network? And other than that, what are the weakest areas? How can our network be improved? I usually write down what my usual suspects are. So for whatever your subject matter expertise is, these are my usual suspects. This one, too many chefs in the kitchen because we'll have SEs and customers. I had a customer one time come in and they're like, they cleared the config. I'm like, we just had all that for you for the multicast. It's like, don't stop touching the routers. But too many chefs, and then things like these are my usual suspects in a routing environment. So I'm going to ask you, what are yours? Right? Think about what your usual suspects are. And again, prevent, prepare, repair. And what can you do to help protect your network, because each and every one of you are a network detective. Thank you.
A very nice afternoon to everybody, ladies and gentlemen. Welcome to the session about OSPF LSA Types made simple. My name's Peter. I am currently with Cisco Training Bootcamps team, so I live off of trainings. I do hope, though, that this session here is not going to be too boring and too bookish. I have to say, though, that OSPF LSA Types, as you probably all know, who try to work with OSPF, or try to troubleshoot OSPF, or even learn it for certification purposes, you know they bash them over your head. And they give you those lists, and then you wonder, why are there so many? And what do they do? My goal is to try to explain why they make sense the way they are invented. I cannot simplify them too much, but if you understand why they're useful, that's what it makes all of click. I call this session, also known as OSPF is a jigsaw puzzle freak, because that's exactly what's happening. By the way, anybody here likes to put jigsaw puzzles together? Some of you do. So imagine something like this, a simple topology of 3 routers. Imagine now that this was a picture we were supposed to put together from a couple of jigsaw puzzle pieces. So it could look like this. One jigsaw puzzle would be there for this R1 in the diagram. Another jigsaw puzzle of the same type would be there for the second router, and yet another one would be there for the third router. This is how OSPF sees the world around itself. Every network object is a jigsaw puzzle. And as it turns out, different types of network objects are different types of the puzzle pieces. What if I had this type of network? So just 2 routers, a switch in the middle. Well, what OSPF often does here is say, one of the routers is going to be one jigsaw puzzle, fair. The other router is going to be a second jigsaw puzzle, also fair. And imagine that the network itself might be a jigsaw puzzle on its own, and I'll explain later why that's a good idea. All in all, when we talk about the link state advertisements, this is what they do. They put together a map of the network. To OSPF, they're the lifeblood, they're the knowledge, they're the conscience. Because OSPF really doesn't care about addresses. Did you know that? OSPF doesn't care about IP networks. OSPF cares about topology. It wants to know precisely. And so that it can know, it needs to know precisely what the routers are and what their interfaces connect to. It's a freak about detail and a freak about topology. It wants to create this mind map inside its memory so that it knows precisely how the network looks like. And that's why it pieces together the understanding of the network's topology from these jigsaw pieces, the LSAs of different types. And we have a jigsaw puzzle type that represents a single router and its immediate neighborship. We have a jigsaw puzzle that represents a multi-access network that connects 2 and more routers together. We have a jigsaw puzzle that represents a prefix somewhere else in another area, but still internal to our domain. We have a jigsaw puzzle that represents possibly an AS, autonomous system boundary router, that connects the whole domain to an external world. And we have a jigsaw puzzle that represents the networks behind that router that connects us to the external world. Notice how the scope grows. A router, a network between routers, prefixes from other areas, our border connections to the outer world, and whatever is outside behind those connections. That's what the LSAs do, and this is why they are also sorted in this way, because these are precisely type 1 to type 5. So let's go and check what they do. The first type is router LSA or LSA type 1, who originated every router for itself. The LSA describes someone. Whom does it describe? The router itself. It may sound a little redundant, but we will have LSAs that are originated by a router but describing somebody else on its behalf. And what does this router LSA contain? Information what this specific router is connected to. All right? So, let's check a topology. Let's assume I have these 2 routers and this zigzag connection is a point-to-point link like the old serial ones we used to use 15 years ago. Okay? My question is, how many LSA types 1 would be in OSPF running here? 1, 2? Remember, each router generates 1 for itself. So it would be 2 here, 1 for R1, the other one for R2. What would R1 say about itself? I can hear router 2, I'm connected to it, so I will point to router 2. That's what we do in that LSA 1 over router 1. And what does router 2 do? I can hear router 1, so I will point back to the guy. Notice that we have those arrows, they have their direction. We always need to follow the direction. And this is also why they are independent, why we can have also, it's not a good idea, but we can have different link costs from each side. They would be reflected on those individual arrows depending on the direction. What about here? How many router LSA type, well, LSA type 1s, router LSAs would be present here in this topology? 3, perfect. 1 for each router. And what would they say? Well, router 1 is only connected to router 2, so there would be just a single pointer, single link. Router 2 in the middle connects to both the guys, so it would point to each other, like this. And router 3 would point back because it's connected only to router 2. Notice that when you follow those arrows, you can get from anywhere to anywhere else. This is important. And what about this? So, how many LSA type 1s? 3 again, nothing new. And they would each point to each other. 1 points to 2 and 3 because they are connected. 2 points to 1 and 3 because they are connected. And 3 points to 1 and 2 because they are connected. In fact, it would seem that with these router LSAs type 1s, you can describe any arbitrary topology. Technically you can, not always efficiently, but you can. We can do something more efficiently with the second type of LSA we call the network LSA. And if you don't mind, let's take this as a, for comprehensive purposes, but let me go to a diagram. It's going to be more simple to explain why we need this network LSA type 2. Imagine I have a network that looks like this, 4 routers on a common network. If I wanted to use the previous approach, how would the mental model of OSPF of this network look like? So always, first question, how many router LSAs would be here? I have 4 routers. So 4 LSA type 1s. And what was the previous approach? If I can hear the other router, I will point to it. So here everybody can hear everybody other, right? So 1 would point to 2, 3, and 4. 2 would point to 1, 3, and 4. And so on, and so on. And the model would be workable, but quite dense if you think about it. And there are algorithms that need to visit what we call the node and check every single neighbor, what happens there if I can find a cheaper route. Well, this is a densely populated node, and it takes memory, and it takes CPU space. However, this represents the connectivity as it truly is. And that's why this is also what we use on the OSPF point-to multi-point network type. You remember those hub and spoke frame relay stuff that we used to do. This is precisely the ideal mode of operation because I won't assume a connectivity. I need to hear from the guy, and then and only then I will put that connection there. But this is a little pessimistic approach. Well, what if I could create a mental model of the network as it truly is? And what is the true model of the network? 4 routers with a common segment between them. So let's try to do that. I will need those 4 router LSAs because they are about routers. But I need another piece of puzzle that says I am a network. Essentially, I'm quite stupid because I'm just a cable, but I'm connecting all of you together. And this is the LSA type 2, the network LSA. And what do we do now with those links? Well, every router is connected to the network, so the router LSA will point to that type 2 LSA. And the network will say, I am connected to all of you guys. And again, if you follow the direction of the arrows, you can get from a router into a network and to any other router. So again, it's fully connected. But wireless, the top approach needed 4 times 3, 12 links. Here down, you have 8. So it's not as computationally complex and not expensive. This is the network type LSA. It represents a multi-access segment because it allows us to create a simpler mental model of the whole network. And who generates the LSA type 2? The designated router. That's why we elect it. It's the designated router that is responsible to speak on behalf of a multi-access segment in the link state topology. By the way, would it make any difference if there was another switch here and those 4 routers have been somehow split between those 2 switches? Would it make a difference? To this network model, no, because all I care that in the middle is a shared medium that connects us all together. That's why. And now the combination of all the router LSA and the network LSA allows us to precisely and efficiently create a mental model of any topology inside a single area. And that's what we do. So, without talking probably too long here, this is what we would do. 4 router LSAs because I have 4 routers. 1 network LSA because I have 1 multi-access network here. And the links, well, router 1 is connected only to the network and to nobody else. So there you go. The same for router 2. Router 3 is connected to that network and also to router 4. And router 4 is connected back to router 3. And this would be the model of this network. And once again, this is all you need to represent any kind of routed topology inside a single area. You don't need any other LSAs. Yeah, of course, the network also has to say that it connects back. One comment now that we're on this. What do you think would happen here if I did what we do today? 3 routers, but Ethernet connections. Yes, physically they're just crossover cables or fiber. They are point-to-point, but they are Ethernet. What's going to happen? What do you think is going to happen by default in OSPF? Type 2, yes. Let me show you. This is the point type. OSPF knows that Ethernet can be a multi-access network technology. Yes, there is only a single router, but where's the guarantee there is not going to be another one? So there will be 3 or 4 on the same segment. Therefore, by default, it works on this multi-access network type, and it complicates the network model as is shown on the bottom topology, because for both of those networks there, it creates this network LSA. By the way, IS calls it the pseudonode, and it's precisely the same thing. Precisely the same thing. And the mental model of that network would look like this. Is it simpler than the top topology? No, not really. Here is OSPF getting a little over-engineered. This is why it's actually advantageous if you know that you have physical point-to-point connections between routers. Also configure them as IP OSPF network point-to-point. You don't lose 40 seconds on DR-BDR elections, and you don't necessarily create those network LSAs that, in this case, don't simplify anything. All right. Let's move on. The third type of an LSA is called summary LSA. Now, this LSA is there to represent an IP prefix that exists in a different area than myself. Who originates it? The area border router that connects to that other area. And what does it contain? The information about the prefix, so the subnet address, the mask, and the distance or the cost from the originating ABR. So let's have a look. Let this be our topology. We have area 0, consisting of just 3 routers connected with a common switch. And we have area 1 that contains essentially 4 routers, 3, 4, 5, and 6, with point-to-point connections. And now remember, every area keeps its own independent link state database. Every area sees the whole network differently. It sees itself in detail, and whatever is outside, it's a little cloudy. So let's see what the routers in area 0 see. I'm talking about area 0 now. So again, my question, how many router LSAs in area 0? 3, because there are 3 routers. How many network LSAs in area 0? I'd say 1, because there's 1 such network. Okay, there we go. Let's have them connected the way they should be. Perfect. However, router 3 is also an ABR between the 2 areas, and it knows that there are additional networks X, Y, Z, and Q somewhere in area 1. We have implemented areas because we don't want to see the topology of the other one, but we still want to be able to route there. So while I don't want to carry over topological detail, I want to carry reachability information. This is precisely what the LSA type 3, the summary LSA, does. It represents the networks that are somewhere else, and where they are, well, behind my ABR that is connected to that area. And this would be the mental model of the network as area 0 sees it, of the whole domain. It knows itself perfectly, and as far as the faraway areas are concerned, I don't know nothing about the topology. I just see the networks that are present there. By the way, what would you believe would happen if I had multiple ABRs between area 0 and area 1. The question is, what would happen if I had multiple ABRs connecting area 1 and area 0 together? What would happen is that each of them, on its own, would advertise the prefixes in one area into another. And you would simply be looking at the total cost, because each of the ABRs may be closer to some networks and more far from some others. So you would use that one that appears to be the closest one. All right. What about area 1? Remember, area 1 sees things differently. What do they see? First of all, how many router LSAs? I'd say 4. The connections would be point-to-point because there are no shared segments here. And there is one network called network A in area 0 that area 1 doesn't see in detail but needs to know about so that they can route there. So there would be an LSA type 3, the summary LSA, injected by router 3 into area 1, representing some network in area 0. And that's all. This is what the area 1 would see. You're starting to get the hang of it. It's now getting a little repetitive, I know. That was actually the goal, because if it gets repetitive for you, it means you're starting to understand. Thank you. Now, I am intentionally skipping LSA type 4 for now, and I'm going directly to LSA type 5, which is AS external network. In simple terms, those are the prefixes you have redistributed into OSPF from somewhere else, a different protocol, or connected, or static. So let's modify the topology a little by adding some RIP domain above router 5. And there would be some networks, I, J, in the RIP, which you happen to be redistributing into OSPF on R5. And my question is, what happens in area 1? Now, all the process again, how many router LSAs? 4, because we have 4 routers, members of area 1. What their connections would be, they would look like this. By the way, you notice that I rearranged the diagram a little, but it doesn't matter where I put those nodes as long as those arrows go to proper devices. Of course, there would be information about a network in a different area, in this case, network A. But there would also be those 2 redistributed networks, I and J, that come into OSPF and that have been redistributed by R5. So R5 would be pointing to them. And this is how the area 1 would look like. I suppose pretty simple. But before I go to LSA number 4, I need to emphasize one thing I didn't mention so far. LSA type 1 and 2, router and network, they don't cross area boundaries at all. They simply don't leak. LSA type 3, the summary LSA, it gives you the feeling that it floods from one area to another. In reality, every ABR recomputes it and generates its own because it has to increase the cost, right? So not even LSA type 3 is flooded across areas. It's just regenerated on area boundaries. LSA type 5, pardon, the external one is the only LSA that is flooded across area boundaries without any change. Nothing gets updated, absolutely nothing. Not the advertising router, nor the cost, nor the type, nor the prefix, nothing. And this creates problems. Let me show you, and again, there will be a slide, blah, 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 but what I want to show you is the problem that we get with the fact that we flood LSA 5, the external route, and not change it. The question here is, what is area 1 going to see here? So again, the tedious 3 routers, 1 common network between them, all the connections as they're supposed to be. The inter-area routes from the other area. And remember, we got the external routes flooded, but now we have a problem. They have been originated by R5, and that's written in their header. That's their originating router. But inside my area 0, there is no knowledge of R5. Where is it? Who is it? Which way? I don't know. So I cannot associate these external network, these pieces of puzzle, with any existing stones of puzzle because I have nowhere to put them in. I don't know where. So this is the question that I have to solve, and this question gets solved precisely by the last type of LSA, which is the LSA type 4. It's also called summary LSA, but instead of describing networks, it describes autonomous system boundary routers in different areas. All that it says is, or all it contains, is the router ID of a faraway ASBR somewhere in another area. Because if I now know that it exists and that my own ABR can reach it, I know where to look for the external networks that are supposedly behind it. And this completes the whole set of LSAs as OSPF classically uses them. Routers, common networks, networks from other areas, boundary routers in other areas. Notice that area 1 didn't need it. Area 1 had knowledge through LSA type 1 about the ASBR. And the external networks. Now for those who are familiar with also area types and maybe OSPF v3, a few closing remarks. First, those of you who know about type 7 LSA, or sometimes called the NSSA type of LSA, that one is in format identical to type 5, external routes. It's used in area types that want to distinguish between external routes in the backbone and behind it, which they don't want, and their own external areas they privately bring in and they want to keep. Because it would not be possible to tell apart my own external networks from the backbone's external networks. We simply advertise them in a different LSI type. But if you looked at it, format bit by bit is identical. So that's what the type 7 sometimes is used for, and it's for the so-called NSSA area types. If there are IPv6 aficionados here, they will point out that I may have not been entirely precise. And thank you, because truly I have not been. This information is about OSPF v2. OSPF v3 that was originally created for IPv6, it had to be because the old version simply wasn't able to do IPv6 stuff. They decided to split away the topology information and addressing information. This is something that ISIS, by the way, already does. And this allows avoiding recomputing the whole shortest path tree if all that changed is just an address, but links haven't moved, which is a perfect thing. So in OSPF v3 for IPv6, you only find information about who you connect to. Only the topology. Addressing is moved out into yet two another LSA types, the so-called link LSA, which only gets advertised to your immediate neighbor, and there it ends. It's not even flooded across a router. It contains the link local addresses and on-link addresses. And the true IP addresses on the loopbacks, on the interfaces, on the interconnections, are then carried in yet another LSA type, which is called the intra-area prefix LSA type. The basic idea, though, still holds for OSPF v2 and OSPF v3. Think of it as putting together pieces of puzzle, and if we created a separate piece of puzzle, it's because we want to describe a specific network type that needs special treatment. With this, thank you very much, and if there are any questions, I'll be available.
We have, yes, perfect. There's 2 more minutes to go, but of course I like to take even every second I can get. Otherwise, I mean, you will not be leaving within 30 minutes. People that have met me before, I can talk forever on this subject. So here's the cool thing. So I'm having Slido up now, and I just want to see where you are coming from. And also the main reason, because then you can already test yourself if Slido is working. And because after I've done my presentation, there will be a quiz in order if you have to pay attention what I have been saying. Potentially, there could be a question left or right that might have been a little bit cheeky. Besides, if QR code from the distance doesn't work, open the browser, go to slido.com, and then type in help. That's how I generated. And I'll let you know, and the prize is sitting waiting for you here right now. It's a 3D printed IPv6 stroopwafel with moving legs as well. So what not to like? Make sure that it doesn't tip over. So we have a lot of people from Germany. I see Iceland, and I see some people are sort of, sorry that they come from the Brexit land. The first host in /64, I love that. That's really awesome. We have Sweden, Italy, Zandvoort. Ooh, we have a Formula 1 fan. 2 more years. Wer komt hier nog aus Kiel? Delft. Perfect. I love the answers. Amsterdam, Italy, ciao. I was about to say buongiorno, but buongiorno is a little bit too late for that. USA, that's the far end. Home, Poland, I think Stuttgart. So I think we have EMEA well presented, and then a little bit left and right. So that's cool. I will quickly go out here and we'll IPv6 Groove with a little bit help of my friends. Who loves IPv6? Raise of hands. I was about to say who hates. Who says, Nicole, I really do not need IPv6 and dares to raise their hand? Good. No. At least you are still entitled for a stroopwafel. No.
I'm afraid of IPv6 category.
Okay, and so no, that's a very good. The gentleman up front up here says, I am in the category I'm afraid of IPv6. Thank you for sharing. And by the way, you know what? I'll give you already for comfortness. You already get a stroopwafel, so this already feels really good. So let me first tell you about myself. So my name is Nicole Wajer. As you notice from my accent, I'm from the Netherlands. Fun fact, I am born and raised in this area. So the Rij is my home ground. Born on the Churchlaan, went to the Polytechnic. Unfortunately, that's burned to the ground, well, because there's another glass building on the other side of the hotel. On the other side of the Beatrix Park is where I went to high school. So this feels like home. Fun fact, 2026, we are still coming back. And that's a fact, so you know. I love IPv6. I can talk forever IPv6. I do need to keep it in the next 27 minutes in order to make sure the next presentation comes in. But besides IPv6, I also love my Formula 1. Now, one of the things, you know, I also like broccoli a little bit. I'm also known as the Chief Stroopwafel Officer within Cisco. I am the CSO of Cisco, and two of them combined is the perfect combination. I mean, what's not to like? For the people that've never met me, and for the person that's still a little bit afraid of IPv6, the one thing you should remember of IPv6, it's broccoli. If you go home, your damager asks you, what did you learn? The key would be broccoli. They probably go like, did you get the flu or something? Because that's potentially something that could happen. Broccoli. I'll explain you later why. Of course, help, you know? This long 120-bit 8 address, I mean, it fits to the whole, I mean, I am even, you know, not big enough for the 128-bit address. And this is scary, right? Because, I mean, we all have been working in the legacy protocol world. Yes, I said that. Because we run out of IPv4 addresses. My brain cannot even say IPv4 anymore. It's the legacy protocol. It's not sexy anymore. It's that 128-bit address. Is it scary? Of course, because it's massive. But it will be, once you dip your toes in the water, you'll be fine. It's the same what we did with the legacy protocol. Remember that first time you saw those addresses and thinks, how am I going to subnet? Network address, broadcast address. Oh my God, how do I even remember this? Well, guess what? You remember now. Same for IPv6. So help, right? How am I going to do this? Well, ask a friend. Can we know? I mean, yes, I did a little bit of AI in here. The legacy came back, giving you some help. Because there are a lot of people around you here already trying to help you explain how cool v6 is, and also explaining that this 128-bit address is really nice. One of the first things then in the past when I started talking about IPv6, oh, what's the business case, right? And that's the first, sorry, but that's always like, everybody's like, oh, what's the business case? Well, it's cool. You can do much more, it's scalable, and that's not the business case. Well, guess what? We have a business case. Did you know already since last year, AWS is charging you for the legacy protocol? 42 € and 20 cents. And yes, I put it on purpose very tiny. Hint, 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 pay attention. 42 € per year per legacy IP address. That's a lot of addresses. v6 is free. For the Dutch people, Germans as well, we love free. That's super. Did you know that there are customers? I met them last year and the year before. They acquired /24s of legacy addresses. And they said to me, Nicole, we are still trying to whitelist them. They've been abused so heavily that we can't even use the legacy IP which we acquired. I said to them, you could have used that budget, you know, to deploy IPv6. Or, if there's any CFOs here in the room, I have a good proposition here, a value proposition. If you own a /16, right now you get good money out of this. And do it now, because in a couple of years from now, this will not be able to sell off as much as Bitcoin would say. Why? Because there are strong mandates. Germany has a massive strong mandate. As of this January 1st, IPv6 only needs to be there. And we all know about the Germans. They're gründlich und pünktlich. They take it serious. Whereas the Netherlands, you know, explain and comply. Oh, yes, sure, fine. And then move on with life. So can you just imagine? So these are a couple of reasons, let's say, to talk to management, because that's one of those things. But seriously, right? Help. You know, you really need someone in order to get yourself going, get yourself knowledgeable about this 128-bit addressing. One of the cool things with this 128-bit address is that you don't have broadcast anymore. You don't have ARP anymore. Why is that cool? Because now all of a sudden you do not need to think in subnets. Whereas in the past you would go, how many hosts are on this wireless VLAN? Ooh, I have a university. I have 1,000 in the small university. I have 1,000 on this space. Ooh, I need to subnet this, and oh, I can't use the first, and I must make sure that I'm not configuring the broadcast domain. That's like pain. In IPv6, you have use it all. And here's the best part, a /64, 18.4 quintillion addresses. A 1/64. I can safely say you know, the help, because it's like, help, that's a lot of addresses, Nicole. I should use this /64 for my branch. No. Leave the legacy thinking away when you do IPv6 address planning. Because that will be your, how do you say, your point where you really struggle. If you keep that legacy thinking, you will not be able to expand the whole lake of availability of IP addresses you have in your environment. And I'll say it again. Leave the legacy thinking home. Why? Because you will not. You will at some point think, Nicole did say this. Because it's so grained in, it's so like IPv4, but legacy, legacy, legacy comes after a while. Unicorns, right? So it's not just anybody, you know. Can you just imagine, so like I said, so on the Churchill-Aan, because the legacy protocol, you know, was already there when I was born. And fun fact is that over the years, when I was going to high school, also already IPv6, they knew they were going to run out of the legacy protocol. And IPv6 is already old enough to drink. As of December 1998, when it became an internet draft, we are here. See, Nicole, it's already been for years, and we haven't done anything yet. Well, we did. Fun fact, you know, in 2018, the first of the people that always said to me, oh, nobody's using IPv6. What do you mean nobody's using IPv6? I mean, seriously, what do you mean nobody's using IPv6? February 25, 2025, 45.87% of Google traffic is IPv6 native. What do you mean nobody's using IPv6? I'm teasing you, of course. Because what really happens here is that it just works. We made it so cool that it just works, like a charm. And if it doesn't work, we also made sure that you don't know. Because show us of hands. Who is currently running IPv6 in their network? So we have 1, 2, 3, 4, let's say, people are some, am I, yes, should I raise my hand? Are we, he's talking to his admin. Are we running IPv6? Yes, no, maybe. 50% raised. So 50% raised the hand, and the gentleman up front said, some of us not intentionally. Because the people that didn't raise their hand, and if they have Android, Linux, Microsoft, Windows machines in their network, and guess what, everybody has that, the IPv6 stack is default enabled. You are all having an IPv6 address as we speak, including in your company. And the scary part is, most likely, on the local link, you are communicating with each other without of your knowledge. When the IPv6 stack is enabled, you get something that's called a link local address. That's the first standard link what you get, and you will see it in your interface as a Fox Echo 80, FE80. So this is your IPv6 enabled, and this is how all the mechanisms start to work. Everybody right now here in this room, and including, by the way, just outside on the walls, are all having an FE80. We are currently communicating over IPv6 with each other, because IPv6 takes precedence over the legacy protocol. RFC 6724 address source selection explains the reasoning why, whereas in a link local address and a global address takes precedence over the legacy protocol. Hold on, but Nicole, I am really planning to deploy ULAs in my network, because those are the best, because I'm running a 10 address, I need to have ULAs. I would say, I would rather strongly encourage you to look into global addressing, because right now, at the time that I'm speaking here, ULAs in a dual stack environment, so legacy protocol, IPv6, ULA have a lower priority than the legacy protocol. This is scary, because this means that when I'm trying to connect to Netflix, because Netflix is IPv6 only data center, anybody that struggled watching the fight with Jake Paul and Mike Tyson, and they had buffering issues, you are on the legacy protocol. If you had IPv6, most likely you did not suffer from carrier-grade net. Did you suffer? I see the eyes like, oh, was that the reason? So, in the ULA and legacy protocol, that means you do not know whether your IPv6 is working. Because you know what? Because the journey really is, you go from an IPv6 only world, it's really comfortable to stay in a dual stack environment, but your end goal is to transition to IPv6 only. And here's another one. So besides me talking about the legacy protocol, transition. I don't say migrate, because we're not migrating here. Birds migrate. I do not want you to come back. Birds come back. Fun fact, last year a customer in Germany, they looked at each other, they saw the same joke, and they looked at each other and said, oh, we are migrating to the cloud. They did want to come back. So these are the little bit of the steps which you really want to take forward, pardon me, sorry about that, in your environment. And it's a scary part, the IPv6 only. Because who has a phone, who has a new phone since the last 5 years? You know, got a new iPhone, new Android. I mean, at least it's everybody, 5 years, because then definitely the old phones tip over. And so keep the hands up there for a moment. I'm still surprised that not everybody has, yeah, exactly, everybody. So keep it up. Who still has their old phone? Exactly, yeah, exactly, right? Because you're like scared to, there might be still something on there because we don't know what's working. That's the dual stack, because people are scared to turn off that legacy protocol. However, the challenges are real, right? Or its struggles are real. Because if you want to go to an IPv6 only, you need to think of, okay, DNS issues, NAT issues, because you need to maybe definitely need to go DNS 6.4, NAT 6.4 to serve those legacy addresses, because if you want to watch X or go to GitHub, still legacy enabled, because they haven't moved yet to the cool stuff. What am I accessing? Are they v6 capable? But then also on the IPv6 only side of the space, how is the service offered? For any developers here, IP literals, pain in a very dark area for the networking people, because hard-coded legacy addresses are not fun. I need to be careful. So, these are the challenges if you want to go to an IPv6 only network. And so in the ITF, Google decided, we need to make this also a little bit more transitionable. How can we really, figure out, okay, the hosts that are capable of doing IPv6 only and showing that it's really working. So RFC 8925, they said, what if we have these hosts and they know that they can run on IPv6 only and not giving them a legacy IP address? That's the short version of what this entails. And how does that look like? Because now the transition to IPv6 only comes a little bit different. And this is where IPv6 mostly comes in play. So what's needed, Nicole, for this IPv6 mostly? It needs to be stateless address auto-configuration. Because keep in mind, there's this well-known operating system, Android, that doesn't do DHCP v6. It will never do DHCP v6. Don't ask me the when. You need to have, of course, when you are doing in the v6 only, you need to have, of course, a mechanism to make sure that you're still accessing legacy addresses. So DNS 6.4 to make it nicer, not 6.4 as well for those legacy destinations, because you need to keep everybody happy. So one of the extra nerd knobs, not 6.4, router advertisements with pref DNS 6.4 and pref 6.4 and DNS 6.4. Last but not least, a centralized DHCP v4, because you still need that. Because you want to make sure that all the clients are happy people. So how does that look like then? So how do these clients access? So here we have a client, and this IPv4 only client will get a legacy address from DHCP v4. Old people happy. Good. They can retire soon in the next 5 years, or better tomorrow, but let's hope. However, here we have a host that is capable of doing IPv6 option 108. So this is in the RFC 8925. And it says, I'm the cool kid. I can do this IPv6 only. I don't need that legacy shit. Sure, I hear you, DHCP v4, but keep that legacy address to you. So the DHCP v4 says, I still have it for you. I will not give you a legacy address. And I'll come back to you what that X amount of seconds means. Because, Nicole, then what is a client that is capable of IPv6, but not sending the option 108? Well, it gets an IPv6 address through Slack and a legacy address. So you have both. So the X amount of seconds it holds, it's keep the legacy running with a backup timer in case I do need a legacy address. So that's where that timer comes. So like, do you still need it? And mostly it's like, no, I'm good. I'm good. So we're all happy chappy. 3 options, right? Because the cool thing is that as of today, Android, iOS, Apple, macOS is currently doing IPv6 mostly. Unfortunately, Microsoft not yet. They are in the making, and Linux is mostly on Git right now, so it's also in progress, so coming back and forth. And so this mostly is sort of a nice path to go towards IPv6 only. So now, you know what? I sort of changed my mind. The NOC people also changed their mind. So this is an output of a Cisco Live address. And what do we have here? Remember, we have IPv6 enabled because Fox Echo 80. We have a stable address and we have a temporary address. That's always normal for privacy reasons in the IPv6 world. Then we have this 192.0.0.2. That's an old number. That's not routable. Huh. And then we have something that's called CLAT. Huh. At this moment, this host is running IPv6 mostly. All your iPhones here, all your macOS, right now, you are running IPv6 only. And if you haven't heard the mostly part yet, and you haven't noticed, welcome. This is capable. Are you still scared? I must say that when I told my colleague saying, hey, Brian, you have a Mac, right? Yes. I said, you don't have legacy. What? Because he's like, I always need it. And he's like, no, but you've been working fine. And this is, for the first time at Cisco Live, we are running IPv6 mostly, and it's going quite well. Intranet, we are running 72% of IPv6 traffic. And over 50% already to the outbound world with IPv6. And that's where we're still accessing some legacy addresses, but mostly of the people here are serving Google, which is also IPv6 only. Not Netflix here, but Meta things are all IPv6 related. So this is why you will see a lot of IPv6 traffic. So with 5 minutes left, it's quiz time. And let me get you the bigger picture, because that makes life easier again. To hold your screen, and remember, for the people that arrived a little bit later, there is a prize to be won. And then after the prize, I will tell you why IPv6 is broccoli. Let me, I still see your people. Actually, I can do this because I know that's perfect. So people can join the quiz. Let me see if people are still holding their phones up. Yeah, there's one person holding their phone up. Yeah, cool. And you can do any random name. So for people that haven't played a quiz before, it's timer based. And I did it on purpose. It's only 20 seconds, so not 30 seconds. So you need to respond quite quickly. The quicker, by the way, you respond, the higher you are in the ranking. So I'll tell a little bit about that. So the longer you think, but then again, it also depends on, the type of question. Potentially, you might need to think a little bit longer because I might not have mentioned it. So let me go here. Let me go out. Why didn't I want to go out? 1 second. Let me. Let me do. and slideshow. That's why. That's the cool thing. Cool. And oh, I see a stroopwafel there. Say 80 people registered. Let me give. Is there anybody raise of hands that's still trying to join? No? Okay, so here we go with the first question. Ooh, 84. Oh, well done. So first question. As of today, how much does AWS charge per year for a one legacy protocol address? So for people that have attended my CTF tomorrow, they know this answer already. And they also know. But a couple of cents, 42 euros, not my problem. My boss is paying $44, or I just bought a /legacy. I am good. I like it I really want to win. So yes. The reason why the first one is not correct, because the number is correct, but it's dollar cents and not euro cents. So yes, and apparently there's no boss paying anything. And 7 people apparently just bought a /24. So next question. What music was this presentation inspired by? The Rolling Stones, Robbie Williams, the Beatles, or the Dutch band called Golden Earring? I like the let's say it's the Beatles. I will say, help, I need somebody, help, not just anybody, help. Sorry, I don't, if I tell my husband that I was singing, he's like, no you didn't. Yes, I did. Okay, next question. What are we currently running here at Cisco Live for the first time? IPv6, IPX, IPv6 mostly. I'm not running at all. So cool. I like it that people say IPA. They probably think if I click quickly enough. So indeed, IPv6 mostly. So next question. Nicole said IPv6 is like the legacy protocol, a stroopwafel, broccoli, or sliced bread. And I have 4 more questions and I'm on 0. I need to. So indeed, of course, IPv6 is like broccoli. So we go to the next question. Oh, Nico, well done. No pressure. How old is IPv6? 26 years, 35 years, 10 years, or 40 years? Well done. People they saw it. It's indeed 26 years. What's Nicole's job title in Cisco? Nerd, system engineer, technical solution engineer, chief stroopwafel officer, or IPv6 specialist? Or all? Also, well done indeed. Chief Stroopwafel Officer. 2 more questions. We're almost there. Windows supports now IPv6 mostly. Yes? No? Mostly yes. Can you just imagine me having already so much fun making these questions? Correct. The answer is no, because it's still in progress. I dearly hope it's coming this year, but they did promise it was coming. So last question. Why do you need DHCP v4 with IPv6 mostly? because the legacy is cool. Nicole, you made an error in the question. Android doesn't do DHCP v6. It's not a matter of why. Back to the future. I love it when people just now like, I quickly. Correct, right? Android doesn't support IPv6. So let me quickly show the leaderboard. Oh, Martin. So Martin, who's the winner? Are you the winner? You need to sit because, but you will win. But at least the other people who are on the screen, they can also come here for a stroopwafel and a nice treat, because I just want to quickly finish off, because remember when I said at the beginning, one of the things you need to remember, IPv6 is broccoli. And the reason why it's broccoli, IPv6 is internet broccoli. It's good for you in the long run, but you do not get an immediate sugar rush by deploying it now. Keep it on the screen. I was about to say, so there's a WebEx room. I'm just waiting. There's another guy who's trying to quickly going through. Okay, I'll go back one more time. Quickly. I can send you the slides. So if you want to learn more and you have WebEx, you can join the WebEx space. And there, everybody in the world are joined and very actively in helping. We are learning from each other, and everybody's keen to see what challenges people are facing, addressing plan-wide, maybe bugs, whatever you can imagine. So do join. There's over 100 people already joining in this room. If you don't know about this room and after this, oh, I really want to join, talk to your account team. Tell them this crazy girl talks about v6 and there's this room where you want to join. They will then know where they must go to. Last but not least, and I'll go to the next slide, and people that want to take the QR code can come and see me. We have a breadth of IPv6 still available this whole week. So there's tons for you to see. And you have a survey, leave comments. I love the comments. I always read comments, they're anonymous, so I don't know who says what. So if you say, Nicole, wear a skirt, I wouldn't know next time that it was you. So, so I don't know, but I highly encourage you. With that, I would say thank you so much and have a great Cisco Live.
All right, how's everybody doing? It's Friday, right? Time to go home? Feels like it. Just all of the knowledge we've been absorbing as we've gone through. Everybody stretch with me. I need the stretch. You guys might not, but I certainly do. All right, it's getting late in the week. We're here. I've got 2 minutes to kill before we officially start. And I'm excited to be back in Amsterdam for Cisco Live EMEA. That's great. Anybody here last year? All right. What about the year before? Do we have any three-peats here for Amsterdam? I got one over here, we got there, a couple in the back. Excellent. All right. I'm still waiting to hear the official word on where we go from here. If anybody knows, don't spoil it. Don't spoil it. I'm excited to see where we head next year. I'm always happy to come back to Europe. I'm hoping maybe we could someday shift it so it wasn't like really, really cold outside when we come out. But hey, can't have everything the way that we want it to go through. It's awesome. All right. Anybody do any hands-on labs this week? Either instructor-led, walk-in, DevNet labs? Yeah. Hands-on for me is one of my favorite parts of anything technical, but the option to do that here at a Cisco Live event, right, with instructors right in front of you is something to take advantage of. I ran a lab on Monday. It was so popular, they asked us to do it a second time, so tomorrow morning I will be up at 8 a.m. Actually, I'll be up way before 8 a.m. to deliver an 8 a.m. lab, and I am stoked to see more people kind of dive in and take advantage of that. All right, I've killed 60 seconds. I got a little bit more to kill. Anybody know any good jokes? No? I didn't really prepare for this part, but Emma's like, it's time to go. I'm like, all right, I'll just wing it. It's all good. All right. I think that's probably close enough. All right, everybody, welcome to Cisco Live Amsterdam 2025. My name is Hank Preston. I'm a principal engineer here in Learning and Certifications, and I am excited for so many reasons to deliver today's presentation, How to be a Network Engineer in an Artificial Age. I've been thinking recently as I was coming up into Amsterdam, because I've been talking about similar topics for a really long time, and today's presentation is special. It's a presentation, it is a session 8 years in the making, believe it or not. It was the year 2017, I'm pretty sure that was 8 years ago, in Berlin, and I delivered this session, Reimagining the Cisco SE as a Developer. It was the initial version of the content that has turned into this session. I just looked back and I was flipping through it, reminding myself about kind of where we've come over the last 8 to 10 years in the networking industry. There were some things that I liked about this. Right? Shortly after this one, I was back in Vegas, and I delivered the inaugural launch of How to be a Network Engineer in a Programmable Age. In Berlin, I didn't know programmability was the age. I still thought it was the year of cloud. And my buddy Donkey Korn, the cloud we all ended up with, was kind of co-starring with me in that session as it went in. But even back then, we talked about the ages and how we went through the Stone Age, the Bronze Age, and it's just continued as we've gone forward. I used to always have fun talking about the OSI model. Right, I don't bring it up near as much these days anymore, but I was fond when I looked back, and I still think that there's some truth to these elements, right? How many network engineers in the audience? Right? We still pretty much feel like the physical layer and like half the data link layer is black magic, right? Generally, we plug the cable in and we go, please, and then if it doesn't, we flip it over and we plug it in and maybe it'll work now, right? We're really excited about these layers, right? The oh yeah, we got this layers. And then still today, even after 8 years of programmability and applications, I still don't want anybody to ask me about the top 3 layers, right? We'll just leave those alone. Enough nostalgia. You all are here for today's age. How to be a network engineer in an artificial age. Now, when I started talking about programmability, I was really honest with everybody that would come and listen to me. I have no idea what I'm doing. Literally make this stuff up as I go. And I bring this up, and I continue to remind people this fact, because help me out here. How many people out there, be honest, feel like everybody else around you has everything under control? Everybody else is an expert. Everyone else is staying on top of the topics, right? They know about this AI thing. They know what all these letters that people are spouting out mean, right? We all assume everybody around us has their stuff together. Trust me, we don't. We definitely don't. And that's my favorite part of the community that we have in networking in general, right? We all live in our little data center closets. Some of us in our data center closets have to share it with the hot water tank, right? And then we feel like we're alone, but we're not. We're a big community figuring out these transitions as we go through. And we're gonna do the same thing in artificial intelligence, and I promise you I'm in this with you because I have no idea what I'm doing, but I pretend really well. So the ages of networking. My graphics team has gotten slightly better. Carl is here, living his way through the Stone Age. We made our way through the Middle Ages, where we dealt with WAN design. We all transitioned to IPv6. IPv6 is always in your face when you don't need it. I just had to push Nicole off the stage so that I could come up and talk, because she just wants IPv6 everywhere. But we've dealt with that. We've dealt with it. The Renaissance was fun, right? We had to learn and deal with SDN, software-defined networking. Everybody told us that network engineers were going to go away. You were irrelevant. Cisco didn't matter anymore. White boxes, controllers in the cloud, OpenFlow was going to change the world. It changed a few worlds here and there. The Renaissance, my favorite part of the Renaissance, and I tell this joke, I've been doing it for 8 years, and I'm going to tell it again. All right, what did I learn as a Cisco SE? I've been here for almost 15 years. One of the first things I learned in sales training is when you have a product that is hot, that everybody loves, that is sold really, really well, every now and then you have to add a little more pizzazz, right? Make it better, get people excited about it again. And there is a surefire way to accomplish that single fact. Anybody know what it is? Put an X in the product name. The Renaissance brought us VXLAN, because we had VLANs way back here. It had been too long, we needed something new, right? VXLANs happily are still around. We don't have VXXLANs yet, but it'll come. Mark my words. I make the prediction now. We moved into the programmability epic, where I really have enjoyed myself. I loved this time. right? I look back and I was like, great, we made it to automation. We understand programmability. Net DevOps has become real-ish, right? I thought I could retire and just be happy, right? We made it to programmability. And then AI happened. And I was like, really? I got to do this again? Anybody else feel that way? I just barely held on through automation, and now I got to learn something new. But here we are, and I've had to evolve as well. The artificial intelligence era, generative AI, pretty cool stuff. We're going to talk about how that factors in a little bit today. We've got training, LLM, Rocky V2, agents, right? Carl looks like an agent. He's just trying to like fit in himself, right? He also thought he was almost to retirement and he could get away with this one, but he has to deal with AI as well. Artificial intelligence has come on so fast. Anybody else feel that way? So fast. The first time I retitled this presentation to Artificial Age from Programmability was last year in Amsterdam. And I sat down and I said, okay, Hank, it's time to figure this out. Let's start to learn. And I took a look at the news. What's out there about AI? Is this really important? And there were a few things that really hit me on it. And I knew AI was going to be big as soon as I hit the news. You know why? How many other technologies that we've dealt with as network engineers have been able to get Chuck Robbins to meet with the Pope? VXLAN didn't do it, but AI brought Cisco's big shot to the real big house. And I was like, that's pretty awesome. All right, I better dive in, figure out what this AI is all about. A few months later after this was in like February-ish, I was back in Vegas talking about artificial intelligence and networking, and it was time to look at the news again. And I was like, all right, it's okay, where are we? What's latest? Has the AI bubble burst? 10 reasons AI is overrated. Is it worth investing $1 trillion in generative artificial intelligence? It was like whiplash, right? In February, everything's great, we're meeting with the Pope. Now it's like, it's not worth it, it's a bubble burst. And now I'm back again. All right, what's new? What's new? It's been like 6 months, so I hit the news again. And it was interesting, right? DeepSeek's AI shockwave hits NVIDIA hard, wiping out billions. Boy, that was a day. What a Monday that was. And I was like, wow, maybe the trillions wasn't worth it. And then a little bit later, this headline hits. DeepSeek may not be as disruptive as claimed. They actually invested like over $1 billion. All right, okay. Everybody calm down. We'll see where we land. We continue along, and we're like, okay, will California revive nuclear power to feed AI energy demands? Doesn't feel like that long ago we thought nuclear was dangerous, right? We need to get rid of that and go through green energy all the way. But we bring the latest shiny tool, and all of a sudden, bring back the atoms. Let's split some stuff up again, make some power, because we got to feed those hungry beasts. It's not all bad news, right? There's a lot of organizations out there dealing with artificial intelligence, and it's not all bad news. I was happy to see this quote. Meta promises it won't release dangerous AI systems. Thank you, Facebook. Thank you very much. I appreciated that headline. And then as I was packing to come here, I just had to shake my head. Because concern over Google ending its ban on AI weapons and surveillance. Oh, my Lord. It's like up and down, trying to figure out where this AI stuff, and it's not going to end. And so where are we? You've seen this before, the Gartner hype cycle. I keep asking every time I do this session, all right, where are we? Where do we think we are? Are we here? Who thinks we're here? Hands? Anybody? No? Oh, I got one. All right. Here? Who thinks we're approaching the top? Ooh, some in the back. How many people think we fell this way? Ooh, all right. Yeah, it's hard to know. It's hard to know. And then I realized I was actually talking with a buddy of mine, Tom Davies, works with me here, and I was going through like the insanity that AI is. And we realized we needed, the Gartner hype cycle just doesn't do it for AI. So I went in and I sketched a new hype cycle. I think this is what's going on with AI. All right, it's up, it's down, it's up, it's down, it's back and forth. It goes backwards for a little while, and then we head back in that direction. I don't know where we are on this graph, but this feels more realistic with artificial intelligence, right? But none of that matters. None of that matters because AI is here, and we got to deal with it. So here's Carl. He's back. He's been diving into some AI, and he's got Mr. Packets, the network AI assistant, right? The future of where we're headed. Because the network is not isolated. We've evolved the network for years. Plenty of times have gone through. Network used to look like this, routers, switches, servers, right? Remember this? It's great, good time to be a network engineer because you could touch it. You could walk into the closet, you could move the toilet paper to the side, and you could touch your network. It was painted teal green. In silkscreen white letters, it said Cisco. Networks were awesome. But it moved forward, right? We got into some of the cloud stuff. Things started to grow. We had blade switches started to pop up. Virtualization went in. I'm glad to see we've pretty much got over our angst about VMs, right? Anybody out there remember days as a network engineer completely flabbergasted that there was a virtual switch, right? What is a virtual switch? I had no idea. But we've gotten over that. We had to, because eventually we actually put containers inside of VMs and had to remind ourselves that under everything is some IPv6, sure, maybe, but really under everything is Linux. And we got Linux networking with the Linux bridge. Clouds became exciting. We talked about Donkey Corn. He was all the rage for a while. And we evolved, right? Things came at us. We had to deal with overlays and software-defined WANs. Those are pretty exciting. A few years ago, we all had something that we had to deal with that really transformed what our focus was, and we had concepts like hybrid work became really critical. SASE, source of truth, full stack observability, infrastructure as code. What we do as network engineers, what makes up the network continues to change. The topics, the technologies we're after. And that brings us to artificial intelligence. Still not exactly sure where to put it, so I just kind of go around everything, right? AI is just about everywhere. Maybe someday it'll hone in, right? But AI is not just about like doing stuff, right? We have to adjust what our network looks like. So we've got these new fancy servers with GPUs and DPUs and LLMs. I don't really know what all those letters mean, but they tell me they're important, and we're selling a bunch of them. And then just like 20 minutes ago, I actually had to update this slide. Anybody at the keynote yesterday? Now we've actually put DPUs in the switches. That's, I don't know why, but sure, I'm in for it. In for a penny, in for a pound. AI is cool, it's interesting, it's everywhere, and I'm just buying into this, right? I don't think we need the rest of it. We're just gonna AI wash everything. Just put it everywhere. Just, hopefully not, right? We've gone through this before. There was greenwashing, there was cloud washing, but we're at this phase. It starts to feel like we're in this place, but that's still okay. It does have value. There are things that we as network engineers can get out of artificial intelligence. Let's talk about Hank's opinion, completely just my opinion, on how we can take advantage of AI. First up, let's use AI to find answers to questions. Let me correct that a little bit. Let's use AI to help find answers to questions, because it's not always completely accurate. I started my journey with AI with a question that I often have to figure out, like every time I do anything in the data center. What type of 40 gig transceiver will work in my Nexus 93180FX, right? How many times have we had to tackle this question again or ask somebody to do it? I said, all right, it's a softball. This should be easy, right? I know where to find the answer. AI should be able to know where to find the answer. What do I get? Oh, my Lord, I get a wall of text. I wanted a part number. I got a wall of text. All right, check the hardware compatibility list. Here are some things that might work. Yeah, I know what might work. They fit into the slot. That's not hard. And then it's verify the specific part number and firmware version to ensure I gave up on this one. All right, I'll go back to the way I really do this, and I say, okay, can you tell me where the link to Cisco's transceiver compatibility tool is? Because that's the real answer on how to do it. What does AI tell me? I'm sorry, I'm an AI. I have no idea where to find that. But if you go to Cisco's website and you search, no, I'm not going to do that. Back to Google. Just back to Google. I do it often enough that that's as far as I had to go, and it just gave me the link. I was happy. Solved that problem, got to where I was going to go. But I didn't give up, right? One mistake is not a problem, so I move forward. What kind of network is needed for AI, right? That seemed like something AI should have some opinions about. And I got an answer. It was decent. There was some good stuff in there. But as soon as I started this, I was like, all right, I can get into AI, right? AI's got a bit of a sense of humor. Or maybe it was trolling me right up there. First line, it depends. Ah, come on. It always depends. I know this. I know this. But we do have to find ourselves building networks for artificial intelligence. Or at least, I don't know, marketing tells me that we have to figure out how to build networks for artificial intelligence. And so let's talk a little bit about that. I dove in, right? We put together some white paper, some documentation to help engineers build artificial intelligent networks ready for it. And what did I find? Something that made me really happy. QoS, that's right. Can't count me out, baby. It always comes back to quality of service. All right, big packets, lots of traffic, prioritization, all that's really, really important. Or maybe not, right? A little bit longer. We say, how do we solve QoS problems for real in the world? Just more bandwidth, right? So now it's like, let's just shove 400 gigabit ports directly to the server. That'll solve the problem, right? Right? I don't want to do QoS. No, we're just going to, more bandwidth. We'll solve it that way. But the true answer to what type of network is here is Cisco has got your back. Cisco is in your corner. You all don't have to sweat this at all. Just buy Cisco's AI pods. This presentation brought to you by Cisco's AI pods. We'll figure it out. We'll figure it out. One step at a time. Somebody else will figure it out, and then they'll tell us what it is. Other use cases for AI, lots of exciting options. Right? We've all heard this, generate configurations or code with AI. Right? Hear this option? Right? I don't need to figure it out. I can just ask ChatGPT, Llama, Gemini, I don't know, Ralph. I don't know what all these AI names are, but you could ask one of them to figure it out. And so we'll take a look at it. What can we possibly do? How can I add a VLAN 99 to a trunk port on a Cisco switch? I gave it a softball, another one that should be easy. Right? Does it know how to do that? Give me some steps. What I was looking for, I'm sure some of the network engineers out there know what I was looking for. Did it know the important 3 letters, add? Add. Anybody ever forget that? I'm willing to admit it. I've taken down a network or two. Yeah. We should get pins, right? You get another one every time you take down a network because you forgot the add keyword. We'll get to that later. All right, so this wasn't bad. I was pretty happy with it. Something else I have to do occasionally. What is the QoS configuration to work on a switch to make FTP traffic best effort? Now, a little more complex. I wanted to see, could it handle this? Gives me an answer. I'm not going to read it to you. I did when it came through, and I was like, OK, that's fair. Right? It seems reasonable, looked good. Gave me some good explanation of what was going on. I like that. And then I also appreciated the end. Please note, QoS configurations can be complex and should be tailored to your specific network needs and conditions. I appreciated that. Right? A reminder, don't just copy and paste whatever you get from the internet. Right? You always need to take a look at it. And I think that's a fair memory, something to keep in mind for anything we do. I continued my exploration. How can I perform password recovery on a Catalyst 3550 switch? Why did I go Catalyst 3550? Because that seems to be what we have in our labs, right? Piles of old gear, and I need to remember how to reset it. I got reasonable answers here. This also looked pretty good, so I was like, all right, there's some good stuff that was out there. Then we get to the one that actually made me pause for a minute. I'd been working on a project for a while, and I said, okay, let's see if AI can help me here. There's a session I did, I think it was yesterday, on programmability skills for engineers who don't want to code, because not all of us want to write code all the time. And I've got a use case in there that involves some basic fundamentals. And so I said, let's see how AI can do with it. And I said, all right, use the data. This is all I gave it. Use the data from the below CSV. And so it's just some details of some VPN connections. And then this Jinja template, can you generate me configurations? Let's see what it can do. And it generated some configs. And I was like, all right. Pretty good. Wasn't impressed yet. I mean, if you've paid attention to any of the examples from OpenAI, like this is pretty rudimentary. Copilot, all these tools can do that. And I was like, awesome. But it wasn't done. The AI continued to go, and it continued. And it says, please note, there's a typo in the Jinja 2 template specifically, and I immediately stopped, and I'm like, well, hold on. I don't make typos. I was insulted. There is no possible way that I made a typo. Oh. Nope, I made a typo. The coolest part about this is it saw not that it saw the typo, that the configurations it generated for me fixed the typo, fixed the mistake. That was pretty awesome. I was like, all right, that's valuable. And then it continued. It went on and said, hey, additionally, you might have some problems if you actually do this. The short version is I asked it to create different configurations for VPNs, and it says, hey, if you actually apply this all to the same router, it's not going to work, which is true. You can't actually apply multiple crypto maps to different devices. You're going to have an issue. And so it gave me a fairly reasonable alternative that I could do. And I was like, all right, now I started to see some power, some things that were in here. Because it was able to take what I gave it. I didn't tell it was for networking, but it could interpret that. It could figure out that I had a typo, sure, but it could look at that and say, that wouldn't work. Like it intuited aspects of what I was trying to accomplish and then make kind of that next step of thought and be like, here, this might be what you're after. Now, in my case, these configs were going to different routers, but I didn't tell it that. So I was pretty impressed with that. So when we come to this idea, generating configurations or code, right? My advice is proceed with caution, right? Don't not do it, right? But just be careful. Check the work that's out there. My real excitement around generating configurations in code is not this type of a use case. It's something I haven't heard anybody really kind of talk about this way, but we've seen examples even from Cisco. You may have seen this video example from the security team where you're kind of going through and you're providing some input and things are happening. I like to consider this like the next generation of interfaces, a natural language interface into our systems. We're still responsible for knowing what we want and what's possible, but we don't necessarily have to memorize every single command and the ACL syntax, and is it a network mask or a wildcard mask? Like, I've got some excitement around the potential that's here. Other things we can do in the configuration space is understanding configurations in code. Have you ever been in a place where someone sends you a configuration block and says, hey, can you check this for me? Can you take a look at it? And you get it and you're like, I don't even know what they're trying to accomplish. Well, I gave it that shot and say, hey, can you just add some comments to this configuration telling me what's going on? And it did a pretty darn good job, right? Added comments, kind of told me what was going through. So, all right, that's a nice use case, like analyzing configurations for the network. We can also use it as a use case to understand code. So here's a bit of a, this is JavaScript I did for a project years and years ago. And hey, can you tell me what this is going on? Most of you network engineers don't have to know JavaScript, but hey, it went through and sure, it actually dove into it and could break down what was going on. Really kind of an interesting use case, and I think that fits in really well. Not necessarily generating the configs in code, but helping me understand what's there. This is a place that I've got some real value, because in my role these days, I'm a more senior engineer. We got lots of other engineers doing work, and I need to do reviews and feedback. This can help kind of break down, speed that process up. So these are some of the things that I think right today we should all feel very comfortable doing those. But very quickly in the near future, new things I think are on the horizon, potential that we should have our eyes open for and be excited and figure out how we're going to dive into them. One of my favorites, right? Next generations of assurance. We're seeing this in Splunk. We're seeing this in all of the tools that are there. Ways to kind of analyze all the data that comes at us out of the network. syslog messages, and NetFlow data, SNMP, all this stuff, and figure it out faster. Like, great use case, right? I think we're going to be able to see some really interesting stuff in that place. Eventually, this one may make us feel a little worse, right? Unsolicited configuration advice and oversight as we're doing our job. And so I've got Carl back. Mr. Packets pops up. Hey, what's going on today? Hey, you know, I'm just doing a little bit of network updates. And then Mr. Packet stops in and says, I'm sorry, Carl, I cannot let you do that. How would you feel when that happens, right? What do you mean I can't do that? I'm the engineer, not you. Oh yeah, but look, you forgot the add keyword. In this case, that wouldn't be so bad, right? I think there's some potential in this space that goes through. And I'm happy to announce I've been doing some AI prototyping, and I have brought Mr. Packets to life. Mr. Packets is kind of alive, right? I've been using him a little bit with some of the work that's in there. Here's an example use case I had. I was debugging some OSPF issues, right? I'm sure you've all done that. Something's wrong with the routing protocol. You turn on some debugs, and you get like 1,000 lines of debug. And then you start scrolling, trying to figure it out. And I have no doubt we do. Like, I could have figured this out on my own. But I said, hey, what if I just copy, paste, hey, Mr. Packets, can you tell me what's wrong with my OSPF setup? Here are the debugs. And sure enough, Mr. Packets did a great job. Said, all right, let's check it out. Dead intervals, check, 4040. Hello, 1010. Subnet mask, whoops, that was the problem. Mismatched subnet mask. Almost immediately, it could dive into those debugs and tell me what's there. So I see an option for network team members, right? These augmentations to what we do, not replacing us. Let me be absolutely clear. I don't think we'll ever quite get there, but augmenting our abilities, right? We're all professionals. We've put years and years into learning how networking and infrastructure works, earning certifications, right? And I always joke, I was the smartest network engineer in my entire career the day I passed my CCIE. Every day since then, I've become a worse network engineer because I'm not studying, I'm not keeping it up. It's hard to maintain all that. But having a tool that can help us augment our work, right? There's some real potential in there. I'm excited about that. Maybe eventually Mr. Packets is off the leash, Carl goes on vacation, he can handle it for now. I think we've got some time before that happens. There are other places we're looking at prototypes and trying to consider where AI might fit in. And here's a conceptual idea that I've been working with the CML team on to figure out what might look good. And so here's the idea, is that I've got the CML interface, we embed the Cisco AI assistant, and we get a nice chat interface into the support knowledge about the tool. We can ask it about, hey, what are the features that are there? What's possible to work with in this tool? And back to natural language inputs, having that ability to deal with it as it goes forward. And so here's where we can figure out what CML can accomplish, right? It says, hey, and I know that I don't know how easy it is for you to read. It's hard for me here, but I just asked, hey, how do I start a packet capture inside of CML? Gives me some nice steps. That's super cool. And then it goes through and says, all right, this sounds interesting. Maybe I can do a little bit more. Can you help me out with, hey, I'm working on OSPF, back to that same use case. I don't want all the packets on the link. How would I filter just for OSPF packets? Goes through, gives me some details, gives me a BPF filter that I can put on the packet capture. All really good usefulness. And then maybe I want to dive deeper in. Hey, is it possible to learn a little bit more about packet capture? I'm new to this feature set. What can you offer me here? So we put that in there, and this is where the integration back to learning comes really high. We have training in Cisco U all about CML, how to do these things. And so it says, sure, let me load up a topology that you can use for a lab, and then go ahead, feel free to launch that lab as soon as the graphic catches up to me, and then it can actually let you kind of integrate the Cisco U learning, there it goes, Cisco U learning experience into the product sets so they're tighter. We don't have to jump so far apart. Now this concept of an approach, I think, has some real legs to it. Gives us an ability to kind of put the learning, the training, the information at the moment of need when we're trying to do stuff, right? And take advantage of the things that are already available. Super exciting feature set that we're trying to figure out how to make this real. Right, does that seem useful? I'm also doing product polls right now. Does this seem like it would help out? These type of, okay, we're just trying to gain. Like I said, we're just in the early stages of some of these areas. But there is a lot of potential that we can ask. Which brings us to here. What should we all be doing as network engineers today to stay up with artificial intelligence, maintain relevance, right? Well, we are trying to help out here at Learning Certifications with Cisco U. We have an entire area dedicated to artificial intelligence, where we've got tutorials, labs, information, all sorts of things that you can dive right into to start understanding. And many of these have been kind of built specifically for us, right? They're network engineers in mind, right? Understanding AI and LLMs as a network engineer, right? Introduction to Retrieval Augmented Generation by Jason, who's probably over there somewhere. Network engineers doing things for other network engineers. Now our certifications have to keep up, and we've been doing certification updates, and right on that AI page, you can see what's been done to some of the certifications. So across associate, professional, and expert, we're bringing in the early phases of artificial intelligence skills and expectations to help you stay relevant as you continue to learn and grow your careers and earn those next certifications. So take advantage of those. And so as we come to the end, I'm actually doing really well on time for a change. I want us all just to recognize that AI is here, right? We can't stick our heads in the sand. We got to absorb it. We got to admit that this is something we can take advantage of. I'm questioning Carl's clothing choice changes. I don't think we need to go quite that far. But hey, there's stuff that we can get out of this. And as I said, right, we are all in this together. We're trying to figure out where AI is going to go, what the impact is going to be on all of our jobs, our careers, the things we have to know, the things we have to do. And I promise you, right, I'm right there with you. Feel free to reach out. Stay up with what we're doing. We're going to have more content coming out, helping, right, every step along the way. If you were on this journey with me through network automation and net DevOps, you know that we're not going to get everything right the first time, right? But we'll get there in the end, and we'll work on this together, right? We'll work on it, and we'll make sure that we all come along and we do a better job for ourselves, our career, and our companies, our organizations. Always feel free to reach out. hapresto@cisco.com. Follow my blogs. We'll start to see some new things around AI hitting there. There's lots of stuff going on. It'll take us some time to get there, but we'll do it together. And I guarantee I'll be back wherever Cisco Live Europe is next year. I'll be back with the latest updates, right? We'll see where we are in the hype cycle, right? I can't wait to see what the headlines look like a year from now. I'll be honest, a little bit concerned what they might look like, but hey, I'm optimistic. They'll be great, and we'll do this all together. All right, with that, thank you all so much for spending some of your time at Cisco Live. There's so many excellent opportunities for learning, education, networking. Take advantage of them while you're here. There's still time. And visit more of the sessions here at the Cisco U Theater. Check out what they've got going on in the DevNet zone. Visit our demo booths, the World of Solutions. Take advantage of everything we have. And when you get home and you're exhausted, keep going, because all of our content, or a lot of our content, is made available on demand at ciscolive.com. So the learning doesn't have to stop when you leave Amsterdam. Thank you, everybody. I'll talk to you again soon.
One, two, three, 1, 2, 3. Yep, that's it. Okay, so welcome everyone to this session on the coolest cloud-native DevOps tools. As you know, this is a 30 minutes format. As a 30 minutes format, I'm going to be speaking very quickly because I need to develop a common base of knowledge that all of you are going to be able to bring back home after the session and change your lives. You know, something that you don't get with any other session is that everything that we are going to describe here today, you're going to be able to bring it back home and replicate it yourselves. So for the software development people coming from networking environments, this is the session where you take everything back home and you can replicate it for free, which is something very, very useful. What we are going to cover today is how is a day in the life of dev and ops. You know, if you are networking people, maybe you are not that familiar with that. So let's try to explore how they live and what are the concerns that they have. And then we are going to go into modern challenges, the things that are really impacting the way that they work these days. And finally, a conclusion on what we should do moving forward. This is the way that the CNCF, the Cloud Native Compute Foundation, defines the landscape of tools that we have around cloud native. This is amazing. I mean, this is overwhelming. I cannot even read the title of the different applications. So where do I start? I mean, what do I do with this? For me, this was kind of a starting point and realizing that unless you have some guidance, you are lost. You cannot do anything useful for this. So what do we do if we are developer or operations people? So the way that they operate is that they want to have something that is ideal. There are 3 features that developers want to have in their day-to-day operations and the tooling that they use. The 3 features that they want in their software development environment is, first, whatever they define and create needs to be replicable, that can be replicated in different environments, that whatever I create here, I can send it to you and you can use it as well. The second feature is that it's integrated, meaning that as long as cloud-native applications are composed by different microservices, you need to make sure that those microservices lifecycle is handled in a way that is easy for you. When you have new software versions, when you need to obsolete some others, when you need to push them into production, all of that is the integration of different microservices and how you handle them. So the easier it is, the better for the software developer. And the third one is that it needs to be efficient, meaning that if you want to move your software into production, it needs to be as easy as possible. You cannot tell a developer, hey, you need to learn about Docker and Kubernetes, and you need to do this and blah, blah. They want to learn their programming language and develop. That's the main concern. And the easier that we do it for them, the better. So these are the 3 things that developers want. For our demonstrations that I'm going to run a ton in this session, we are going to have an application that's been developed by that guy, Hank. That guy. That guy has created this software application. It's a software application with 3 microservices. You have a front end using HTTP, an HTTP server. Then you have a middleware that processes the votes. And then you have a very fancy backend data microservice that is basically a text file. But it's good enough for our session today and for our demonstrations. So whatever is going to be served by the HTTP front end is going to be processed by the middleware, and it's going to be stored in the data. Remember this 3-layer because we are going to use it during the whole presentation. And we are mainly going to be impacting this microservice and making changes as a software developer could do. Software developer is responsible for this one, another one for this one, another one for this one. But that's the idea. We are going to show you how a developer would work with this example microservices-based application. So let's start at the beginning. As a software developer, what is the first stage when you are developing software? You go and developing your own laptop, right? And you tried everything there. And that is great because everything works. Everything works. And if it doesn't work, I will make it work. I will go to Stack Flow and I will find the solution for all my problems. So let's see how it works. As long as I have fat fingers and I'm not very good at speaking and typing, I have recorded the demo for you, but it's basically the same. So remember the backend that I was describing in the previous slide, the 3 levels? Well, for the backend, the data microservice, you run it with a Python command, right? You run the Python command, you let it run, and it's a Flask environment that serves its capabilities in port 15,000 of my laptop. I do the same for the middleware. The middleware is another Python command with some Python code, and I run it. And again, it's a Flask environment that runs on port 15,001. That's great, and that's the way that it runs. For the front end, for the HTTP, I'm using Nginx. And Nginx is just a piece of software that serves HTTP code. And that's the front end that you see. So I run it with Nginx, and that's where I run my front end. That's basically it. With these 3 pieces that I have just run individually in each one of the tabs in my terminal, I can go here and I can just see the application that Hank created. And you can see that it says, for example, here on the top of your screen, you can see that it says, make your voice heard. You know, vote for the best superhero and so on. Yeah, that's great. But that's the software that I have right now. And it's running. It's using the 3 microservices, and they're interacting in a great way. Fantastic. So that's the way that I can run it. But what if I need to make changes in my code? Well, as a developer, everything is running in my laptop. So what I do is I edit the HTML file that is running in the front end, in the HTTP Nginx microservice. I can edit the file. I can make changes. And I'm going to change make your voice heard from small letters to capital letters. That's a change. It might be whatever software change. But this is just an example that is going to be very easy for you to see when it goes into production. So I save the file. I click reload on my computer, and automatically I can see the software has updated whatever I change, and it's reflected. OK, that's great. It's a laptop. There is no big science here, right? Great. So everything works there. I'm just going to stop whatever I'm running there, but I'm going to tell you what is the next step. This is not very good because it's not replicable. I'm running it in my Python, in my own computer with my Python installation, with my own libraries. If I give it to you, then you're going to need exactly the same setup. You're not going to have the same libraries. It's not going to work. And I'm going to say, it's your problem. Because it works in my computer. So I don't care. I don't care. It's your problem now. And that is a problem. Because when you want to put something in production, it needs to be replicable, or staging, or quality assurance. So not replicable. It's neither integrated. I have 3 different microservices, and this is just an example one. Real applications have maybe hundreds or even thousands of microservices. There is no integration in between them. I'm running them in different terminal tabs, and I need to do, OK, Python this, Python that, and then stop them individually. It's not integrated at all. But it's very efficient. Definitely efficient. Yeah, everything works. It's efficient for me. Remember, this is for the developer. The developer is happy because he doesn't have to be concerned about anything else. That's great, but it doesn't work very well because it does not comply with the first 2 options. Now, next step is Vagrant. Vagrant is a runtime environment that allows you to run virtual machines in your computer. You can run different virtual machines. And Vagrant is great because running virtual machines allow you to have something that is replicable. Yes, I can give you my virtual machine, but the virtual machine comes with its own operating system. So it's not very, I would say, convenient, right, for your purpose. So it's definitely replicable, but there is no integration in between the microservices. Each one of them is running in its own operating system, and I have to run them individually. Come on, that's not a good approach. And definitely not efficient. When I want to put it into production, I would have to send the guy responsible for production, staging, or quality assurance the whole virtual machine for each one of the microservices. Definitely not the right way, right? We don't want that. Next step is going into Docker, containers. I can do the same thing with containers. And containers are great because I can just build, ship, and run any application anywhere. So it's very good in terms of replicability. And as long as containers do not have their own operating system, but rather use the capabilities of the kernel, they have a very small size and also a very small attack vector, meaning that the surface that I can attack, the vulnerabilities, is much smaller. So there are certainly very good things. Memory consumption, hard disk. I mean, everything is good because they are very small. Lightweight, isolated, and portable. So that is great. Let's see how it would work in my demo. So the demo for Docker does the same thing. I'm just going to go into each one of the microservices in each one of the tabs. And I'm going to say, OK, Docker Compose app. I have a Docker definition. And I would just do Docker Compose app for each one of the microservices individually in each one of the tabs. And it would automatically run that microservice. It's a little bit better because it's just containers instead of full images. But still, I have to manage them individually. So I do the Docker Compose app for the 3 of them. And again, when I go into my browser, I see that the application is running. Fantastic. Small letters, again, make your voice heard. It's small letters, back to the original version. And when I need to make a change, what do? Well, I have to go and connect to the user interface. I have to connect to the container that I'm running and make the changes in that container that is running. So I go there and I connect. With docker exec -it, I can connect and run a shell command. So I run the shell command, and then I install a very fancy text editor called VI, because the container does not, the basic image does not include that functionality. So I install that, and I edit, again, the same file, the main HTML. Remember, inside the container. And inside the container, I make my change, again, going from small letters to big letters. Great. I save it, and when I reload in my browser, I see that the change has been performed. Big letters. That's the way that a developer would have to work. If you ask me, not very convenient. I have to use Docker and connect to my container. Even worse, when I want to save my changes, I need to do a Docker commit of the file, of the image that I have just modified so that it's saved as an additional image. So I save it with Docker commit, a Docker commit command, and then publish it into my container registry so that everyone can download it from there. Oof. Not very convenient at all when I want to publish any code changes, especially if I want to do it frequently. So let me go to our next step. Docker is not very good because, yes, it's replicable. It's not integrated at all. I'm using Docker Compose app in different tabs, so not very integrated, and definitely not efficient. If I want to send my software to production, I have to do a Docker commit of the changes, do a Docker publish of the file that I have created, the image, and then have someone update the deployments. Not convenient at all. We don't like that. Then comes Kubernetes. Kubernetes is a container scheduler, meaning that it's responsible for the containers. And it's declarative, meaning that I ask Kubernetes what I want for it to do, but not in the way that it should do it. It's declarative, not imperative. I don't tell him, do this, 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 and this. I just tell him the desired end state. So that's very good. It adapts to underlying infrastructure errors. That's very good as well. But the containers that it runs are immutable, meaning that as a developer, I do not get to change the code that is inside the containers. I need to create a new image and then update the deployment. So how does it work? Well, let me show you a quick demo. For this step, I'm going to do the same, but the containers, each one of the microservices, is defined in one specific YAML manifest. So with one single command, I run each one of them. So I do the data one, remember, the backend. I run also the middleware, the application, and I run also the front end, the user interface. With those 3 commands, I have run the 3 microservices that I need. Additionally, I need to run also an ingress service. Ingress is because I'm running this in Google Kubernetes, so Google Kubernetes engine, so I need a resource to get all the way to where my application resides. So I apply also that manifest. And with that, I can just take a look at the pods, the running pods. I see that the 3 of them are running, 1 out of 1, fantastic. Go into my browser, and there I see that I'm going to a real URL that takes me to my Google Kubernetes engine cluster. So see the application running, that is good. I see that it says make your voice heard, so the title is back to the original thing. That is great. The problem is I cannot change anything. If I wanted to change something, I would have to create a new container, a new image, publish it. It's a big mess for developers. They don't want that kind of thing. Is Kubernetes good? Yes. It's good in the aspect of replicability. Yes, it's very easy to replicate whatever I have created because Kubernetes is Kubernetes, no matter where it is. That is fantastic. It's integrated. Yes, my microservices are all managed by Kubernetes, so that's very good news. But it's not very efficient. As a developer, I need to do Docker commands and Kubernetes commands and manage the lifecycle of my application. That's not good. That's not what I want as a developer. Please let me focus in my code. That's what they are asking everyone. Let me focus on my thing. I don't want to learn about other things. I'm a very good Python developer. Let me focus on my Python code. So what are the modern challenges that we are seeing? Well, because of this situation where everyone needs to do a Docker build, building their application, publishing it, and then deploying or updating the deployments that already exist in production or any other environment, we need to find a solution. And that solution comes in many different ways. So I'm going to show you today some of the examples and the ways that we solve this specific problem for developers so that they don't have to do Docker build, Docker push, and then update the deployments. How do we do that? There are several options. The first one is using CI/CD pipelines. CI/CD pipelines is an automated way that we provide to our developers so that they can do exactly this, which is updating their software and pushing it all the way to any other staging platform or quality assurance environment. So how do we do this? The way that it works is you have a number of developers, all of them contributing to a single repository where the code for the application resides. You might think this is the developer for the user interface. You might think that this is the developer for the middleware. You might think that this is the developer for the data, for the backend that we define in our application. All of them use a tool called Git for version control to make sure that there's a system that tracks who does what in your software and provides capability to go back, to roll back in case that there are problems or failures. All of them push their code into a central repository that is a version control server. In this case, this is in the tooling that I'm using is GitLab, but it's GitHub, but you might be using GitLab or Jenkins or whatever. And here you have an integration process that generates automatically the Docker images, the real artifacts that you are going to use to push them and update the deployment in production, okay? So this is automated for the developer. The developer is only doing this, updating the software and pushing it. And then automatically everything automatically happens. So let's do a demo as well here. How does it work? The demo for CI/CD is going to show you the experience that you get as a developer. As a developer, you change your code. You go and again change the main HTML, the front end, the front page. You go there, you update it. You see that it says heard with big letters. I'm going to insert a lot of R's. We will call those the Hulk R's. So we save the file, and then we run 3 commands. One of them is git add. Git add adds that file into the commit that I'm going to create, adds it to the staging phase. So I add that file. Then I run the git commit, where I say all of my changes are now ready to be pushed, and I'm going to add a comment that explains what changes I have done in my code. And then the third command is git push. Those are the 3 commands that the developer needs to know. Git add, git commit, and git push. Git push is going to send all of these changes, the code that they have created, is going to be sent into the GitHub repository, the central location, if you remember, where the developers were pushing their code. They send it there, and automatically, if I go to my repo on GitHub, I can see that there is a tab called Actions. And Actions is the pipelines that have been predefined with a number of actions that this is going to detonate. So at Hulk R's, this commit that I created is going to run this pipeline that I have created, where I have a number of steps that are going to be completely transparent to the developer. Developer just does the git add, git commit, git push, and then nothing else. All of this is transparent, but I want to show you what I have defined here. I do a git checkout from the repository. I do the authentication on Google Kubernetes Engine under Google Cloud. I do generation of the kube config Kubernetes configuration that it's required to update Kubernetes later on. We do the authentication on Docker so that I can do a Docker push, because otherwise I cannot publish my image. We also build the Docker image. Remember the build that was done manually before? Now it's done automatically by the pipeline. He does everything for me. Then it publishes the image into the Docker container registry. It does it for me as well, completely transparent for me. It does everything. Now it's deploying to the Google Kubernetes Engine cluster. So the production environment is automatically updated by the pipeline. I could configure it to be manual, but it's automatically done for you to see it. So it deploys to the cluster. It tells me that the deployment is successfully rolled out. And then it starts cleaning. It removes the credentials for the Google Kubernetes Engine authentication and also for the Docker authentication. All of that is done, the Git checkout, everything is done for me. So all these steps are done, and I'm not aware of it as a developer. I don't have to be concerned about it. The only thing that I see as a developer is that when I go into the production environment, I see that reload shows the whole cars, shows my code changes. Now, this is the way that companies like Netflix or Amazon are doing, on average, one change per second on their production code, because they use these kind of tools. Otherwise, it would be impossible if they had to do it manually. Now, that is great, but are there any other options? Well, yes. Let me show you some other modern options that might be of your interest. One of them is called telepresence. Not to be confused with the fancy rooms that we had with the screen so that you could talk to your cousin in Argentina. Well, no, that's not it. This is a tool on the open source field called telepresence. What does telepresence do? Well, telepresence is able to take the traffic going into production. So this is a remote cluster, like in Google Kubernetes Engine or whatever, like a real environment, and say the traffic that is supposed to go to a container or microservice there is going to be redirected to my laptop. And from my laptop, the outgoing traffic is going to be sent to the next microservice in the production environment. Doesn't that sound magic? That allows a developer to work in their computer and get automatic feedback about what is happening with real production traffic without having to update the deployment there. What is the value of this? Well, first, it allows you for direct and transparent connectivity from your laptop into the cluster. That is amazing. I don't need to know what is the URL. I don't need to know if there is a service that is publicly available for this microservice. No, it's automatically connected into my local environment in my laptop. So I'm going to show you in a second. It allows you to intercept traffic. Whatever traffic was going to my hero UI here, now it's going to come to my local instance and not to this one, transparently. It allows me to do local coding and debugging in my own environment, not having to be concerned about anything remote. It allows for instant feedback. It's just in that immediate instant, I know if it's working and if it's not working, and I can troubleshoot in that same moment. I can use my own tools. If I'm using Visual Studio Code here, I can use it, in a transparent way because I'm just working on my local code. I have a very low usage of resources because it's just a single microservice in my computer. I don't have to operate any Kubernetes, even though I'm interacting with a Kubernetes environment. I'm going to show you a demo, sorry. Let me just show how it works. The demo for telepresence is in two phases. One of them is I'm going to install telepresence. So you see that it's just a single command, Helm. Helm is a package manager for Kubernetes. So you just run telepresence helm install, and it's installed transparently for you. Then you connect to the daemons that it has deployed in the remote cluster. So it says connected to my Google Kubernetes Engine cluster. This is the name of mine. And then I can just list what are the different microservices that are available there so that I can connect to those. So you see that I have the three levels, UI, the middleware, and the backend data. Fantastic. So what can I do with that? Well, first, I'm going to demonstrate direct connectivity. If you remember, I told you that I can just have direct connectivity to something that is remotely located without having to specify any IP addresses or nothing like that. So I can do a curl command. Curl is a CLI tool that is used to send HTTP requests, for example, to simulate that you are a browser, to send an HTTP request to somewhere. So I can use it to send a GET to the My Hero data. That's the backend database. I'm not saying, I'm not specifying an FQDN URL. There is no URL. I'm in my local laptop. I'm connecting or trying to ping or trying to send an HTTP request to something that is in a remote cluster that is not publicly accessible, and I just have to use My Hero data as a name, and it says, yes, I can access it, and it gives me the options that are available for me to vote. Think about it. As a developer, I'm connecting transparently to a remote cluster without having to specify anything. That is quite awesome. I can also do that from Docker. I can run a Docker container, and I can also connect from that Docker container to the remote cluster completely transparently. You see? I do a curl from inside the container, and again, I have full connectivity. And I'm going directly to my hero data. I'm not going to a URL or an IP address, nothing like that. It's automatically resolving it correctly. Great. Apart from that, well, I can connect to any other microservice. I can also go to the middleware, and I have connectivity as well. But apart from that, I can also use telepresence to intercept traffic. Meaning that if you remember the diagram, I can say all the traffic that goes to the user interface, to the HTTP Nginx microservice, instead of going to the production one, send it to me, to my local laptop, to the one that I'm running in my own laptop. And that's the intercept demo. With this command, telepresence intercept, I can say, hey, when you have traffic that goes to the user interface, redirect it to a Docker container that I'm going to be running in my own laptop. That way, the code that I'm running locally can be debugged in real time with real production traffic. So I run it, and you can see that it automatically, it's done. I don't have to do anything else. But when I update my software locally, I'm doing an addition of my file locally. I change it from the Hulk Rs. I remove the Hulk Rs. Let me show you first that they are there. You see, reload, and the Hulk Rs are there. I make the change and remove them, save the file. And when I save the file and click on reload, they are gone. So it's automatically done. I'm going to the URL of the production environment, and it's automatically detecting the changes that I'm doing in my local environment. Boom. For a developer, this is magic. This is the kind of value that they're expecting. Great. Let me stop that and show you another tool that you're going to love. Yeah, question. Exactly. That's a good point. If all the traffic from the production environment is redirected to my own laptop, it could be overwhelmed. Definitely yes. There we could use the capabilities of the service mesh in the remote environment that allows you, something like Istio, allows you to do canary deployments and say, yes, a percentage of the traffic can be redirected to this specific label V1 or V2 or V3. I can just use that specific 10% of traffic and have this tool redirect that traffic into my local environment. That way I could accommodate the limitations of my own environment. Yeah. Another tool, MirrorD. MirrorD does something similar. It allows you to steal the traffic going into a microservice. It's similar to the intercept capabilities that we have seen with telepresence, but it also allows you to mirror, to create a copy of the traffic and send it to me. Again, for a developer, there is a lot of value on that, because sending a copy of the production traffic to my own environment allows me to debug my application with real traffic that is not synthetic. It's something real, and it's just a copy, and I'm not impacting the traffic in the real environment. So why is this useful? Because it allows you to still intercept the traffic or mirror it. Again, local coding and debugging, instant feedback, very similar values. Minimal resources. I don't have to operate any Kubernetes. I don't have to operate any Docker. In the previous one, I had to operate Docker, if you remember, with telepresence. Now I don't have to do it. I just can manage it with my own environment. There is no access to the root passwords. A lot of people using telepresence complain because they don't have the root password for their own computer. Now you don't, here with MirrorD, you don't need it. There is no cluster installation. Remember telepresence Helm install? Now here you will see that there is no installation required. So also very convenient. It supports pods that are not exposed via service. That was the case with telepresence. And it's much easier to use. So let me show you why it's easier to use. Oh, and there are plugins for the integrated development environments. Let me show you. I'm going to uninstall telepresence and stop it. telepresence leave, telepresence helm uninstall, great. And then disconnect from the daemons that we have remotely installed with telepresence. Okay, telepresence is gone. Let me show you now the demo for MirrorD. For MirrorD, I'm going to show you the mirror option first, which is creating a copy of the traffic and sending it my way. How do we send it my way? I see that the pods are running, that everything is good, and then I run the MirrorD exec command, which creates a copy and sends it to me, to my local instance. You see, it's now running with a Flask backend, running on port 5000. Okay, so what I'm going to do now is I'm going to create a curl request for HTTP request to my local environment, to the local one, the local copy that I'm running in my own setup. That you can identify it because it's the IP address and then the port 5000 where it's running. I see that Captain America has 5 votes. 5 people have voted for Captain America. So what I do is I vote again for Captain America in the production environment. I have my own copy, but this is the production environment. It's an URL that goes to the production environment. I vote for Captain America. I see that the votes increase, so 35%. That's great. But when I take a look at my own environment, I should see one additional vote because it has sent me a copy, you know? So I take a look at it, and again, one more vote. So that means that it's mirroring the traffic and sending me a copy into my own local environment. That is great. Even if I take a look at the votes, I can edit the file and say how many votes I have. Okay, there are votes for Captain America. I'm going to do the opposite. I'm going to delete 4 votes that I have for Captain America here. I'm going to delete them. Now there will be only 2 left. And when I save the file, you will see that the production environment is not impacted because I'm using a copy. I'm using just my own local environment. So I go back. I go into the production. I go to my own environment, see that I only have 2 votes. But when I go into the browser, Captain America still has 35%. So it's not being impacted. That means that my copy does not impact the real environment. Great. That's the first option. If I stop it and run another capability, which is the intercept option, it's very similar to the one that we had with telepresence. I'm going to send a copy, I'm going to intercept the traffic that is going into the database. So how do I do that? Well, I add the parameter -- steal. And that way I steal the traffic and send it to my own environment. When I steal it, just with one single command, again, I have my local copy working in port 5000. You will see that it's starting to redirect traffic to me. So how do I demonstrate you that the traffic is actually being sent to my local copy and not doing just a mirroring? Well, let's take a look at the votes that we have for Deadpool. It's 13%. 13% of votes right now. If I go and do a curl into my local environment, again, to my local copy, you will see that the number of votes that Deadpool is 3. What happens if I go and edit the file for the votes again and remove those votes? I go here and say Deadpool. We see 1 vote here, 2 votes here. Delete. Delete. And I have deleted 2 out of the 3. Great. Save the file. Take a look at the results in my own environment, and I see that now I have only 1 vote. The difference is that if I now go into the browser, you will see that Deadpool has lost the votes. Now he only has 1 vote left, 5%. The reason being is that the traffic is being sent to my local copy from the production environment. It's transparently being sent to me. That is the power of MirrorD. Not only it can mirror traffic, it can also intercept the traffic that is going into specific microservices and send it to me. Great. And for my last demo, because I'm running out of time, I'm over time, I have one new tool called Octeto. Octeto does the best thing ever. Octeto has the remote cluster with the microservices, and then you have your local one, and you have your code here. And instead of doing redirect, intercept, mirror, whatever, it does nothing like that. What they do is you have your code here, just your code, just a text file with your code, and it automatically synchronizes that code with the remote deployment and updates it in real time. As a developer, this is nirvana. I do my changes, I hit save, and the production environment is automatically updated. That sounds impossible, right? Well, it allows you for a myriad of amazing things, right? No Kubernetes, no Docker, no nothing. Of course, you're just using your own environment. No cluster installation, easier to use. You can have a repo where you collaborate. We could be pushing changes to the same repo, and all of them would be updated. It's something that we can use in a lot of environments. So let me finalize by showing you how it works. It could not be easier. You go into the repo that you are going to work on, in this case, the user interface. You do octeto app. Just that, octeto app. And with octeto app, everything is sorted out for you. Everything is synchronized for you. You don't have to do anything else. It does its magic. It automatically connects to the remote cluster. Everything is done for you. It says that it's connected. It's installing whatever libraries it needs, whatever. It says it's running, it's serving. The application code resides in that directory. OK, let's see if it's real. I go here and see that I have the Hulk Rs, a lot of Rs. I go into my own environment. This is the developer experience. I'm just going to edit my file locally, no container, no Docker, no Kubernetes, no nothing. I edit my file. I make the changes, remove the Hulk Rs. You see, I save the file. I go to my browser, and it's gone. It could not be simpler. It literally could not be simpler. There is not much more that you can do to simplify the life of a developer. This is what they want. They want to focus on their code. They don't want to focus on anything else. They don't want to learn your Kubernetes, Docker, whatever. So that's basically it. The conclusion for me is, you might be thinking, why not we use all of this fancy stuff that Julio is showing? Well, basically because maybe it's too much. You need to start step by step. You need to start slowly. You need to start evaluating the different tools, and then you will realize which ones are useful for you or not. The good thing about all of this is that I have very bad memory. And as long as I have very bad memory, I write love letters to my future self, where I tell my future self, the future Julio, hey, you will not remember, but you built all of this stuff. So that love letter, I have made it available to everyone else. And I call it hands-on with DevOps, with a special emphasis on hands-on. So if you want to learn about all of this, you can go to this URL, cs.co/JulioDevOps, and you will find there a plethora of content. The session today is just a very small piece in what you have here, which is everything around containers, Docker, Kubernetes, Istio as a service mesh that we were discussing, Helm, CI/CD pipelines, how you can get started with serverless, all of it. If you really want to learn what is from zero to hero, this is the document for you. And the good thing is that you have my contact details, so you can reach out to me in case that you get any questions. This is not something that's been published by someone else. This is just me, so you can reach out directly, and we can discuss if you need help. So please fill in the surveys. We are evaluated on that. We would really appreciate if you could do that for this session. If you do that, you might get a T-shirt, which is always great. Without further ado, continue your education. I wish you all the best for the rest of the event. Thanks a lot for your attendance.
All right. How's everybody doing? Happy Wednesday. Awesome. Hopefully you guys grabbing some beer, enjoying your little happy hour time here. My name is Kyle Winters. I am a technical advocate focused on security with the Cisco Learning and Certifications team. I've worn many different hats over the years, and whether it's consulting, customer success, application security. I'm a Cisco certification holder myself as well. And today I want to talk to you about how you can future-proof your career with Cisco security certifications. So just to kind of give you an overview of the agenda here, we'll start kind of by giving you an understanding of the importance of cybersecurity certifications and what the job market and landscape looks like today. We'll then go into some of Cisco's security certification offerings and give you an overview of what each of those cover and how they differ from each other. And then we'll cover some effective exam preparation tips and strategies as well. We'll also have a Slido quiz. So the winner of that quiz, I've got a little prize for you as well. So once that happens, you can come up to me afterwards and I'll give you a nice little prize. So why don't we go ahead and begin? But before, really quick, we do have a WebEx channel for this session. I'll be monitoring it until February 28th. So feel free to post any questions that you may have during that couple week period there. I'll post the slides as well as some resources for you. So feel free to join that. You can join that in the Cisco Events app. So to begin, what is the importance of cybersecurity certifications? And just to kind of give you an idea of the workforce, there's a 33% growth in the number of jobs that are going to be available in cybersecurity over the next 10 years. And if we take a look at the workforce gap itself, that's 4.7 million jobs that are going unfilled today in cybersecurity across the world. And that's actually up 19.1% from last year. If we take a look at Europe specifically, 392,000 open job roles are going unfilled today in cybersecurity just in the Europe market, and that also is up about 12.8% from last year. So there's a tremendous opportunity, and the reality as well is that cybersecurity jobs are everywhere. They're not just tied to a cybersecurity company or a technology company. All sorts of different companies around the world and different verticals are leveraging cybersecurity to protect their infrastructure and their organization from emerging threats, whether they're in healthcare, energy, food, government. There's a lot of opportunity in a lot of different areas that are looking for cybersecurity talent today. Now, when we take a look at cybersecurity teams, many people are familiar with the idea of the blue team. They're the ones who are protecting the networks and the infrastructure. They're the people who are commonly referred to as the Security Operations Center or the SOC. They could be focused on things like firewalls, access management, data protection, cloud security, application security. All of these different areas are typically falling into the blue team side of things. But there's also this red team side, and that's the offensive security side. And that's made up of ethical hackers and penetration testers who are working behind the scenes to essentially find vulnerabilities before malicious actors out in the wild find those vulnerabilities. So between those two, there's a lot of opportunity. Yes, you had a question? That's a great question. So the question was, what is the difference between an ethical hacker and a pen tester? There really isn't much of a difference, to be completely honest. I would say it really depends on kind of what the job title is. Really, that's ultimately the same or similar responsibilities. It's just kind of how, similar jobs can have kind of different names over time. So really, they're ultimately trying to do the same thing, and that's validate and test the resiliency of an organization and make sure that they can identify potential vulnerabilities before some malicious actor does. So that's offensive security and defensive security. Companies these days need both. And there's a lot of opportunity out there, but the problem as well is that there's not a lot of talent that's available today to fill all of these open job roles that exist. 77% of companies are reporting difficulty finding skilled talent to fill these roles, and unfortunately this slide is not showing the actual number there, but A good number as well, too, are also looking to upskill and reskill their current workforce to be able to have this role available. So really, people are looking for the right skills to be able to fill these roles. And that's kind of where training and certifications come in. 99% of organizations that were surveyed are using certifications to make hiring decisions. 81% are viewing certificate holders associated with increased quality of work and work contribution, and 91% as well believe they are a reliable predictor of a successful employee. So there's a lot of emphasis that's being played in the hiring process and how people are looking for talent to fill these cybersecurity roles. And if we take a look at Cisco certification specifically, 8 out of 10 consider Cisco certified staff to be more knowledgeable and more valuable to their organization than individuals who hold other certifications. They see them as more knowledgeable, valuable, but more responsible, more respected, and more promotable as well too, which I always find to be very important. So that's kind of where Cisco security certifications come in. It's quite the portfolio of different certification offerings. Just to give you an idea, it covers from entry level all the way to expert level. So the CCST is kind of where you kickstart that career and get your introduction into cybersecurity. If you're looking to kind of have something that is complementary to a CCNA, as an example, we have our Cisco Cybersecurity Associate certification, formerly the CyberOps Associate certification. And then we have these professional and expert level certifications as well. And to kind of give you an idea of what the difference is between these two professional ones, why does Cisco have two professional ones? Well, the CCNP one is a bit more focused on network security, and the cybersecurity professional one is more focused on cybersecurity operations, things that would be happening in a SOC as an example. You can kind of see that as well too when we take a look at some of the different types of exam focuses that are in those two exams. So for the professional, you obviously have a core exam, but you also have a concentration exam as well that covers things like forensics and threat hunting. Whereas if you look at the CCNP security, it's a bit more product and technology specific, covering things like firewalls, ICE, web security appliances, VPNs, automation, cloud, etc. We also, though, have the CCIE security focus as well, too, and that's a certification for the ultimate highest level that you can achieve in security from a Cisco certification perspective. And that involves a lab as well, too, as well as one of the core exams. And that's really focused on demonstrating a mastery of the security concepts that Cisco has to offer in their technologies as well, too. So one thing just to quickly note, we did introduce a new concentration exam as well for the CCNP, designing Cisco security infrastructure. Oops, there we go. That's going to be launching on May 20th. So that's going to be an additional option that you can take as you work towards your CCNP for security as well. So what do these different exams cover from the beginner to the expert level? So the CCST I mentioned, that's kind of your introduction into cybersecurity. It doesn't really have a lot of prerequisites. It covers really the core concepts and the basic ideas of cybersecurity. So it might be something like what is malware as an example, and giving you kind of testing that base understanding of those core concepts in cybersecurity. You need to learn some basic troubleshooting principles as well and some initial incident response stuff. But it's a very kind of low-level exam, or I guess kind of high-level, however you think about it. But it's very introductory level. For those who are looking for something, like I said, more comparable to a CCNA exam, we have that Cybersecurity Associate exam. And you can see, compared to the CCST, it's taking it up a notch a little bit. You need to have a mastery of the essential security terminology and concepts, be able to understand and identify attacks, be able to troubleshoot even deeper than the CCST exam. And then we also have that cybersecurity professional, which takes it one step further. This is really all about system security, deep understanding of attack tactics and cloud security as well. It's really kind of taking it to another level. And I'll show you kind of how that fills in with job roles here in a second. But to compare the cybersecurity professional exam a little bit further with the CCNP security, you can see this is taking a bit more of a general cybersecurity operations approach. It's threat analysis, system security, attack tactics. Let's compare that, though, to the CCNP for security. You can see it's a little bit more focused on networking, as well as some Cisco technologies as part of that as well, too. So encryption and VPN, threat vulnerability identification. You're going to do things like email security and traffic management as well. So it goes a bit more heavy on the network side of things compared to what the cybersecurity professional exam does. And if you want to go all out and go for that CCIE in security, it's really all about the deepest level of understanding that you can have in ultimately both of these concepts, the cybersecurity operations side of things as well as the Cisco core technologies. So you'll be in a lab environment working with Cisco technologies, having simulated attacks that are occurring, and you'll need to essentially understand how to contain those attacks, how to leverage APIs and automation to detect and respond to those more effectively, and have a deeper understanding of some of the concepts that were covered in those previous exams as well, such as VPN and identity management as well too. So when it comes to the blue team and the defensive side of things, this is kind of the gambit from entry level to expert. But for red team as well, we do have an offering, and this is an exciting one that I like to talk about. It's the Cisco Certificate in Ethical Hacking. So Network Academy, netacad.com, we have a free, I think it's like a 30, 40, 70, something very long course that we have on ethical hacking. It's free and available to everybody to take that ethical hacking course. All you need to do is sign up for an account on Networking Academy. And when you complete that course, you gain access in Cisco U to the Capture the Flag challenges. That does, unfortunately, have a cost associated with it, but you can take all of the ethical hacking learning for free as well, too. But when you take and complete those Capture the Flag challenges, just one of them, you get a Cisco Certificate in Ethical Hacking, and you have that certificate for life. Cisco U will be regularly publishing new Capture the Flag activities every quarter. We have a new one coming out, I believe, in a couple of weeks as well. So we're going to essentially allow those to have you continuously test and hone in on your skills over time. But this is a great resource. It's free. If you're already doing security and you want to add a red team edge to it, this is a great free resource that you can use. Or if you're new to security and the red team side of things is more exciting to you, free, available, Networking Academy, netacad.com. So when it comes to the different job roles that align with these certifications, let's start with kind of the junior cybersecurity analyst. They're really going to be kind of a 0 to 1 years of experience role in cybersecurity. They're going to be kind of helping with troubleshooting things, understanding, applying those core concepts. It could be a thing like a IT help desk job, cybersecurity support, or cybersecurity specialist. That role, that job role, really aligns with that CCST exam. But as you kind of get more advanced and you do something like the cybersecurity associate exam, maybe you've worked now 1 to 3 years in cybersecurity, you can get a role as like a SOC analyst, security analyst, level 1 type stuff that allows you to really now get in the weeds with data with your organization and be able to detect and monitor attacks as they're occurring in real time. So that's when cybersecurity gets a lot more exciting. That's when you're actually responding to threats and helping secure your organization in a quick and effective way. Now, if you want to take that even further, by the way, if you want to, let's say, go for that cybersecurity professional exam, that's when you're now kind of deciding what the SOC policies are and how the SOC and security operations team can run. So that really demonstrates that you have an understanding of that ability to apply the knowledge that you have to drive security policy in your organization and build an organization that's secure. Now, when it comes to, let's say, the CCNP security, a great job role that aligns with that is a network security engineer. It could also be a cybersecurity engineer. It could be cloud security. It could be a lot of different things depending on what your focus and interest are. But with that CCNP security, you typically need a few more years of experience to get a good qualified role where it becomes applicable. But that's really kind of, if you want to have a stronger network focus or be more product specific, that CCNP security is a great one. It's highly respected. People know the CCNP brand as well. So that's a great certification to have. And when it comes to ethical hacker, you can see as well other aliases for it are penetration tester, to answer again your question earlier, bug bounty hunter. This is where you can now essentially do hacking, but in an ethical way for an organization to identify the vulnerabilities that they might not be aware of that are there, so that way you can fix them before a malicious person does. Oftentimes people are hiring for 1 to 3 years of experience, but like for all these roles, there's such a gap in the market, like I showed you earlier, that sometimes companies make exceptions as well. So it's great to get these skills, it's great to hone in on them and practice them over time. So if you're starting in security, or maybe you have a CCNA already, this is just a good graphic to kind of show you the different routes that many people go on. A great starting point if you're new, like I said, is that CCST. It gives you those core concepts, and then you can pivot really into any direction that you want to go. If you're more interested in the network side, or you want to ultimately get to something where you're managing firewalls, email, VPN, then going down that CCNA to CCNP route is a great way to go. If you want to be more incident response and forensics as an example, the cybersecurity certifications, the associate and the professional, are definitely a good route to go as well too, and that's where you'll be in a SOC responding to incidents in real time. And if you're more excited by ethical hacking and being able to break things instead, then that ethical hacking certificate and becoming a penetration tester is a great option. Just to kind of give you an idea of what some people have said who have completed these certifications, this is a quote from Jenny. She said, "The guidance I gained from earning the certification helped in near real time to determine what's happening on the job." So you don't have to be a security person to have this be relevant and useful to you in your organization or your job function now. If you're a traditional network person, having that security edge will help you be a better network engineer. So it's incredibly valuable and useful skill to have. Now, let's talk about some effective exam preparation. And this is actually largely applicable not just to these cybersecurity exams that we have, but to any of the Cisco certification exams. So for those who are grabbing beer in the back, if you're interested in cybersecurity or any certification, you feel free to jump on in here. So some tips that I have. First, really, and this is an important one, I'm going to dive into this a bit more, is understanding that exam blueprint. There's a lot of hidden details in that exam blueprint, and I'll kind of show you how to decipher that to be as effective as possible when you're preparing for your exam. But use that blueprint to ultimately create a study plan and put weight on the different topics that are very high priority, because those are the ones that are going to be scored and come up more frequently as well. There's a ton of practice exams and labs that are available for you as well. Cisco U is a great resource for that, and I'll talk about that later. But there's also a ton of communities that you can join, including through Cisco U, where you can work with your peers to better understand these concepts and study together. Now, to talk about the exam blueprints, these are available for every Cisco certification exam that's out there. And you can get it on the Cisco Learning Network website. You can go ahead and just kind of click that button down there. From there, there's a PDF option to view those exam blueprints. And when we essentially click on that, there's a couple key pieces of information. You'll see a lot of different sections that look like this. And on its own, this looks almost like a study guide. But there's some important key things to note here. First, the domain. This is going to be the high-level area that the exam's focused on. The domain weight as well is important, because that tells you, in this case, that 20% of this exam is going to cover this particular topic. Now, inside of here, we have tasks as well as subtasks, and these are going to be the different areas of focus that you're going to want to study on. But one very important thing to note are these verbs. Many people overlook these verbs, and these verbs have meaning beyond just being a word here to differentiate each line by line. We call them blueprint verbs, and they really represent the depth of knowledge that is going to be covered for that particular topic. So when you see something that says describe and explain, you're ultimately being asked for a high-level understanding of what that concept is. But as you get further down into these verbs like troubleshoot, identify, analyze, implement, that's going to demonstrate a much deeper understanding of that topic that you're going to need to be effective in passing that exam. So very much take note of the verbs when you're looking at that blueprint, because that's going to help you significantly in building your study plan and knowing where you need to focus and how deep into that topic you need to focus. So, like I said, understand that exam blueprint, use it to create that study plan, focus on those highly weighted topics, use those practice exams as well, and join a study group. And just to kind of give you an idea of some practice exams, I have put together a Slido quiz here for you. Feel free to join. Like I mentioned at the beginning, I do have a prize for those the one person who is going to be at the top of this quiz. So there's going to be 3 questions, and these questions are all similar type questions that you might see in one of the Cisco security certification exams. So they're going to be multiple choice. You'll have about 30 seconds each to answer them. And let's go ahead and begin. So the first question, what is the primary purpose of a security information and event management system in a cybersecurity operations center? So you can see here, oh, sorry, I jumped the gun a little bit. There we go. What is the primary purpose of that security information and event management system, also known as a SIM, in a cybersecurity operations center? So we'll give you about 15 more seconds to answer. It could be number 1, 2, 3, or 4 there. Hopefully this is an easy one. It's going to get a little bit harder, but I wanted to kind of start it off with an easy one to warm you all up here. All right. Everybody got this one right. Good. And that is the correct answer there, to provide real-time analysis of security alerts generated by applications and network hardware. Let's get a little bit more difficult, though. What is the primary goal of a DOS attack? I'm not going to tell you what that acronym is. Hopefully some of you know this already. Again, these are some of the example questions that can come up on one of these certification exams. Maybe not necessarily the CCIE one, but in some of these exams as well. So we got about, all right, everybody's doing really good. I guess it's going to come down to who gets it the fastest. All right, this one might be a little bit more tough. What is the purpose of a DMZ? And we're not talking about the one in the border of North and South Korea. All right. If everybody gets 100%, I'm going to have to make this a lot harder next time. This might come down to who gets it the fastest. All right, people are thinking. 2, 1. All right, tripped you all up a little bit more, but that is the correct answer there, to allow external hosts to access specific company servers while maintaining the security restrictions of the internal network. So those are 3 questions there that you might come across in the practice exams. And Kevin Reynolds, which one is Kevin Reynolds? Kevin Reynolds, awesome. Come find me after this is done. I've got a little something for you. But these are, like I said, some examples of some of those questions that you might see on the cybersecurity associate exam as an example, or the CCST exam as well too. You can find more of these practice exams though for all of these certifications all the way up to the CCNP security and cybersecurity professional on Cisco U. It's the namesake of our beautiful theater here. It's a great learning platform that's available to you. It's free to join. We have a ton of tutorials that are available on there, and we also have premium content that is learning paths tied to every certification that we have pretty much. So you can take a learning path that will guide you from A to Z on how to accomplish and achieve and prepare for a certification. We also have different practice exams throughout the way as well too. So just to kind of give you an idea, this is a screenshot from one of the CCNP security trainings. And we do have hands-on labs as part of that as well too. So you don't need your own ICE deployment as an example. You can spin up these labs and be able to work with ICE directly inside of these labs. So a great resource, I highly recommend it. Well, that concludes the time that we have. Hopefully you still get to hang around here, have some beer, have a stroopwafel, but that's gonna be it for the Cisco U Theater today. Like I mentioned, I highly recommend that you sign up for Cisco U. It's u.cisco.com and it's free to join. And check out some of the different certifications and training tracks that we have on there as well. Not to mention, we also have the Networking Academy. That's where that free ethical hacking course is going to be, and that's netacad.com. So thank you again for your time. A reminder, if you fill out your session surveys, a minimum of 4 of them, you get this awesome limited edition Amsterdam Cisco Live t-shirt for the 40th anniversary, I believe. Yeah, I don't think it says 40 on it, but it has a really cool bike on it. So I highly recommend that you fill out those surveys. Your feedback is always appreciated. And continue your education while you're here as well. We've got plenty of demos over here. You can see my buddy Nick right there if you want to learn more about Splunk as an example. The DevNet zone is a great spot. Check out the World of Solutions, or do a Capture the Flag as well too in our Capture the Flag area. So I want to thank you all again for your time. Feel free to stick around. We've got food and snacks for a happy hour here for another 35 minutes or so. And thank you all.